Hi everyone, welcome to this new video. Today we will be building a Mario-like game in JavaScript using the Kaboom.js library. Without further ado, let's jump right into the game so you can have a taste of what we will be building. So here you have the title and then a menu where you can enter start. You have a screen that tells you what the controls are, and then you can start playing. You can see that you have spiders with enemy AI. You can collect coins, and the goal of the game is to collect all the coins of a given level before you can proceed on to the next one. So here I collect the coins. You'll see fish that go up and down. All of this, we're going to build it in this course. So you can have one-way collisions. I can collect the coins here, and here's the second level where there are a bunch of spiders, and now we have added axes that swing. All of this, all the sounds as well, we're going to add this into the game. So let me just complete my game just to show you, to give you a full overview of what we're going to build in this tutorial. So if I just collect the coins here, and we're also going to add another saws. We're going to add saws or saw to the game with this weird noise, this strong annoying noise. Should have lowered the volume. And then finally the third and last level is this level where in the sky you have to pass in and avoid the birds that can kill you in one shot. So that's basically the game we're going to build. So let's get right into it. I have an empty folder here, and we're going to create a bunch of folders that are going to be needed for this project. The first folder I want you to create is the assets folder. Once this folder is created, we're going to bring in all the assets of needed for our game inside our folder. So in the description, I'll put a link of all the assets you're going to need for this project, and I'm just going to copy and paste over all of those. So give me a second here. I'm just selecting them all manually. And also there is a font that you need to use as well, which is called Around 9x13. So I'm just gonna take all the files and then drag and drop them into my project. So here are all the assets we need. Now we also need, whoops, I think instead of dropping them in the correct place, I'm gonna undo this, and I'm going to drag it inside the folder. Now if I close the folder, all is good. Now the next thing I want to do is to create another folder, and this is for our sounds. And I'm just gonna put this here, and here again I've collected a bunch of sounds from freesound.org. Again, the link to download all of these assets are going to be in the description below. Yeah, I copied this twice, so I need to remove that. So we have all of our sounds here. Now what we're going to need also is a bunch of other folders, and I'm going to go over them. The first folder we're going to need here is a content folder. This folder is where we're going to write basically the layout of our level. I'm going to go over this much more later on. The second folder we need here is the libs folder. We're using the Kaboom.js library for making games, and usually can use a CDN, which is just a link, but I prefer to download those libraries as a .mjs file, and as you can see here, have a copy of the library on my computer, on my server, so that in the future, if somehow the Kaboom CDN is no longer available, then your game will still work. Again, here I'm going to put a link to the description. By the way, we're using the Kaboom 3000 version. So for all of these assets that were imported, I have a link for all of them. Now, what I'm going to do is create another folder, not here, right below, an entities folder. This is where we're going to put the code for the various entities like fish, spiders, the player, etc. And finally, we're going to have a folder called utils. And this is for everything that does not fit in the other folders. So now I think we're almost ready. What we need with all JavaScript games is an index.html file. And within that JavaScript file, we're just going to have it really simple. An HTML tag and then a body tag. And then I'm just going to collapse this so you can see better. And then here, there's one thing very important, is that the script tag. This is the script tag you need. So it needs to be of the type module so that we can use import statements. So you can import from other files. And we need the source to be the main.js file, a file that we haven't created yet. So yeah, let's get right into that. So I'm going to go back here, right below the index.html, or right above. I'm going to create a main.js file. Now, in this main.js file is where we're going to import Kaboom. So I'm going to import Kaboom from, and then here we're going to import it from the libs folder, and then kaboom.mjs. And this will give us access to the Kaboom library. Now we need to set up our screen. So to do something like that, I'm going to write Kaboom, which is a function that initiates the canvas. So this is provided by the Kaboom library. It takes in an object as the param, and in that object you can specify a variety of properties. So here we have the width property, the height property, the letterbox property. This property basically makes sure that when the user will resize the project, the canvas, their browser window, then we're going to preserve the aspect ratio. So this is the only thing we need for now. And to test that everything is working as intended, I'm going to click on the Go Live button here. So you might not have this because this is an extension. You need to install the Live Server extension. So going to the Marketplace, Live Server, this one, and then if I just collapse this, you click on the Install button. Here it's written uninstalled because I have it already installed. So what I'm going to do now is I'm going to click on the Go Live button, and a browser tab should open. And you can see that we have a checkered board, which is basically our canvas. So now that we know for sure that it works, we can really start working on our project. So let's get right into it. Now that we have the Kaboom.js library, we're going to build our scenes. So this is a scene in Kaboom.js is basically a screen, so you can move from one scene to another, and it's going to be very helpful because we need a menu, and then from the menu we need to go to the controls menu, and then from the controls menu we go to the actual first level. When the first level is completed, we move on to the second level, etc. So to do something like that, we simply going to create an object, and this object is going to contain our scenes. So I'm going to call it scenes, and I'm going to leave it like that. So this object is going to contain a bunch of keys. So for example, the menu key here, and we're going to return a function. Here it's an arrow function, and within this arrow function we will write the code required for our scene. Now in Kaboom.js, to display a scene, to create a scene, you need to use the scene function. However, one issue with this is that the reason I'm using an object is to have much cleaner code. So what I mean by this is that if I go above and create a second key, and I'm going to call it controls, this is for the controls menu. I'm going to again create an object. Alright, so now what I'm going to try to do here is I have the control scene, the menu scene. Those are just keys that points towards function. There aren't yet scenes. In Kaboom.js, to create a scene, like I mentioned, you need to use the scene function. However, because we have those many scenes, what I'm going to do is I'm going to use a for loop. And this for loop is going to take a const scene of, well, actually maybe to not conflict with the scene function from Kaboom, I'm going to simply use key instead. So for key in instead of, so it's going to give us all the keys of our scenes object. And then within the for loop, here we're going to call the scene function that is from Kaboom. So this scene function, what it takes is, as the first param is the name of that scene, and this is where we're going to pass the key. And as the second param, you need to pass in a function, a callback, and we're going to pass in this function. And so to get this function from the scenes object, you need to pass in the key here. So I'm going to pass in the key so I can get the function. This is just a cleaner way to set up your scenes. Otherwise, you would manually call scene, for example here, the name, for example menu, and then put as the second param a callback, a function. So this is how you would normally do it. Now here it isn't detected. You cannot find scene, any name, etc. Well, you can ignore this because this is just VS Code that doesn't know that we have this. This is just a global function from Kaboom, so VS Code isn't aware of it. So that's why it's not working. I'm using a simple HTML JavaScript setup, but if you use something like Vite, you can import Kaboom using npm install and have all of these defined. So yeah. Now that we have all of this, so we have this with our scenes, what we need is to actually test that our scenes are actually created correctly. So here I'm just going to create 2 more scenes, or actually 4 or 5 more scenes though. So the first level can be just the 1 key like that. Then I'm going to create a level 2 scene. Then I'm going to create level 3, etc. So here as well. So we have both 1, 2, and 3. So 3 levels for this tutorial. Then we have also, we are going to need a GameOver screen scene. So GameOver as well. Again, an empty function. And finally, an end scene. So when the game ends, we're going to congratulate the user. So just to one thing before any of this works is that Kabooms require that you specify a default scene, and this can be specified by calling the go function and passing in the name of the key, the scene you want to pass in. So this needs to run first, this whole block, where the scene object, the scene function creates the scenes by passing in this key so that you can refer to them in the go functions. So if you were to remove this, passing in menu will not work because the scene was not initialized. This whole object we're creating here is just for organizational purposes, for making our code cleaner. So I'm gonna just pass in the menu scene here. And to test that it works, because now if I look at the browser tab, nothing happens, and it's normal because we have nothing in our scene. So what I'm going to do now is I'm going to use one of the main functions of Kaboom, which is called the add function. Not add event listener. And this add function takes in an array of components, and those components in Kaboom.js are used to create your game objects. So here I want some text. I'm going to use the text component. All these components come from the Kaboom.js library. And if you want to learn more about Kaboom.js, you go to kaboomjs.com and you have the list of the components you can use. And this is what makes Kaboom.js really easy to use. It's just a bunch of functions that you can call. So here I'm going to call the text component, and I'm just going to type in test. If I go back to the browser, you can see at the top corner that there is a white test. Now, one thing that is is amazing with Kaboom is that for position, you pass in the positional component, and in there you can pass in some values. So for example, 500 x value by 500 y value. If I pass this here and I look, you can see that the text has moved over here. You have a bunch of other components like the color component. If I pass in the color, I want my text to be black, so RGB can be specified here. You can also specify hexadecimal values. So yeah, that's nice as well. Now you can see that the text is now black. So this is how you deal with text. All right. Now I'm going to remove this line of code because it isn't really necessary. So let's do that. So now what we need to do is to actually create our menu, and I'm going to use in this tutorial object-oriented programming because I think it's really helpful when it comes to isolating states and yeah, basically putting code in self-contained reusable blocks. So I'm gonna, in the utils folder, create a UI.js class. And this UI.js class, I'm going to export this class. Well, actually, yeah, I'm not going to export this class. It's going to be a singleton. That means it's one class that is instantiated for anyone. So we only instantiate this class once. If you don't know what I mean, you're going to see it really soon, and it's going to be much more straightforward. So let's get right into it. So I have this class UI and we want to make a bunch of methods available. What I'm going to do now is well, actually we should call this UI manager instead of just UI. It's more descriptive and a better name. So I'm going to call this UI manager, and here I'm going to also call it as a UI manager. And we don't need to specify a constructor because we aren't interested in constructing anything. What we want is just make a bunch of similarly themed methods available from this object. So here, and share state, but I don't think we're going to need to do that. But anyway, later on we'll be making entities, and you're going to see the benefits of going with the object-oriented approach. And when I'm talking about object-oriented, we're not going to do any inheritance or stuff like that because it's not needed. So yeah, Kaboom.js by default isn't a object-oriented library, so you just call functions, and most of the time it's just easier to just call functions and make your game that way. But when you reach a certain size, it becomes messy. So having object classes like that to really capture state and silo off certain parts of your code base is a good approach, I have found. So that's why I'm using it for this project. By the way, if you want to see the final code, you can see it on GitHub. In the link in the description below, you'll find whatever you need, the actual repo. So here I'm going to create a function, or actually a method, called display main menu. And this display main menu, what it will do is we're simply going to draw our sprite. So we're going to draw a background, so the forest background, and then draw the logo of our game, and then write some text. But you see here, there's a bunch of things that we need. We cannot load sprites yet because we haven't written any logic to load images in our game. So how do we achieve something like that? Well, first of all, let's create a loader. So I'm gonna again go to the utils.js, create a loader.js. And this is really, we don't need anything much more than just a function. So, well, an object that contains a function. Well, just to be consistent, I guess, we can create a class, call it loader. But yeah, that would be over-engineering. Let's just create an export const load. And then within that object, we're just going to have a fonts property, which returns a function. And this function will load the font. And the font is called round, and the path to it should be, I think the path, not quite sure. I need to look into this real quick. So the path is, of course, in our assets folder, and then round 9x13.ttf. So that's the, yeah. Now I'm going to create another property. This time it's our assets. And I'm not going to load every asset now, because I think we're just going to load the assets when we need them. So yeah, I do not consider fonts as assets, but technically they are, but it's just a different kind of asset. So this should have been made maybe images, but it doesn't matter in the long run. So what I'm going to do here, I'm simply going to load, called the load sprite function. And this load sprite function is a function from Kaboom.js. It takes in the name of the sprite and the, well, actually the key you want to refer to for the sprite. So later on, when you're going to use the sprite component, you want to use that key, the name you decided for that resources, so that you can refer to it. So you can say to the sprite component, display this image. So here we want the forest background. So I decided on the name. This is the name I want to use to refer to this sprite. And I'm going to specify as a second param the path to the sprite. So to do something like that, I'm just going to so let me just find this, the path. I'm just going to copy paste it instead of writing it out. So I'm going to do something like that, and I'm just going to type in asset slash forest background 0. This is the name of the resource. So now we have the load sprite. Yeah, so we have this sprite loaded and can be referred to by this name. Now if I go back to the UI manager, what I'm going to do, I'm going to use the add function. So the add function, you can think of it as a way to create game objects that are going to be displayed on the screen. So again, the add function takes in an array, and within this array, I'm going to, alright, so to display a sprite, you use the sprite component within the add function. And you pass in the name of the sprite you want to display. And here, as I told you earlier on, it's the forest background. Now, we also need a bunch of other components, and I usually prefer to put this on a second line, like that, and then pass in the second component we need, and we need the scale component. Well, before using the scale component, let's just look at what we have as a result. So I'm going to go back to, whoops, I haven't called the function, the method, so that's why. So first, we have our class UI manager. We're going to export const UI manager, and here we're going to use the new keyword UI manager. So this is how we're going to do it. Now I'm going to go to main.js and I'm going to import it. So I should be able to simply use it from here and then .display menu and call the function that way. Now you can see that it added, VS Code added automatically the import statement, but you have to be wary about one thing, is that you have to have a .js, otherwise you'll have a MIME type error. So let's look into it. You see my tab became blank, and inside it says, well, actually it's in French, sorry, I should have changed my computer to English. What it says here is that it was blocked. Well, the loading of the module UI manager was blocked because of an illegal MIME type of text/HTML. So that's why you need to specify that this is a .js file, so that it knows that it's some JavaScript to be loaded. So if I go back, it says to me that the sprite is not found because we haven't called the loader function. So here, right above where we define the scenes and right below the Kaboom instance, we're going to use the load object that we created from the utils folder. And this time you see it adds the .js. So I think once you add it once to one other import statement, it does this naturally. So yeah, so this load dot assets, and then you call this function, and this basically loads the assets. So the way it's structured here is that it looks intuitive. So once you have this done, the assets are loaded, whatever they are. And then in the menu scene, we're calling the UI manager to display the main menu for us. So now, of course, remember that we have at line 41, we have the Go menu. So what I'm going to do here is you can see that the background appears here. However, it's way too short, and we needed to cover the whole screen. So I'm going to go back to the project, and I'm going to go back to the UI manager, and then specifically here, I'm going to add a scale component. This is another component provided by Kaboom.js that basically allows you to scale a game object to a certain level. So here I want to scale it 4 times. And if I go back to the browser tab, you'll see that it's going to take the whole, the whole screen, the whole resolution. So that's what we want. Now the next thing we need to do is to display the logo of the game. And here again, it's the same process. We need to go back to our loader, add the asset for it. So I'm just gonna create a new line. All right, load. We're gonna call it load sprite, and then call it logo, and then the path for it. I don't have it from the top of my mind, so let me just find it real quick. So if I look it up, the logo is under dot assets slash logo capital L dot png. Then I go back to the UI manager. I go back within the display main menu function, and then I'm going to create another game object right below. I'm gonna use the sprite component by telling Kaboom to display the logo sprite here. I'm gonna also use the area component. The reason I'm using the area component here, and it's another component provided by Kaboom, is that it will create a hitbox over the game object you've just created automatically. But one of the main benefits is that it allows you to use the anchor component, and the anchor component, again, coming from Kaboom again, I said again 2 times. Well, inside of it, it takes in a string where you can specify from which the game object is going to be drawn. By default, game objects are drawn from the top left corner, but we want here that the logo be drawn from the center. So that's why I'm using the area component, because without the area component, you cannot use the anchor component. But the area component is useful for having a hitbox over your game object, which is useful for detecting collisions, for example. So now I'm going to use the pause component, which allows you to specify where the game object is going to be placed. Here in the first one, we didn't need to put the position because by default it's set at 0, 0. And because we want the forest background to take over the whole screen, we didn't really need to modify the default position. However, here we absolutely want our logo to be at the center of the screen. So how do we achieve this? Kaboom has another component, well, actually it's a function that returns a vector 2. So it's basically a vector contains x and y values, basically tells you the coordinates of where the center of the canvas is. So you call the center function here, you do a dot x to access the x property, and then you call it again for the y coordinate. And here we don't want the logo to be actually in the center on the y axis. We want it to be a bit at the top. So I'm just going to save it like that. I'm going to go here. You can see that it's super small and it is at the center. It's not what we want. But before changing the y value of the position, I'm just going to scale. I'm just going to scale it again. So I'm going to do 8 as of the scale. If I go back, you can see that the logo is looking pretty good. However, It's really at the center, and we want to basically display a message below to tell the player to press enter to start the game. Alright, so what are we going to do here? So it's simple. We're just gonna subtract 200 pixels to the Y value of the center, so that the logo goes up. Just so that you understand, I'm just gonna pull out Excalidraw real quick. So this is Excalidraw, just a drawing application. In game development, usually, let's say you have this is your canvas. Now you have the Y-axis that is like that, and the X-axis that goes like that. So the more you increase the value of Y, the more your coordinate goes down, and the more you subtract, you go up. So this is something that might not be intuitive if you're not familiar with game dev, or you're just coming from a math class. Usually in the math class, the diagram is taught by looking at this quadrant on the right here. So I'm just gonna do this real quick. So you have the Y-axis, and the more you go up, the higher the value of Y. So let's say here the value is 10, and then here it would be Y equal, I guess 5. Well, actually it looks much smaller than 5, so 2. And here Y would be equal to 5, and then here it would be Y equal to 200. So the more you subtract, the farther up you go in the canvas. So hope that was clear, and so that's why we subtract by 200. So if I go back to the project, we have the add function here. That's good. I'm going to, so we have this. Now we need a bunch of other stuff. We need to add a message that tells the player to press enter to start the game. And to have something like that, I'm just going to create another method in the UI manager, and I'm going to call it display blinking UI message. And the reason I'm creating this is, in games, when in the title screen a message fades in, fades out, and it looks like it's blinking, this is what the effect we want to achieve here. So what I'm going to do, I'm going to create a content param, which is going to be the content we want to pass in to that message. So the actual content of the message we want to display. And then at the second param, I'm going to pass in the position. So here is the position. And now we need to actually write all of these logic to display. So what I'm going to do is I'm going to create a constant. And this constant, one thing that is going to be pretty new is that I've used previously the add function to create game objects, but this add function actually returns the game object, so you can store it in a constant or variable, which makes it handy later on if you want to add stuff, because those game objects have methods you can use, and depending on the situation, which helps you with creating your game. So what I'm going to do now, I'm going to use the add function, again pass in an array, and then use the text component, and pass in the content here as the param to the text component. Now, one thing that is you can do with the text component is it can take optionally a second param, which is an object, and this object you can specify, for example, the size of the text. You can also specify the font, and here we're going to specify the round font. So round font that we have loaded. We haven't loaded this yet, so let's do it quickly. So in main, I'm just going to call load.fonts. We only have one, so in case you wanted more. So having called this, we can simply make sure that the font is loaded before we call this display blinking message. So once this component has been added, the text component with the optional object that specifies some options like the size and the actual font you want to use, we're going to add an area component, and for the same reasons we did for the background, because we for the logo, because we want the anchor, so the origin of where the text is going to be drawn, we want it to be drawn from the center. So I'm just gonna say center here. The position is going to be whatever the position the user of the function display blinking UI message is. And finally, the opacity. We need the opacity component. For now, this does nothing, but it's going to come. Is going to be handy earlier because it will allow you to modify the opacity of the game object we're currently creating, which is the message. So what I'm going to do is just keep it as is. Just again, the opacity component is from Kaboom.js. So when I mention component, they usually all come from the Kaboom.js library. So here again, we're going to use the state component, and I'm going to create some states. So I'm going to create the first state, the first param of the state component is the default state. And then as the second param, you pass in an array of states you want. And this is going to come handy because we want to basically create a state machine. So we want the message game object to do something when it enters the flash up state, and then we want it to transition to another state and do something else, etc. And this will allow us to have the blinking effect. So I'm going to pass in the flash up string here, and then I'm going to also create a second state here, which is the flash down. So as you've noticed, you have to pass into the array the state you have specified as the first param, because the first param of the state component only tells you if what is the initial state, and not all the states, and does not add any new states. So here we have flash up and flash down as our states that we want for our state machine. All right, hope all of this was clear. If it isn't, it's going to hopefully become clearer sooner. So I'm going to create, so here I'm going to use the constant in which I have stored my game object. I'm going to do the dot and have access to the on state enter property. And the reason I have access to this property is simply because I have used this state component. And then as the first param of this method, it is the flash. Yeah, so it's a method, not a property. So because I have used the state component while creating my game object, I now get to use this method. If you were to not use this, you wouldn't be able to have this working. So here I'm just gonna specify the logic. So on state enter, what it does is it takes in as the first param the name of the state to listen on. So here it's the flash up state. And as the second param, it takes in a callback, which is a function that is going to be run or ran when the message game object enters this state. So by default, the message game object is going to enter the flash dash up state, and this function here that we're going to fill in is going to run. We need it to be an async function because we're going to use async await inside. You're going to see in a moment. All right, so what happens here? Well, we're going to use tweens. So tweening is a component. The tween component in Kaboom.js allows you to gradually, smoothly change the value of something to another. And it can follow a function, a mathematical function, which gives us a bunch of effects, like a fade away, fade in, and allows you basically to animate. So I'm going to use this. So to use the tween function in Kaboom.js, you need to use the await keyword here. Well, actually, you don't need, but the reason we're using the await keyword is because of the property of asynchronous JavaScript. So let me explain. Here we want the tween to happen, so the transition from one value to happen, before we move on with anything else. If you were to not use the tween function here, whatever code you write here is going to be executed even if the tween has not finished. So by having an await, we're basically waiting for the tween to finish before proceeding on with the code execution that comes afterwards. So this is why we need the tween, the await keyword near the tween. But you can use the tween without the await keyword. But keep in mind that if you do this, then your code will continue to execute even though the tween has not finished. And we want this tween to basically take our text and make it from fully opaque, so full visibility, to 0 opacity, so that it disappears, and then we enter another state to do the reverse. And this gives us the blinking effect. So let's do just that. So the tween function, so the tween function takes a bunch of params. The first one is the actual starting value. And here again, I'm going to use the game object, the message game object. And because I use the opacity component, I have access to the opacity property. This is something specific to the opacity component. So it's just because I used it while creating my game object that I have access now to this property. If you were to not use this or use another game object, you will not have access to this. So I pass in the opacity, the current opacity of the message game object. And then I need to pass in a target value, and we want the opacity to go to 0. The third param is the timing. In how much time do you want the opacity of the message to go from 1 to 0? Because by default, when it's fully visible, message.opacity should be 1. And we want it to reduce to 0. And we want this to happen in 0.5 seconds. And then the fourth param is a function that is called every time the value is changed. So it takes in as the param the current opacity at the current moment, and then we will simply pass in this opacity and set the new opacity to being that opacity. I'm gonna explain much further. So here it is, opacity equal message dot opacity equal opacity. So the reason we were doing this is that this opacity here is going to gradually change from 1 to 0.8, 0.5, 0.6, etc. And as soon as it changes, this function is run, and you pass in the value for it, and we simply use the fact that we have access to the opacity property to set the new opacity to being that of the message opacity. So to explain further, I'm going to pull out Excalidraw again. I think making diagrams is a really good way to explain things. And so I'm just going to clear. So just to make you understand what this function does, is that so we have 0.5 second. So from, let's say we have this timeline, and we have the value 0, which is 0 seconds, and then we have the 0.5. So let's say that t is equal to 0.5, and then here t is equal to 0. So what we have here is, as time progresses, the value of opacity, so let's say at it's the reverse. At this instance, at time equals 0, the value of opacity, we want it to be equal to 1. It's currently equal to 1. And as it changes, as this moves, this opacity should change as well. So if I just copy this quickly, okay, at this point maybe it's at 0.75, but this setup, this change of value isn't going to happen automatically. We have to set the opacity value. So if I go back to the code, what you see here is this function. You could say that you could call this next value, next opacity value. And then here we set the opacity of the message object to being the next opacity value. So hope this was clear. Yeah, so I hope this was clear. If I go back to the drawing, you can see that what is varying is not the opacity, the message.opacity, but it is this value, next value opacity that is varying, and we need to do the job of setting this value to being the value of the opacity. So hope this was clear. So let's continue. So now what we need to do, we need a fifth param, which basically tells us how frequently this function that we passed in that contains the next opacity value is going to be called. And Kaboom offers you a bunch of easings, which are basically mathematical functions that will call this function at a certain rate. So here we're just going to go with linear. So that means at a regular interval, this function is called. You have ease in sign, ease out sign as well, and a bunch of others. Depending on the situation, you use different functions to achieve different animated effects. And for example, for having a bounce in, yeah, there is a function for that as well. So that's basically it. Now what we need to finish our code here is, once this await is done, this tween is done, we're simply going to move on to the next state. And we're going to move on by using the enter state function method that is again provided because you use the state component here. If you were to not use that, then this would not work. So here in the enter state, I'm gonna pass in the name of the state we want to enter in, and that's basically it. Now we need to do the exact same thing but in the reverse. So I'm gonna copy this and just paste it over. I'm gonna change the name of the state, the logic, and here instead of 0 is going to be 1. So we want our message opacity that is currently 0 because it was changed to 0 in the previous state to re-become 1 at a similar pace. And that's basically it. And then we want here that after having done this, we enter the flash up state. All right, so let's test everything out. So let's call this function here. So in our display main menu, because it's part of the main menu, we're going to add a message that tells the player to simply start the game by pressing enter. So I'm just going to call this. But this keyword allows us to access other methods in the class and the properties of the class. So that's pretty handy. So display blinking UI message. And here I'm gonna, as the first param, enter this message, press enter to start game. And as the second param, I'm gonna pass a vector 2. So the position is really an XY coordinate, and the way you pass in a position as a param is by using the vector 2 function here. So the reason you cannot specify just X and Y value, for example here, we're passing to the pos component, a position which has to be a vector 2. Otherwise you would have to have a pos X, pos Y, and do position X and then position Y, but you would need two params instead of two params here instead of just one. So that's less handy. So by using the vector 2, this is not a JavaScript feature. This is a feature from Kaboom. It offers you the ability to create vector 2s. So in there, I'm just gonna pass in. We want this text to be at the center. So I'm gonna use center X and then center Y as the Y coordinate, but we want to add 100 so that it is right below the logo. So if you remember, the more you add of the Y value, the more the game object will go down. The less you add or you subtract, the more you subtract, the more your game object goes up in the canvas. So let's look at the result of what we have here. I'm gonna go over here, and you can see we have a blinking message that tells you to press enter to start the game, and that's awesome. And we simply want now to change the scene, to go to the next scene when the player press enters. And Kaboom.js offers a bunch of functions, event listener they are called, to do that. So let's use that. So what we want here is to use the on-key press event listener. This is offered by Kaboom, so don't mistake this for a normal web API. The first param it takes is the key, and here we want the enter key. And the second param is the function to run when the enter key, or when the key here specified as the first param, is ran. So here what we want is simply to go, to go to the controls scene that we created early on, which is empty for now. But let's try it out. If I open the game and I press enter, I'm brought into the next scene, which is just an empty checkered board. So at least it works. Now what I'm going to do is that we would like to have sound. Yeah, so we would like to have sound when the player press enters. And I think I've brought the sounds here. So we're just going to use this confirm-ui.wav sound effect that we're going to play when the player presses enter. So to do something like that, we're going to go to our loader. And if you remember, we need to create well, actually we didn't do it. So let's create a third property here that returns a function. And to load a sound, you simply call the load sound function. You pass in the name you want to refer to the sound to. And here it's just confirm-ui. And then the path of that sound, and it's under the ./sounds/confirm-ui.wav. So now this is how we have loaded it. But of course, don't remember, we need to load it in our main here. So I'm just going to do load. Yeah, after the assets, it doesn't matter. Yeah, maybe I'm tempted to put it before, but it shouldn't matter. So let's load the fonts, then the sounds, then the assets, from the least heavy to the most heavy. I think that makes sense. All right, so if I click, we haven't played the sound. We haven't written the logic to actually play the sound. So we need to go back to the UI manager, and right before going over at line 58, I'm gonna do play, not plugin array. Yeah, my VS Code recommends weird things sometimes. We're going to play the confirm UI. Remember, when we loaded the assets, the sounds, I specified that the name I wanted to use to refer to that sound was confirm-ui. And by using the play function, you can have it here. And now what's cool with the play function here that allows you to play sounds is that you can pass in as a second param an object where you can specify a bunch of things. You're going to see in this tutorial, this course, a lot of things that you can do. But for now, we're just going to set the speed to being of 1.5. The reason being that this is what sounded good. Now, I'm going to go to the browser tab, and we should be hearing something when I'm going to press enter. Have you heard? This is I actually need to test if you've heard. Just gonna increase the volume of the computer, and then have you heard? There is a slight delay, and the reason there is this delay is due to the browser, I think, which does not give you the permission here to immediately play the sound. So when we're going to replay the sound in another menu, in the controls menu, when we move on to the actual game, then the sound is going to be pretty in sync. And I don't think there is much I can do for this first sound of the game. So that's the menu, and yeah, so there's still many more things to implement. So let's get right into it. The next thing I wanted to implement is the controls menu. And we're going to just create a another method for this. So we have the display main menu, and right below in the UI manager, we're going to have the display controls menu. And inside of it, as the first thing, we're just gonna display the same sprite here. Where is it? The forest background. Just gonna copy over this. If you see yourself copy pasting this too much, make a reusable function. This is good coding practice. But for the time being, there is no need for that. All right, so we have this. I'm also going to add a control indication, so just a message telling the controls. So here no new concepts are there. You have the text component, you have the text within it, the font is round, the size is 50 this time around. We use the area component to have access to the anchor component so we can center our text, and then we have a position that we which basically the same as the logo. So that's that. And yeah, so let's test this out. And it's not finished because we're going to display controller prompt, not keyboard prompts, so that the user knows how to play the game before they are brought to the first level. And then after that, we're going to work on actually building that first level. Okay, so let's test this out. Let's go to main, and then here we're just gonna call the UI manager and just call the display controls menu function. So now if we go back to the game and I press enter, I'm brought to the controls menu and it looks good. Now in the assets that I've linked in the description, there's a bunch of assets regarding controller prompts. So if I go back here, you have the arrow down key D. Wait, if I could expand this, that would be great. It doesn't seem I can expand this, unfortunately. But here you have arrow underscore down key dark, arrow left key dark, etc. So if you haven't already put that into the assets folder, there's also the space key that is here. So this is basically the only thing we need from that pack of controllers prompts that is available to download in the description. Just take those assets because we aren't going to use everything. And also for the actual game assets, there are plenty of assets that we aren't going to use. You can feel free to remove them after the project is done, so that you can really know which was necessary and which wasn't. And yeah, so instead of going through each of them and really selecting, yeah, it's a much better approach. All right, so we have our assets. We need to load them though. So to load them, again, it's the same logic. This time around, I'm just gonna put it here, and I'm just gonna copy paste it instead of writing it manually. So because it's tedious to do it manually, you have to do it manually, or you could go into the description and look at the final completed project and just go to the file for that. So here it is. Let me just fix the formatting a bit. So we have the load sprite and then the path for each. You can feel free to pause here so that you can take note of all of these paths. All right, so we have this loaded. I'm just gonna maybe leave a space here. And then here in the UI manager, we're going to add those prompts. And this is where we're going to learn a new concept, the concept of children in Kaboom.js. So Kaboom.js has this option, this concept of having child components. What I'm going to do here, I'm going to create a constant, call it control prompts. I should have called it controller prompts, but anyway. So you have this, and we're simply going to create an empty game object with just one component. So it's not a visual component. It's not going to appear visually. We're just going to have a position, which is the center dot x plus 30 and then center dot y as the y value, y coordinate for this positional component. Now if you look at the game, nothing is going to be visible, but what is cool now is we're going to be able to add to that controller prompts game object that is centered here a bunch of other visible game object as a child of this game object. So to do something like that, you just take in, you just write the name of the, you just take where you have stored the game object. In this case, we stored the game object into the control prompts, and then this gives us access for each game object. You have access to the add method, not function. The add function is general. It allows you to create game objects. The add method to a game object allows you to add a child game component, game object, to the object, the game object. So while they work the same, the game object is added in different places as a child of another game object, as opposed to a game object that is added to the canvas in general. So what I'm going to do here, I'm going to have a sprite, and as you have seen in the loader, this is the name up, down, left, right for our various keys, and the space key as well. So this is where those names are coming from. And then right below, I'm going to have a positional. So 0 as the x value, minus 80 as the y value. And the values here are relative to the position of the parent. So it will first center these game object the same way as the parent are, and then adds any x and y value here as an offset from the parent. So it's relative to the parent. So now if I go to the game itself and press enter, nothing happens. Maybe I did not save. Oh, actually, maybe I just did not save. Okay, if I go, all right, you can see the up key that appears here. Now I'm going to do the same thing for the other child components. I'm going to add the sprite down as another child of the controller. So a single game object can have multiple childs. And here we just need to pass in the sprite we want as the initial centering that is done. So 0, 0 offset looked good. So if you look here, press enter, you can see it's right below by default, so no need to change it. Now, I think you have probably, you got what it needs to be done here. So I'm just going to paste over the code here. So here we have the left, this is the position, right, this, and space here. So we should have all of our keys. And again, if you want to just copy paste this part, you can go to the GitHub repo and to the UI manager file, so you can find it really quickly. All right, so here it is. I think maybe, yeah, that's what I wanted to say. I think I'm going to show you how you can easily reference the actual repo on VS Code, on GitHub, I mean. So here I have the repo, the actual repo. It's public, so you can have access to it. If you press the dot key, it's going to open a web editor, a VS Code instance. And this seems to be only working on Chromium-based browsers. It doesn't work on Firefox. So here you have access to the whole code base, and you can use the search tool here and immediately search UI manager. Or actually, not even that. You do Control P or Command P if you're a Mac. UI manager, you can easily find a file right here and there. And then you can simply go to here and you can see the code for the keys. You can just copy and paste it. So this is how you would do it. Okay, now that I've gone over this, I'm going to simply continue working on the project. So let's look at the actual results. So if you press enter, you can see all of the keys. Now we want some indication, some text to tell you that what each button does. So directional arrow to move and space to jump. So just some text here to display would be good. And then we're going to also add the blinking message telling the player to press enter to move on to the actual game. So what I'm going to do now is I'm going to add the following. So I'm going to again copy paste this because I think the concepts are understood. So here we just want to display some text called jump with this position and this size. You can feel free to pause to copy this. I'm trying to put my VS Code as big as possible because I think that some of you might watch this video on a smaller screen. So that's why the disadvantage of that is I cannot show you everything here at once. So maybe I should maybe try diminishing like that. So yeah, now you can copy. It should look much clearer. So I'm gonna go back to being big so that I don't have to do a lot of editing to make it visible. So this is the jump text, and then finally we need also the move text as well. So I'm gonna paste this as well, fix the formatting, and here again the values size 32. The only thing that changes between the two is the position, and those positions I came up with them experimentally. So I thought these value looked good because the text was relatively centered right under the space key. And instead of me describing you this, let's just look into it. So I press enter and you can see jump and move pretty much centered right below their key prompts. So that looks good. And now the only thing left for this scene is to display the UI blinking message. And this, we're just going to basically do the exact same thing. We call the this.display blinking message with this exact same text, and as the vector2 for the position, the only thing that changes is, I think, yeah, instead of adding 100, we add it at 300, so the text is even a bit more downward. That's the only changes. And then if I let's look at the result. So I press enter. You have the press enter to start the game here, but nothing happens when you press enter because we need to add an event listener again here. So just to recap, here we are in the display controls menu method within the UI manager, and yep. So finally, I'm just gonna, again, this is the exact same logic than the display blinking UI, than the actual main menu. The only difference is that instead of going to the controls menu, we go to the scene number 1. So if you have a number as the name of the key, you don't need to put a string. I also think that we could do the same for the menu. So let's try it out. So if I go upward here, if I were to just put in controls, I'm not sure it would work because it's a name, yeah. While with a number, well, it's a number, it's a data type. So you could put either 1 here, or you could put here and it would work the same. All right, let's test this out. So I'm going to press enter. I'm going to press enter again, and we have arrived to the actual real game. And now it's time to finally make the first level, and by extension, to develop the platform, the actual players, game object, so they can move around and think about the camera and stuff like that. So let's take it one step at a time. Let's work on displaying the level. So to do something like that, in the utils folder, I'm going to create a level.js class, which will contain a bunch of methods useful for drawing levels on the screen. In addition, we'll use the content folder to specify certain things regarding the first level. So let's get right into that. So I'm going to simply export. So I'm going to write export class level. this class is intended to be used outside of this file as much as we need to draw levels. So the first thing we need first is to add a draw background methods. As you may have noticed, the background we drew in the menu is actually going to be the background of our first level. And here I'm just creating a reusable utility to draw is a background sprite. And to do so, simply add the sprite component with the passed in sprite name. I'm gonna remove this to have a bit more estate. And then I'm going to use the fixed component, and this is important. The reason I'm using the fixed component is that when we're going to implement the camera, we absolutely need the background to remain in place. Otherwise, it will move with the camera or be affected by the camera, so that when the player start moving left, then the canvas, the background, will disappear as the player is progressing to the right, for example, or left. So by having a fixed component here, it basically tells this game object to not be affected by the camera. But this again is a bit too advanced for now because we haven't implemented a camera, but just keep it here so that we will not be surprised later on. And of course we need to scale this 4 times so that it fills the whole canvas. After having created the draw background method, we're just going to create the draw map layout method. And yeah, so let's first do that. So we will take in as a param a level layout and then what I call mappings. So without giving you background info on Kaboom.js, you might not understand why we need this. Usually when you want to draw a level in other game engines or libraries, you usually use an external software like Tiled. However, we cannot do that with Kaboom.js. The way Kaboom.js displays levels is by using an array of strings, where you map out each character to a given sprite or game object that is drawn. So here, I'm just writing the logic to draw this on the screen. And then after that, we're going to create in the contents folder the level layout and mappings needed. So just bear with me for now. So I'm going to create a constant. I'm going to call it layer settings. This is a general settings we want for our map. So we want every tile. So because our game is 2D and we're going to draw a tile map, a tiled map is usually a map that is drawn from tiles, and those tiles usually have the same size and width, and that's a way that retro games would draw their worlds. However, in most recent games, sometimes you don't need that, but it oftentimes is handy to have this separation, especially when you have a pixel art game. So here, the tile width we want here is 16 by 12, and this is because of our assets. If our assets were different, then we would select a different sizing here. And then here for the tiles, this is where the property that specify the mappings for each tiles, and here we're going to just pass in the mappings object. Now this is completely weird, I guess, if you're not used to Kaboom.js. So let's just write a bit more code here before moving on to another place where this will make much more sense. So I'm going to create a state variable, an attribute of the class, where it's going to be the map. And it's going to be an array. But mostly, actually, this should be called layers. Because the reason I would call this layers is because a map in Kaboom.js is drawn, but you need to call the add level function multiple times to have multiple layers. And what this map contains is an array of layers of the map. So for const layer layout of level layout, So here the level layout passes in an array of arrays of strings. So it's multiple arrays of strings, each describing a layer of the map. So here this for loop allows us to access a single one of them at a time that we can draw. Now, one thing I want to specify here is that this is an arbitrary name. You could have decided to call this A. This is just, if you're not familiar with the off loop, for off, basically is the equivalent to the for in Python, where for each element of an array you do something and you have access to that element, the current element. But you need to use off in JavaScript, because if you write in, what it does is it is used for objects, for iterating through the keys of an object. So I have used previously the for in loop because we wanted to iterate through the keys to create the scene. So if I go back here, you can see the difference here. We have const key in scenes because it will iterate through the keys of an object when you use the in keyword here. Alright, so I go back to the levels.js. I'm going to simply write this.map.push. I want to push to the map the game object resulting of the add level function. So add level is what actually draws the map to the screen. It creates a game object for it, and we want to store those game objects into the map state attribute, the map attribute, because we want then later to apply a scaling to each of those layers 4 times so that the map doesn't look small. So this map push add level, we pass in the layer layout, and we pass in the layer settings as the second param. So those things here, this is where it comes in handy, because the add level function that comes from Kaboom, this is not a function I've written, needs the arrays of string and an object that contains the size of each tiles, the height, the width of each tiles, the height of each tiles, and the various mappings. So for example, in this object, you'll see that, for example, this symbol, this symbol will correspond to that game object, etc., etc. This is not clear yet because I haven't created the mappings, but once I create the mappings, you're going to see. So I have added the add level, the resulting game object to this map array, so that later on, right below, I can simply do a const layer of this map, and for each of them, well, before doing any of this, yeah, actually, let's do it. So for each of them, I'm just going to do layer.use, and use here is a method that is available for all game objects that allows you to add new components after they have been created. So far, we've only seen how you can create game object by passing in an array of components. However, what happens if you want to add some components after having created the objects later on? How would you do that? Well, you use the .use, and inside of it, you pass in the component. So I pass in the scale component. I want to scale it 4 times. Once this is saved, well, nothing is going to happen because we're drawing nothing yet. We need to go to the contents folder, and here I'm going to create another subfolder. I'm going to call it level 1. Whoops, this is not a folder. This is a folder. I'm going to call it level 1. Now I also want inside of this to create a file called general mappings.js. What this file does is it's going to contain the various mappings to various symbols in our map. And the reason I'm putting it outside of the level is because we're going to the level 1 folder, is because those mappings are going to be reused and present in both the first level, the second level, and the third level. So all levels. So before doing anything here, let's go to the level 1 folder, and I'm going to create within the level 1 folder first a config.js file, and then within still the level 1 folder, I'm going to create the level 1 layout.js. Now ignore the config.js, I'm going to go over it later on, but now it's time to create the level layout. So just for you to really understand how it works, I'm going to export a constant called level 1 layout, and it's going to be an array, and inside of this array it's going to be another array. And you know, for this I don't want to do this manually. I have already done it, but yeah, so this is how you draw the level. So I'm just going to copy paste it, and you can see that this is basically a platform with a coin here. And the symbols I have decided here are going to be used by the mapping to know. It's in the mapping that I have specified that 9 corresponds to a top left corner platform tile, and that A is a middle tile, and then B is a top right corner tile, and that the A, commercial A, I guess, or the at, is corresponds to a coin. And all of this is through the mappings. So this is just the first layer of our level. And of course, I recommend for this section that you simply copy what is in the code base already. So go to the code base on GitHub and copy this instead of manually editing this, because it's going to be tedious to do it manually. And because the goal of this tutorial is not really game design, it's much easier afterward to just modify the tiles you see fit, add coins where you want, etc. So for now, I'm just going to copy this. So you can find this in the level 1 layout in the code base if you look at the GitHub repo. So now I have everything I need, the various layers. So this is important that this is the first layer, and this is the second layer, because we want this platform to be behind those 2 platforms here. So this is how we would do it. Now let's look at the general mappings, which is empty for now. And I'm going to, again, show you how it's created, and then I'm going to copy and paste some things to speed up things, basically. So I'm going to export a function this time around. I'm going to call it generate mappings. What this does, it's going to take a tile type. And the reason it's going to take a tile type is sometimes, depending on the level, I want the same mappings, but just want to swap out the sprite to being another kind of sprite. And if you look at the assets, you have a bunch of similar sprites with a similar naming convention. For example, there's the grass one way, but there's also the brick one way. The only thing that changed between those two in the name is the brick, the type before. So that's why I'm going to use this and pass it as a params to the generate mappings to basically change which type of tiles is displayed. So now the whole point of this function is to return an object containing the mappings. All right, so the mappings here that we want, let's try with the first one. Let's say we want this 0 symbol to return. This is how you would do it. So you specify the symbol, and then you pass in a callback that returns an array, and then the add level function in Kaboom will take care of creating a game object with this list of component when drawing the level. So here for 0, I want the sprite, I want a game object with a sprite of $. So I'm using a template string so that I can swap in the tile type. So I pass in the tile type here, and I put in the tile set, and those are just names that we're going to specify in the asset loading. We haven't yet loaded the assets for the various platforms, but we're going to do that in an instant. So we have the sprite, tile type, dash tile set. So here tile type is going to be brick, grass, etc. Now, after having added this, I add the area component. The reason I'm adding the area component is so that it becomes a solid, because the area component creates a hitbox. And we need the hitbox for the platforms because we want our player to be able to stand on top of it. But this is not enough. Area just create the hitbox, but not the behavior. And this is where the body component comes in. The body component takes in an object, and you can specify whenever or not it is static. If you add a body component to a game object with is static being true, that means Kaboom will treat this game object as a solid object that isn't affected by gravity. On the other hand, if you just put the body without specifying any object inside, then your game object will be affected by gravity and will fall, for example. Now, one thing you need to add for performance reason is the off-screen component. So the off-screen component will, when the tile or the game object, when this game object is out of the visible, is not visible because it is out of the screen, I guess, then Kaboom is going to stop a bunch of calculations that are going to be cost intensive, if performance intensive, if you were to not use this. So this is a life changer because it really can make the difference between having a game that runs at barely 30 FPS to a 60 FPS game. Okay, maybe I'm exaggerating a bit, but you get the point. So now that means that when we have this generate mapping, if I go back to the level 1 layout, I will export another constant. And this constant that I'm going to export is going to be the level 1 mappings. And I'm going to call the generate mappings function and pass in the tile type I want. So the tile type I want for the first level is the grass type. Now, before doing anything, and just to so you see, the 0 here is going to be replaced by the game object here that is going to be generated when the add level function is called. Now, this might not be clear enough, so let's actually import the assets. You might be wondering, like, where does this grass type come from? You just decided to pass in a tile type as the general mapping function here, but this is just a name. We don't have a sprite that is called here because we have not loaded any sprites related to this. We need to go to the loader, and then after going to the loader, we need here to add a load sprite and then specify the grass tile set. And this is going to be a bit different than the other sprites we've loaded, because now we're not loading just a single sprite, we're loading a sprite sheet. And this is pretty important how to learn to do this, because it's going to be very handy when you're making games. So how you do this? Well, simply put, you will add a third param, an object param here. So the first param is the name you have decided. So here, grass tile set. The second param is the path to that resource, which is a PNG. So let me just really quickly find it. So I think it's grass tile set.png. All right. So I'm gonna write the name here, grass tile set lowercase.png. And then there is this third optional param that I'm gonna use here to tell Kaboom which part of the image corresponds to which tiles. And this is very important. So here, if I go back to, not the config, if I go back to the general mappings, you have the sprite here. So yeah, so the default sprite is going to be the tile, basically the default tile. But you're going to see here that for the other tiles we're going to use here, not only are we going to specify the sprite, but a default anim, which is going to correspond to a specific tile in the grass tile set image. So for example, this is not the grass tile set, but this part, for example, is a tile. This part is a tile, and we need to tell Kaboom this. So let's do that in the loader. So here in this object, we're going to add the following. So let me just really quickly find it out. So we need to first specify the slice X property. You're telling Kaboom how many sprites there is horizontally in that image. How many tiles, not sprites, how many tiles there are in this image. And it's 3. And how I know this? Well, if you just look at it, if you just look at the resource, grass tile set, you're going to see that this looks like the top left corner tile, the middle tile, and then the top right corner tile. So you can delimit this into 3s. How many tiles there are? So yeah, this is an error. So the slice Y property is the second thing you have to define here, and it tells basically Kaboom how many tiles there are vertically. So here there is 4, but how do I know this? Well, it looks like 4, but I did a lot of trial and error. If I were the one to making my own assets, then I would know, because I would have designed it a certain way. So it really depends. But for this tutorial, it's slice X 3 and slice Y 4. And here you need then to specify the anims property. This is where you're going to specify the various animations. So this is used for animations mostly, but it can also be used just to specify tiles. And this is a trick. It's not intended to be used that way. But for example, I want to define the top left corner tile. Well, I'm going to create a TL name key. So this is arbitrary. I decide what I create here. And I'm going to assign the 0 frame, the 0 tile. So the way Kaboom works is that it divides this according to slice X and slice Y, and then it considers this tile to be 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. So by telling that the TL key is equal to 0, you're telling that when I'm going to play the TL animation, even though it's not an animation, display frame 0. So this is how it works. Now if I go back to the level layout, the general mappings, I think, yeah, because it's the zeroth, because it's the first tile, because the 0 corresponds in the layout to the top left corner, I don't think we needed to specify TL as being 0 here. So it might be completely optional. You don't need to specify, because by default, when no animation is specified, it will take the 0th tile. And I just want to make that even more clear. So I'm going to pull out Excalidraw again. So I have, let's say, this is a sprite sheet. And then it's divided in such a way that you have 3 sprites. 3 rows, I guess. Assume that they are all of equal sizes. 1, 2, and then 4. So you see here, frame 0 is here. Frame 1, let me zoom in. Frame 1 is here. Frame 2 is here. Frame 3 is here. Frame 4 is here. So it is all calculated. It always starts from 0 from the top left corner, and this is how you define. So by saying that TL, you're basically telling Kaboom that TL corresponds to this, and etc. Hope this was clear. Let's move on. Now, as I told you, by default, it will display the first tile so the tile 0, if no animations is specified. And this is why in the general mappings we don't have a second param here with the anim being TL. We don't need this. So considering this, and I haven't realized it sooner, I don't think we need it, so I'm just gonna remove it. So I'm gonna instead have a top middle tile, and this corresponds to the first, literally the tile next to the first tile, which is tile 0. If you remember in the drawing, tile 0 is here, so tile 1 is here, and so on and so forth. So tile top right tile to middle left tile 3, middle tile 4, MR, so middle right tile 5, and then middle left dash 2. Yeah, so middle, I wonder why did I call this middle left dash 2. I'm getting confused by my own thing. Well, it should be bottom. Okay, let's put bottom left as the 6th, bottom middle as the 7th, and then bottom R as the 8th. So this is how you would do it. Now if I go back to the general mappings, let's add another one. Alright, so here I'm gonna go again to the general mappings. I'm going this time around. Okay, I don't think you need to specify the TL, so that's why I didn't put it, but hopefully I remember if anything doesn't work. That's the reason. So here, again, pass in the tile type with, don't forget the tile set, and then the default animation. Anim is going to be TM for tile middle. And then here I just gonna copy the same components like that. So that's it. And then you do the same for 2. So it's gonna get repetitive real quick. But once you have done the work, I'm just gonna copy paste it. I'm just gonna copy paste it. And you can copy over what is in the code. So anyway, the bottom I'm using it here. So instead of having ML-2, I should have BL bottom left, bottom middle, and bottom right. So in case you're copying as well from the code base, be careful with this, as I have changed the name from the original source code, as I realized that it's better to have them named as bottom left, bottom middle, and bottom right. That makes much more sense. Alright, so we have our mappings here, and this corresponds to the coin. So those two things, the bridge and the coin tiles and the one-way tile sets, are all sprites we haven't added to our loader. So we need to do that. So let's do that quickly here. So I'm going to go to the loader. And here again, I think you have understood the principle, the main principle. So I'm just going to copy over what I have here. Again, here, instead of ML, bottom left, bottom middle, and then bottom right. So yeah, that's the same structure, the same anim names, but a different name for the tile set. So the one-way tile set, if I can pull it out, one-way grass one way.png. It's this one. We want the player to be able to pass through and arrive on the top. This is called one-way collision. You're going to see later on how we implement something like that. So once we have done this, we have implemented the grass one way. I think it's enough for now. We are going to add a lot of different types later on for level 2 and level 3, but for now it's fine. Now we really just want to display something on the screen. So let's do So we have our layout and we have our level.js, which contains the methods. So now we're going to just go to the main.js, and within the code here, within the level 1 code, I'm going to const level 1 equal new level, and then here we're going to draw the background, and we want the background to draw is the forest background, the one we used for the main menu. And then we're going to simply draw the level by doing a level 1.draw map layout, and here we're going to import the level 1 layout from and the level 1 mappings. This is all coming from the content folder. We were just there a minute ago. So here the general mappings is just a utility for us to here export the level 1 mappings by generating the mappings with the grass tile type and the level 1 layout, which is basically the layers of the level. Okay, so this is done. Now I think that's it, and we can just test if everything is going smoothly, if everything is displayed correctly. So let's try it out. So I'm gonna open up the browser, and there seems to be a mistake, an error. Alright, it seems again to be because of the general mapping not being imported correctly. So I think that's the error is in level 1 layout, and this is something that you need to be very careful. You need to add a .js to your imports. Alright, I go back here and the game seems to be working. Now it just refreshed so that the resolution is correct. Now I press enter, and I press enter again, and oh, the coin. Yes, because in the general mapping I added that you could have coins, and we haven't loaded the coins. So just to tell you what I'm referring to, I go to the general mappings. You see the coins is here, and the bridge. It uses the bridge sprite and the coin sprite. But those sprites, we have not yet implemented them. Also, there's one thing I have kind of forgot to talk about, is for certain tiles, like this tile, where in the area component, it does create a default hitbox for you, but you can pass in an object with the property shape to create a specific custom hitbox. And this line, what it does, it creates a rectangular shape with a vector 2. This is the position of that rectangle. Here it's 0, so it's at 0, 0, relative to the current position of the game object. So this is not absolute. This is just relative to the game object itself. And then we have a width of 16 and a height of 3. So this is just so we have a flat platform, and this is going to be much clearer later on. Another thing I have forgotten to talk about is the ability to pass a string like that in your array of components. This is called a tag, and you can pass a tag to your game objects to identify them. So every tag, there are methods, functions in Kaboom.js that allows you, for example, to check collision with all objects that have a certain tag. This is where it becomes really useful. So yeah, so now let's just import the sprites we're missing out on in our loader. So let's do that real quick. So we need the bridge and the coin. So let me try just finding them real quick. Where is it? I think it is. Alright, I found them. So for the coin, I'm gonna import it right below here as to not clutter. So at line 11, you can import it anywhere you want within this function, the assets function. And then there is the bridge, and the bridge for the bridge, yep, it should be here. And I'm going to import it right below. So we load both the coin and the bridge. All right. Now things should be working. I click enter, and you can see that it drew something. But the way things are is that it really doesn't look any good because it's on the left and we cannot move the camera, for example. So that's bad. So what we're going to do is, now that we have the map, we need to actually draw the water. So and then once we have drawn the waves, we're going to focus on the camera and the player so that you can really see the level. So just before jumping in, because I fear that I'm gonna forget about that later on, so I might as well do it right now. So in the level.js class, write a draw waves method, and the draw waves method is simply going to contain logic for drawing waves. So for the level 1, it's just the water. For the level 2 and 3, it's going to be lava, and it's going to be clouds. But they all have the same shape of wave-like shape. So they all have a wave-like shape. So it is basically the same thing. So here's the code I've copied over from my code. What you need is to add a type as the param, which is going to be either water, lava, etc., and the animation for it. So here we have an offset of -100, because the way we're drawing this is by, instead of adding it to our layout, what we do is simply we draw enough of them so that they don't they're visible within the camera but not outside. We only draw what we need, because this is going to remain fixed, and regardless if the camera is moving, it won't matter. So to explain this, let's make a diagram. I'm gonna go dark mode right now and I'm going to just select this. So what I'm trying to explain here is, this is the game, okay? Let's say we have a level. So we have a level, it's drawn this way, you have a thing, you have multiple platforms, it goes on and on and on and on, even outside of the camera's view. The reason we want to draw the waves in such a way that while I move the camera, we see the rest of the level, but there are still some computational resources that are exerted and used to render this or calculate their positions, or if there's any collision with mobs, etc. So it's necessary to do this. But to save on performance, what I want to do is simply I draw the waves in such a way so that, let's say I'm going to move this over and I'm going to draw the waves, that they cover the whole camera viewport, but because they're fixed, if I select this, they're going to move with the camera, so that it gives you the illusion that there are waves for the entirety of the level. But in reality, no, there isn't. It's just stuck with the camera. It's just an illusion, but it saves on performance. So that's what I'm trying to do here. Hope this was clear. So to achieve something like that, we have an offset, which is basically the furthest point X value we want to draw. And then we have a for loop, and then we draw 22 tiles, 22 water tiles, wave tiles. And for each of the iteration of the loop, we draw a sprite, that is the wave, with the anim. We're going to see we'll have to import it. A position, which is the offset for the X position, and we always keep the same Y position. we scale this 4 times so that it isn't small enough, too small, and this is the most important thing, is we keep it as fixed. It needs to be fixed because we don't want it to move with the camera. We don't want the camera to move while they remain in place. Otherwise, the illusion of having waves for all of the level is going to be broken. And after having drawn the game object, we increase the offset to 64. That's the width of a given wave tile, so that the next tile is going to be drawn right next to it. So this is how we do it. And now in the loader, we're just going to import the water. So let's do that real quick. So the water sprite has a couple of things you need to specify. So this is the code for it. So again, it works the same way as a sprite sheet, because if I pull out the water.png here, you can see that it is a single image containing all the frames, because we want to also animate those waves. So there is eight frames horizontally, and there is only 1 frame vertically, so there's 1 row. So 1 row, 8 columns. So slice X tells you how many columns there is, and slice Y tells you how many rows there is. And then we have the anims property, where we specify the animations. So here we have 2 animations. Let me just format the code properly. So the wave animation, which starts from 0 to 7. This is how you specify an animation. If you want more than 1 frame, you specify the first frame and then the second. So just to reiterate, 0, 1, 2, 3, 4, 5, 6, 7. This is how Kaboom numbers them and how we can reference them. So we want to go from the first frame to the last frame at a speed of 16 frames per second, and we want to loop the animation. So once we call the play function for the animations, it's a different play function than the one used for audio. You're going to see it in a minute. Then it's going to play the animation. Now, the reason I have wave dash reversed here is just an alternative animation where you do the reverse. You go from the 7th frame to the 0. So it's going to go backwards like that. 7, 6, 5, 4, 3, 2, 1, etc. Now, I think I ended up using just the normal wave animation, but let's just add them right now. So I'm going to go to the main.js. I'm going to go to the scene, the level 1 scene, and I'm going to add here level 1.draw waves. I'm going to specify the wave that I want to draw, which is the water one that we just imported, because remember, in the future we're going to also have the lava and the cloud one. So here I have the draw waves, water, and then the animation we want to use is just the wave animation. And let me just look reference in my code base if I used that or I used something else. So for level 1, I think I used wave. Yep, I just used the normal wave. So you don't need to, if I go back to levels.js, not JS, loader, if I go back to loader. By the way, I'm pulling out the files really quickly in VS Code like that by using Command P. So I'm just going to remove this as it is not needed. Yeah, sometimes I will leave leftover code that I forgot to remove. Whoops, no, I don't want to close this. I just want to save that. I'm going to go to the main. And I think we have everything we need here. So I'm going to open up the code, the game itself. So let's do this. And you can see that the waves are appearing and it looks like it's flowing, and that's really great. So now we need to really work on the camera. So let's do that. Well, actually, before we can work on the camera, we need to actually work on the player. So yeah, because the camera is going to be attached to the player, so we might as well work on the player. So what I'm going to do right now is I'm going to go to the entities folder that I've created earlier on and create a player.js file. In this file, I'm just going to export a class player. And this is going to contain the state and logic for our player character. So what do we need here? There's a bunch of methods we need, but I think the most important one is the constructor. So we need to pass in a bunch of properties to the player class to create the player for us. So what do we need here? We need a position, a X position, a Y position. Well, actually, we could pass in a vector, so we could use the position instead. So this is not something I did originally, my original code base, but by doing this tutorial, I really noticed some flaws, and I just can't help it but want to modify it. So I have the position, which is vector 2. Then I'm going to, I think maybe I should keep it because I might assume that some part of the code base is dependent on this, and yeah, I should probably have passed in a vector 2 instead of pos x and pos y, but never mind. Yeah, so in an ideal world, I would have done this. Alright, so now the third param is going to be the speed at which the player passes through, moves. I'm also going to add a jump force param, which tells how the player, the strength of the player, how much the strength of their jump, how far they will jump up, the number of lives they will have, and whenever the player is in a current well, actually, it's good to pass in the current level scene. So what's the current level the player is in, and this is going to be helpful later on, and the is in terminal scene, just so we can know if the player is at the last level of the game, so that we can send them to the win screen if they finish the level. So I'm just gonna reformat this. I should have installed a prettier extension or something like that, but yeah, that's for another day, I guess. Now here we're just gonna set all of this. So to make things faster, I'm just gonna copy over the code for this. So here, this is in terminal scene. You set it by adding the this keyword. You create this attribute that can be accessed later on by other methods, and you pass in what the user of the constructor, the player, well, actually what the constructor passes, you pass it to your attributes so that you can use them later on. That's basically it. Now, before doing anything else with the other properties, let's create the makePlayer function, makePlayer method, I guess, which will take in just the pos x and pos y value. Well, you see, this isn't necessary. What we're going to simply do, yes, I did not want to pass this as attributes because we don't need that to keep that as an attribute of a class, so that's why I put it in as param here. But basically this makePlayer will just take in, actually instead of pos x, it's an x value, a y value, and it's going to create the initial x. This is useful for respawning. This dot initial y, and right now I see an optimization I could have done. I see that I could have just put this as the initial y. So let's do this. Let's refactor. I'm gonna save the this dot initial x as the position x, this dot initial y as the position y, and I don't know why I put a comma here. So I have initial y, initial x. Now here, this is unneeded. We don't need any of that. And because we're making the player, we don't need that as well. So now we can just pass in the following. Here. So this, we're going to store the game object as a property of the player class. It's accessible by using the this.gameObject, game obj, obj, I guess, property. So we have the add function, nothing new here. The array of components. What is new here is the area with the shape here. We want the vector to the position of this hitbox to be offsetted by 3 pixels vertically, and we want it to be of width 8 and height 8 as well. And because we have the area component, we can use the anchor component, and here this is what will change. We can just put in the this initial x and then this initial y. And then you have the scale so that the player isn't too small. We add the body component so it is affected by gravity. And we add the player tag here so that we can reference the player elsewhere by using a get function, which is something provided by Kaboom, is that if you pass in the tag, it will give you all the game objects that have this same tag. This might be handy later on. Alright, so we have this. Now, what we need to do is, let's stop here, and within the constructor we're just going to call this makePlayer this dot makePlayer function, and then we're just going to assign a bunch of other properties. This speed, this jump force equal jump force, this lives equal number of lives, this previous height equal this dot game object dot pause dot y. So this is how, because we have the game object, the pause attribute is available because we use the pause component here. So the pause component, the pause attribute here contains a vector too. So that means you can access the y individually by using the dot y property, and you can have also access to the x property. The reason we need the previous height here is going to become apparent much later when we're going to deal with various jumps, etc. I think that's basically it. We need a bunch of other stuff here, but not now. Okay, so now let's try to display this player and then create the camera for it so that the camera follows the player, is centered on the player. And this way we're going to be able to see our level how it is supposed to be. So now I'm going to go here. I want to draw the player before the waves so that when the player, imagine they fall off, they're not going to fall off above the waves. So it makes much more sense like that, so that you go into the waves rather than outside of it. So that's why I would create. So I'm going to const player equal new player, and then here for the pause x value, let me just look what I have put in my code base before. It's okay, 1,500, and then here we have 100 as the y value. And then of course you have to specify all the others properties, and I'm going to show you later on how to do this much more efficiently by just pulling all the data you need here from the config.js file, and this will make it much easier for you to just modify. Yeah, so just modify everything. Speed is not 3, speed is 400. And this doesn't matter the values you put in for now, but I'm just going to put the correct values so that we'll have a smoother time later on. Current level scene, that's level 1. A number of, wait, I forgot about the jump force, 650. The number of lives, 3. Current level scene 1. Is in terminal scene false. Alright, so we have our player, it's there. And now I think we're ready to look at the results. So I press enter. Sprite not found for the player. Makes sense because we haven't imported that. So we need to go to the loader. And in there, right below, I'm gonna import the player sprite sheet, because we're going to again use slice X, slice Y to have the various animations we need. So here the principles are the same. We have an idle animation from frame 0 to 3. So if I pull out the PNG, the player.png, you can see how it's structured. We have, I think we have 4 frames here, and then by 6, like that. But we're not using everything here. There are certain animations and frames we won't be using, like the climbing and the climbing here as well. So here what we use is the idle animation. I created an animation, I called it idle, from 0 to 3, and I loop it. I don't change the speed here because I don't need it to. There is a default speed. So here from 0 to 3 it's 0, 1, 2, and then 3. So it's 4 frames because 0 counts as 1. So there is frame 0, frame 1, frame 2, frame 3, 4 frames. Now run is from 4 to 7, and here 4, 5, 6, 7. And jump up is just 1 frame, the frame number 8. Here it is. And then frame 9 is for jump down, and here it is. That's all that we need. Alright, so we have this loaded. Now if I go back to the project and I hit, well, you can't see the player, so we need the camera. So for the camera, what we're going to do is in the utilities, create a camera class. So I'm going to create a camera.js file, and then here I'm going to export class camera. Camera. Here it is. And now if I write, so I'm going to add the property attached object, which is initially null, so the camera is not attached to anything. Then we simply have an attach function which takes in the game object, and then any offset you want to pass in, because you might not want to follow exactly the player, but I'm going to assign a default value. It's going to be 0, and just so that this is much more readable, I guess, I'm gonna put this here as a column like that. So I'm gonna put that here. So offset X, offset Y is by default 0 if you don't specify anything. Fixed X is by default null if you want to fix the X value of the camera somewhere. And fixed Y is by default null. Now for the body of the function, the method actually, what I'm gonna do is first I'm gonna attach the object by simply assigning to our attached object attribute the game object that has been passed in. And now if fixed X is defined, is not null, and fixed Y is not defined, then we're going to use the onUpdate function, not onTimeUpdate. I don't know why my code editor decides to just replace things like that, but onUpdate function is a function that is provided by Kaboom that is run every frame. And here we can use the camPause function, which is also provided by Kaboom, that allows you to change the X and Y position of an object, a game object, of the camera specifically, not just a game object. So it's called camPause for camera position. Now I put in the fixed X value here, and this dot attached object position dot y, because if you remember, this is a game object. It has access to the positional attribute property, and then which is a vector2, and then we can access separately y and x values by simply doing a dot y here or dot x, and then we return early. That is if we decide that the camera is going to be fixed on an x-axis but not fixed on the y-axis. Now there's also the reverse here. So here it is, same code just for the other case. And finally, if both are fixed, well, actually I just realized that I've wrote this code but I haven't used it really much. I don't think it's necessary. So you can, I think you could just delete this. This is some leftover code from when I wanted to write a modular camera system, but in the end, the only line you need is this one. And you might as well just get rid of that as well. So only offset X, offset Y, because we don't want, for example, we have the camera to be a little behind the player or a little above, a little bit in front of the player. So we have here the cam pause on update, can pause, the player position plus the offset. If it's 0 by default, then it's just 0. Otherwise, it's going to be the value we need. So that's basically what we need. And then we simply going to call this. So we're going to create the camera by typing in new camera. And then, so we have a new camera, and then camera dot attach, and we're just going to take the player game object attribute. I'm going to pass it here. So yeah, I'm not very strict when it comes to having getters and setters for our classes. I think it's just going to over-engineer the thing here. And even while doing this, I'm realizing that a bunch of classes here are not necessary. They could have just been either a function or an object. Yeah, they could have been an object. So yeah, feel free if you can to refactor the code, make it better. So yeah. Okay, so we have the player, we attach the game object, and I think that's basically it. We have something to see. We have to specify the offsets, of course, and I'm gonna just put 0 for the X offset, but however, minus 200. We want the camera to be a little bit behind the player. This is just what looks good. So let's look at the result. Press enter, and here you can see. However, I see that we probably should have an offset, a fixed value actually. So the fixed code was useful after all. So let's go back to the camera. I just realized that I fixed the value from the X position. So this is the part of the code we need. I'm just going to show it to you. So I think it's the fixed Y, actually, fixed Y. So this part. So I'm going to go here, and I'm just going to go here. I'm going to remove the conditions. I'm going to remove this as well to simplify the code. I'm going to reformat this correctly. I have an attach, object, position, offset, and then fixed Y. So I'm just going to pass in the fixed Y initially. Well, there's no initially. You have to decide on a value. So let's go here. Let's go to the main. Let's go here. And then here the value we're going to place instead. I think game object, offset, fixed Y. All right, 200. That's the value we need to put there. So what happens here? Press enter. All right, looks good. Now what happens is this character is going to be affected by gravity, so we need to add some gravity. So to add gravity in Kaboom, it's very simple. you go to your scene, and at the top you do a set gravity. Use the set gravity function. What this does is simply to set the gravity, and you need to specify a value. And the value I have specified in my config file, if I remember correctly, for this level is 1400. So if you do this, you set the gravity, press enter, and you can see that the character is now has now fallen, and now we're really starting to have something that looks like a game. Now if you press F1, you're going to see the debug mode in Kaboom, which will draw the various hitboxes. And you can see that certain hitboxes are big for coin collection, and these are for the tiles, and I don't draw certain hitboxes here to save on performance. So yeah, I'm gonna go over this in the third part, where we're actually going to implement player movement, a bunch of player stuff. There's much that still needs to be done to have an actual finished game. So in the last part, well, it should be all in the same video, we created the camera class, and I've just realized that, well, having a class just for one function is not going to be, it's not good code practice. So I suggest that we just change this to just a normal camera function. So let's just go to camera, call it this camera JS lowercase, and then instead of having a class, we're just going to export default a attach camera function. So by doing something like that, I'm just gonna take the exact logic here and paste it inside. Now here, instead of having a this keyword, we're just gonna take the attached object here and just put it here. And of course, let's keep the same params, so offset x and fixed y. So you see, when I initially designed this, I thought I would need much more configurability, I guess, for this. But in the end, in the final game, I've barely touched this. After attaching the camera, I've barely done anything. So in another situation, it might have been wise to do something like that, but yeah, I forgot the function keyword. So export default function, we call the onUpdate function from Kaboom.js. So this is all knowledge that I have explained previously. Now we need to change something in the actual code here in the main, and what I'm going to do is here, instead of camera.attach, we don't need this anymore, and we're just gonna call the attach camera function attach camera, that is going to be imported from the camera.js file, the file that we have renamed. So initially it was named camera with a capital C, but now it isn't, and I'm just gonna remove this in the import statement because it's not relevant. Oh, also I see that I've imported by default. Let's do not a default export, just to be consistent with the way I have exported everything else so far, except for the Kaboom. So if you look at the import statements, the only absolute default import is this one. Otherwise, all of them are non-default exports. So let's keep this consistency. So this is just a stylistic choice, and I think there are some benefits to having this. So you can have more than one thing to import from a given file, so that can be handy, even though I haven't used that much in this project, except for this, where I import both the level 1 layout and the level 1 mapping from the content/level/level1 layout.js. Alright, so now what I'm gonna do is simply test that the game is actually working as intended. So let's look into that real quick by looking at the browser tab. So here it is, and yes, so we have a character but no player movement. So let's implement that real quick. So for the player, all the code related to the player is going to basically go into the same single file. So what I'm going to do here is I'm just going to go to the player.js file, and there are going to be a bunch of things we're going to add, but we need to first create a method called set player controls, and this is where we're going to write the logic for making the player move. So set player controls inside of our player class, and then within we can use the key the Kaboom.js function event listener that is provided by Kaboom. It's called onKeyDown, written with capital K and D. I think there is a similarly named event listener by default on the web, so in web JavaScript, but don't confuse this with this one. This is something specific to Kaboom.js, and we're just gonna enter the left key, and as the second param. So here the first param takes the key, the name of the key, as a string you want to listen on, and the second param is the event listener, I mean the callback that is going to be called when the left key here is down. So if I do this, now we're going to add a bunch of logic to that. So we first need to add, I would say, let's just write the moving code. Actually, we need to play animations when the player faces a certain way. So let's do just that. So I'm gonna start with an if statement, and if this dot game object, which is where our game object for our player is stored, that we have created here by calling the make player in the constructor. So if this game object has as its current animation, so curAnim is a method provided by Kaboom on game objects that allows you to check which animation is currently playing. And for now there aren't any. So what we're going to do, we're going to simply say if this isn't equal to the run animation, then what we're going to do, we're just going to do a this.gameObject to access the game object and use the play method. So this play method should not be confused with the play function in Kaboom.js. The play function is a function that you can call without having it attached to a game object, and it is for playing sounds. And if you have seen earlier on, if I go back to where we play sounds, so for example in the UI manager, you can see right here. So here we are calling the play function to play the confirm-ui sound at a speed of 1.5, and this is for playing sound. For actually playing animations, it's usually, well, it's only called as a method of a given game object. So by calling the play function here, you need to specify the name of the animation you want to play, and here we want to play the run animation. And if you remember earlier on, if I go to my loader and I go to the player load sprite, so where we have loaded the player sprite, you can see that in the anims key we have this defined 4 animations. One of them being idle, the other one being run, and jump up and jump down. So by using the run string, you're referring to this animation. This is how Kaboom will find it. So if I go back to the code for our player in player.js, I'm going to simply call the run animation, and then that should be good. We can test this out. Well, first let's call right under this make player in the constructor this set player controls. This is in the constructor of the player, and if I call this, I'm going to go back to the game, press enter, and then you can see that when I press the left key, the character is running. Now you can see that the animation isn't changing back to being the idle one, and initially we had the idle animation running. The reason it is that if I go to the where we make the player, we specify here that the default animation is idle. So that's why by default the player is moving, is running this is why Kaboom.js is running the idle animation on the player. So now let's continue writing our code for this. So let's do that quickly. So what we want to do, in addition to having this if statement, so by the way, in case you didn't know, you can have an if statement on a single line like that without the brackets if it's a single line if statement. So yeah. Now if we press the left key, we want the game object to be flipped so that it faces the left direction. And to do that in Kaboom.js, you take the game object, and Kaboom offers the flip x property that you can use, and you can have equal true for it to flip leftward, well, to flip in the direction opposite from the default. By default, our sprite is facing right. So if I pull out the sprite so they can clearly see, you see it is facing right. By simply setting the flip x property is going to flip this image to be facing left, like a mirror. So that's how you hope the explanation was clear. Now if I go back to the player.js entity here, so we can test that out immediately. So what I'm gonna do, go back to the game, press enter. You see I turn left. Now we need to go back to being facing idle, like facing right, not facing right, facing playing the idle animation, because flip x it isn't just for the current animation, it sets permanently whenever or not the sprite is flipped. So later on, if you would like to go rightwards in the right direction, you'll have to set back flip x to being false. And I think that's it. We haven't written any logic to move the player, so we'll do that in an instant. Let me just look. I think we need to move the player, but I just don't remember how I did that. Give me a second. This dot game object dot move. And this function, this method is also offered by Kaboom.js and will allow you to move your player. And it takes in two arguments. The first one being the left direction and the right, the horizontal direction, and then the second one being the vertical direction. So I want the player to move at a speed of this dot speed. So a minus, so it goes left, and vertically I just don't want it to move at any rate, so I put 0 for the y-axis. So this speed is specified here and is set as an attribute of the class, so we can call it here. And I'm using the negative sign because, for example, this is, for example, 400, and it's going to be minus 400, which will make the character move to the left. Now if we test this out, press enter, press this, and you can see that the character, you can move with it and go further along, but this is just a bug. We have to fix this later on. Well, it's not a bug, it's just we haven't yet implemented all that we need. Alright, so we have this done, There are some conditions we're going to later on impose here as to know whenever or not to let the player move. So in cases, for example, when the player falls down, we want to respawn, but when they are respawning, we don't want to allow them any movement. So now that we have this, we're just going to copy and paste the same thing a second time and just change a few things. The few things we need to change are the following. So we need to change the direction of the speed. So instead of a negative, the direction of the movement, and so instead of a negative speed, we're going to put a positive speed on the x-axis, so it's going to move to the right. And for the flip x attribute, we need to flip that back to being false, and you have to do this because previously it was flipped to true. And by specifying false, regardless of any direction that they look into, we're going to face the correct description, the correct not correct description, but the correct direction. Sorry. So if I save this and let's go back to the game, press enter, and then I can move left, I can move right, but I cannot jump yet. So and when I stop moving, the animation is still going. So we need something to set back stuff. We need something that will set it back to the idle animation. So what we're going to do that, let's first implement a jump. And then once the jump is implemented, we're going to think about that. So the next thing to do is to have an on key down and then space, which is the space key. So when the player presses the space key, we want to run the logic inside this function. What we're going to do is simply if this game object, so this is the game object that we stored earlier on, in case you forgot, when calling the make player function, it creates this attribute called game object, which puts the result of the add function, which if you remember, an add function, what it does, it creates a game object with a list of components you've passed in. Alright, so now that this is done, we're just going to yeah, so my neighbors are doing some construction, so I hope you don't hear that in the recording. I'm sorry if it's noisy. So what we're going to do is that if the game object, yeah, there's this function this method provided by Kaboom called isGrounded. What it does is it will simply check if the player is on a platform. So we want to only allow the player to jump when they are grounded. Otherwise, if they're already in the air and we let them jump, then they are basically going to fly like Kirby. So if you ever wondered how to implement the Kirby jumping mechanic, the floating mechanic, let's try it out. So you do jump, and then you specify here the jump force. You don't have to, but if you do decide on a value here, it's better so that you can really have a fine-tuned control over how far the player will jump. So let's look into it. So you see, I can literally be a Kirby-like character where I can just float. So of course I would put less jump force, but if you have ever wondered how to implement the Kirby mechanic, well, you have an answer here. But of course this is not what we want. We want to only allow the player to jump once, and this is why this if statement is necessary. So I'm going to put this if statement within, remove what is outside, and I'm going to remove this as well. We don't need that. And that's basically it. And then of course one thing, it's not enough to just jump. We want to actually display the jump animation, and to this, well, actually, yeah, we want to display the jump animation, but we were not going to do it here. We're going to do it somewhere else where it makes most sense. Here, we've played the animation here, but the reason for doing it in an on-update loop instead of here is going to become apparent later on. It's just that we want to be able to not only play the jump animation, so jump up animation when the player is jumping, but we also want to know when to play the jump down animation mid-air. So here, if I were to just play this animation, this single frame, I would have to know when to change the animation to falling down. And to do something like that, it's easier to do it in an on-update loop, which I'm going to cover later on. So if what I say right now doesn't make any sense, bear with me. And yep, so you have this game object jump, and that's basically it. Now we could also play the sound for it, so the jump sound. So I'm gonna put the jump sound. So of course this is not going to work. We need to import the sound in our loader. So I think, yeah, you need to do. I'm just gonna find the path for it real quick. Give me a second. Alright, so I think it's here. So I'm just gonna paste it here, and it's load jump, and it's named as jump.wav. So now it should work, and if we try the game, you see? But you can see right now that this platform above here doesn't allow us to pass. And later on we're going to implement one-way collision. So what one-way collision will do is allow us to pass through and arrive here. But you can see that you can actually jump, so that's nice. Alright, now we need to actually set back the player animation to being idle again. So we're going to come back to this player.js file a lot in this tutorial because there's still a lot of things to implement. But let's jump right into the logic for allowing the animation to go back to being playing an idle animation. So for that we use the onKeyRelease event listener. This again is provided by Kaboom, and you can pass in directly a callback. So one thing I haven't mentioned is that oftentimes in Kaboom.js there are many forms of the function. So for the onKeyDown, you could have decided to just pass the function without this param, and what it would do is for every key that is clicked, touched, I guess, or down, for every key that is down, it's going to fire this event. So this is what you need to do if you want a general event like that. Alright, so onKeyRelease. Alright, so what we want here is instead of having to repeat if either the left key or the right key is released, we just want to have to call this function on all keys when any keys is released, not all keys, when any keys is released. And within, we're just going to do an if statement, and there is the isKeyReleased property that you can function that you can use and pass in the key you want to listen to. This returns a boolean. So if isKeyReleased is true for either right or left keys, then we're simply going to play back play back this dot GameObject dot play idle. So we go back to the idle animation. So testing this out, press enter again, and then you see I stop, it goes back to idle. I jump, it goes back to idle. And that's pretty cool. Now what is nice about this is now we can focus on other things in our game, but you can see that it looks more natural. It's starting to our game is starting to take shape. And by the way, let's go on and see the whole level layout. So you can see the level layout here. Let's say if I can jump here, there's a bridge, and then that's the whole level. So if we look back at what we had initially in our folder, level 1 layout.js, and then this was the layout that we just played through, and you can see how there is a correspondence between the actual level in the game and the strings, the characters here. So that's I hope this really let the way you draw maps in Kaboom sink in. And yep, so hopefully you have understood by now how to make maps in Kaboom.js. So what I'm gonna do now is I'm going to fill in the config.js file. So the reason for creating this file is so that we can specify some attributes for our players or level that we want to configure from this file. So you don't have to modify the code every time we want to modify a value. Think of it as for example, the inspector in Godot, the Godot engine. So to explain what I want to do, let's just do it and you'll see. So I'm going to export here a constant, export const called level1.config. It's an object, and I'm going to create this first key called gravity. I want to set the gravity for the level 1 to being 1400. And just before, what I'm writing here in this object is not yet reflected in the game. It's just an object containing keys and values. It's only what we're going to do with it later on that will allow us to set specific values that we want to see reflected in our game. So here I have gravity and I have player speed I want to put as well. And I'm going to take 400 as the value. For jump force, I'm going to put 650. Those values are just arbitrary. By playtesting is how you figure out which values look good. And this is why this is important. It makes it easy for you to just change, oh, I want gravity to be 1000 instead of 1400, just to see what it feels like to play. Number of lives, 3. Player starting position, start pause X. Player start pause X. 100 and 500. 1500. Player start pause Y. And then for now, let's keep it at just that. Now I'm going to show you that if we go back to our main here, and instead of passing in those values here, I'm just going to do level 1 config. So by selecting this, it's going to import automatically the level 1 config. I also like to have this near the level layout and level layout mappings in terms of import statement order. So I prefer to have it here. Also, I prefer to have external imports first rather than and then internal imports. So here it is. Gonna modify this. Something like that. Now this is just a preference on myself. It doesn't affect the code itself, so feel free to follow me or not. So here we pass in the level config object, but we need to pass in the gravity value. Then level1.config. I think the second property that is expected here is, well, actually no, it's start position X, player start position Y, and this is the speed, level1 config dot player speed, and then level1 config dot jump force, and then here's the number of lives dot number of lives, which is going to be useful later on. And here I think it's just a level where I currently level 1. This is going to help us transition to other levels later on. So you can see here that by having something like that, I can just modify the values by going here and just changing the gravity or the jump force, etc. Makes it very handy for me and for playtesting. So if I have the game here, well, I haven't modified any values, so let's go back. Let's say I take, for gravity, I decrease the gravity to 800. I can just do it from the config file, and if I play and I jump, you see, I can jump much farther than I could before. And just to drive home the point, let's put it at like 10, so that it looks really floaty. So enter. Well, you can see. All right. Maybe change some more visible characteristics. So let's say I put the player's speed to 1000. This is going to be very apparent. So you can see that I'm zooming through the level, and it looks like Sonic. Yeah, looks nice. Must be really fun making a Sonic game. So yeah, maybe after following this tutorial, try making a Sonic game. I heard that Sega is pretty permissive with fan games, so it's not like Nintendo where they're gonna sue you or try to DMCA you. So that might be a good next project, something to think about. Alright, I'm just gonna put back the values how they were. Now that we have this specified, we can continue with our work. And I think the next step is to, let's continue with the player code. I think let's just focus on that for now. So now that we have our set player controls, there are a bunch of other things we need for our player. And one of them is, well, to spawn the player when they die. Or respawn. Or maybe you should, yeah, let's work on the logic to respawn the player when they die. So first of all, let's simply create a respawn player method. Now what this does is simply it's going to check if this dot lives is superior to 0. So if the player has more than 0 lives, we allow respawning. Otherwise, we're going to bring them to a GameOver screen. But I think I haven't created this lives attribute. Okay, yeah, it's there. So here inside is we're going to respawn the player. So whenever you want to move the position of the player or do something with the player, most of the time it involves taking its game object and doing something on it. So I'm going to change the position because this game object used a pause, but actually all game objects created have the .pause attribute. Even if you don't explicitly use the pause component, it's just going to create one for you where it's going to put the object at the top left corner. So what we're going to do is we're going to set the player position to a vector2 where the first coordinate is the initial x value. So this dot initial x and then this dot initial y. So where the player initially spawns. And if you remember this, the initial x pause y, in our config, it's the player start position and player start position y as well. So this is how you get it. So for now, we could just test this out. Yeah, and we need to call the respawn player function in a specific way. So here I'm just gonna create, I'm gonna create an update method right below. And this update method, what it does is just gonna call the onUpdate Kaboom function. So it's just a wrapper around that. And the reason I'm doing this is because I want to set this when I call the update function. I have realized that there is a lot of cases where you don't need a class, you don't need these things, but I have tried making a game without classes, and for the most part it did work well. You can actually look at my previous tutorials. I just wanted for this time around to try object-oriented programming, and I would say that in some cases it has been really useful to have classes. However, as I'm doing this tutorial, I'm thinking of maybe there are some way I could use a pattern with and get rid of classes. So for example, using objects more than classes and trying to set state from it. But it is convenient to have just methods here that you can just call from a given name, a given object. So that's something very useful in terms of organization. But anyway, this is a discussion for another day, and really by following this tutorial you gain the knowledge of how to use Kaboom.js, and you can feel free whenever or not to use classes or not on your own. So here, this is a Kaboom function. I try to be very clear when things come from Kaboom and when things are just from my own, so that you don't get confused and think that you have to use object-oriented when making a game in Kaboom. Alright. So we have an onUpdate function. This comes from Kaboom that takes in an arrow function, and it's going to be run every frame. Now inside of it, I'm going to simply write some logic to know when to respawn the player. So I think, if I remember correctly, we need to check the position of the player and make sure that it hasn't dropped below a certain point. And if it is dropped below a certain point, then we will respawn the player. And the logic for this is we check this every frame. So that way we can make sure. So this game object dot position dot y, if this is superior to 1000, I figured this out through testing that when the player, for example, jumps from the platform below to the waves, it's roughly at 1000 that it disappears fully, so we can respawn from that point. But feel free to play with this value, of course. So I'm just gonna do this, and then I'm gonna play the hit sound. So this sound is a sound I found where I want to play it when the player falls, but the player takes damage. It's an all-purpose sound where you get hit or you die. So I like to play it at a speed of 1.5 as well. But this won't work because we haven't imported the hit sound. So we'll do this in a moment. So for now, let's simply call the respawn player method that we just wrote above. And once we have done this, let's go right into our loader function. Loader, here it is. And let's load the hit sound. And the path for that, let me just look into it because I don't have them at the top of my mind. It's of course in the sounds folder. So here it is. I'm just gonna copy paste it. Here it is. So the hit sound in the sounds folder, then hit.wav is the name of the file. Now this is going to be loaded, but there's one thing we need to do, because remember we have not called the onUpdate method on our player. When it's drawn, it's initialized here in the main.js file. So right afterwards, I'm just gonna do player dot update, which will call the onUpdate from Kaboom, and from now on the update loop will be running on every frame and checking the player position. So if we run the game right now, this is how it looks like. Press enter, and now I can move and jump, and then if I drop here, I respawn. Now there are some things we need to figure out later on. As for example, if I don't stop moving, then maybe this is going to confuse the player. For example, I jump like that. I run, and then let's say I immediately jump, but I continue holding, then it's going to move. So maybe we should give a 3-second or 2-second buffer to not allow any player movement before we can give back the control to the player. So this is how we would do it. I'm gonna go back to the player code, and then here in the player code, in this respawn player logic, we're gonna change some things so that it takes care of giving a bit of time before giving back control. We're going to also need to modify the set player controls to allow for this use case. Here what we're going to do is we're going to create an attribute called this is respawning. So first we're going to, here right below this, I'm gonna create an attribute called is respawning, and I'm gonna set it to true. And this needs to be created outside of the in the class attribute, because the onUpdate loop will run every frame, and it could run where this attribute is not yet created. So by having it as a class attribute from the beginning, it's much safer, because really in class code here you can just create new properties from here instead of having to specify them here. And this can be confusing if you're not careful, because you might have created a new attribute under a specific method that is called at a certain moment, but you need this attribute to be accessible in another method. So that could be a situation where you could be calling a method that is not yet instantiated. So here, what I'm going to do, well, actually in the respawn player, if this, we're going to set is respawning to true. And then what we're going to do now is we're going to have a set timeout. So a set timeout to give enough time to the player. So I'm going to do this. So I'm going to create a set timeout function, set. So set timeout is a basic function provided by the browser. So it's something really JavaScript fundamentals related. And I'm going to set this dot is respawning to being false after 1000 millisecond, so after 1 second. So let me just write that and save, of course. And now what is going to happen is that in the on update loop, before we were just like respawning the player, and we're still going to do that. We aren't going to modify anything. The reason I've created the is respawning attribute is that because we're going to use it in the player controls as a way to prevent movement. So what we're going to do is simply that for every movement, we need to check that the player isn't respawning. Otherwise, we don't give back control. So here, we could have an if this is respawning. So only if this is false. Only if respawning is false, then we give control to the player. And then you can just add this to all of the places where it's needed. So I think that as well. Yeah, we need to add it this time around here, not as an if statement, but as a second condition. So we need the and sign here. So if this game object is grounded and this is respawning, then you allow movement. And that's basically it. I think we have it all covered. Yep, all cases is covered. And now if we play the game, enter, we're just going to give back control in a second. So they can't move after a second, which will prevent them from losing, for example. With enemies, it's going to be apparent why this is required. Maybe 1000 milliseconds is a bit too much, so we could modify this to give back the player control after 500 milliseconds, so half a second. So that's how I would do it. And then here you can immediately start playing again. All right. Okay, so I think that's basically it. Then there are many features that we haven't yet implemented that are required here. For example, coin pickup, enabling pass-through. Let's do that actually. It's very easy. So I'm going to create another method right below the make player. I'm going to call it enable pass-through. So what this does is the following. So if this game object on before, this is a method that is offered by Kaboom, on before physics resolve, so, and then in there it takes an argument, which is a function that it passes to the function the collision, the given collision. And this is how you can intercept a collision and allow this one-way collision, one-way pass-through. So just to recap, this game object is where the game object for our player is stored. Because we have used the body component and the area component, I think just because we have used the area component, then we have access to the on before physics resolve function, which takes in as a param a callback, so another function, and then it will pass through to it the collision, the current collision. So I hope that was clear. Now simply inside, if the collision dot target, so this collision object is something from Kaboom and it has the target property. It also has the is property function. So if the target is, and then you pass in the tag, so the tag of the platform you want to check collisions with, and this is the pass-through platform. And this is where tags become handy, is because I've already created earlier on the tiles, the one-way tiles with a pass-through tag. Then I can use it here. So just before continuing here, I'm just going to leave it empty. I think some explanation is required. So I'm going to go to the general mappings. If you remember this file, it was in content, general mappings. Here we had, whoops, this is not properly formatted. I just realized. Sorry, I'm going to fix this quickly. All right, now it's properly formatted. You see that for certain tags, for certain tiles, we pass in the pass-through, and it's because it's using a one-way tile set, top, middle, top, right corners. If I look at the level itself, level 1 layout, this corresponds to tile 9, A, B. Those are pass-through platforms. We want them to be pass-through. That's why I added for them tags, the pass-through tags, so that we can easily, in our player code, check for collisions with them and then ignore that collision. If I go back to the player.js, collision target is pass-through. We also want to add another check, and this check is about checking if the game object is currently jumping. And this again, it's offered by Kaboom. You have the is jumping property function that you can use to know if your player is currently jumping. So if both of these conditions are true, so we're colliding with the pass-through platform and the game object, so the player is jumping, then we want to ignore the collision. And to do that is to do collision dot prevent resolution. We want to prevent the resolution of this collision, so basically canceling it. So now if I save this, you can see you can see that it's going to work, but there's going to be an issue. You're going to see it instead. So let's first, you need to call this in the main right under the player declaration. So player update, maybe before player enable pass through. So you want to enable the player you want to enable the player to pass through platforms. And then here, if I jump, you can see beautiful one-way collision. Now there's another feature I want to implement, is that right now you can only jump up, one-way collision up, but the character cannot go down from the platform. And this is something that is implemented in many games, and we want to implement it in our game as well. So let's do this, because it makes movement much more satisfying and easier, and it makes sense. You are able to do a one-way collision, so you have to do it the other side as well. So to do something like that, we simply have another if statement with the same thing. So if the collision target is a pass-through, and this is where the difference is, and is key down, this is something from Kaboom. It allows you to check when this is called if the key passed in here is currently being down, so pressed, so kept pressed. So because there is the on is key pressed, which is different than if is key down. So here we want the down key to check for the down key, and if the down key is pressed while the player is colliding with a pass-through, then we will also prevent the resolution of the collision, so basically cancel it, and this will allow our player to go down. So if I do this, now if I jump on the pass-through and I can drop down, you see how this is more natural. So if I do this and then I can drop down, basically like in Smash Brothers, if you know the game, like that. So there are plenty of things we need to fix though, like the animation when you fall down, the animation when you jump isn't playing yet. So we're going to think about this in the next part of this tutorial. So in the onUpdate function in our player.js, it's where a lot of these things are going to happen. So let's do it. So the first thing that we need to do here in the onUpdate is we're probably going to create a couple of other properties that we need to know when to play the jump up animation, so when the player is jumping, and the jump down animation. So let's write an if statement here. if the game object is not grounded, so they are in the air, this is where we're going to display the jump up animation. However, we need something else. This is not enough, because when our player is jumping, we need to know when they're falling so that their jump has stopped and they're falling. So just to explain this very clearly, let's do a diagram. So this is our game screen. I'm just going to make that square. I'm also going to just use dark mode because I prefer it. Alright, so this is our screen. Now imagine that our player is here, so this is the ground, and this circle, so this circle is our player. And what we want to do is when the player jumps, they pass through this jumping curve. So those are basically the different frames before falling down to the ground. Yeah, let me just do it before they fall back to the ground. So let's say this is here, this is here, this is here, this is here. So we want to calculate when we arrive at the top point, and that's exactly the moment our player starts to fall down. And to do something like that, we can do this simply by calculating the previous, so we keep track of the previous height of the player. So let's say this is a point in our coordinate system that keeps track of the first this frame. Then at the next frame we keep track of the coordinate, and what we do is we do a subtraction. And by doing this subtraction, we can know if the result is positive or negative. It's going to tell us whenever or not the player is ascending or descending. So that's how you would do it. So just to make things clear, so I'm going to use the pen tool. If here I have x, let's say it's 5, y is 10, and then here we store that the value initially x was maybe 4, and then y was 0. So we do the subtraction between the current frame and the previous frame. So the second point here is the current frame. So I'm just going to write here current frame or current instant, and here is the previous frame. So we have the previous frame here. Previous frame. So by doing the subtraction, we do here 10 minus 0. Well, it's going to give us a positive result, 10. So the height has increased by 10, which tells us that the player is ascending. Now we might need to think about this differently, because remember previously I talked about how the canvas, the coordinate system is made in such a way that the further you increase the value of y, the further you go down rather than up. So you have this. So this might be the opposite. So you have minus 10 and then 0 here instead. So we'll write the logic to adapt this. So we have this game is object grounded. Now we need another property to keep the previous height, and this is something we're going to create within the player class. So if I go back here, you have the is responding property or attribute. Sorry, I say property, but those should be named attributes in the class. And now what I'm going to do is just type in height delta. This is the name of the attribute we want to use, and initially let's set it to 0. So we're only interested in checking the difference in height between the previous time and the current time on the y-axis, so in altitude. We're not interested in verifying the x-axis, so horizontally. So now if I go back down there to the on update, we need to write the logic to store this previous height. So what we're going to do is simply if so here right below, or maybe a bit above at the beginning, this dot height delta is going to be equal to this dot previous height. Okay, so we need also another property. We need the previous height. And the previous height, let me look where I created this. We have the height delta, which is the difference, but we also need to have the previous height, and we added it here, which was the initial y position of the game object, so the player, when we first created it through our constructor. So this is how it is accessible. So here we simply do this dot previous height minus what? Minus the current height. But to get the current height, you simply need to do this dot game object dot position dot y. So this is going to give us the height delta. Here you might have noticed something strange, is that we're subtracting from the previous height instead of doing the current height minus the previous height. It doesn't matter in the long run. What will matter though is the check you're making. So if it's superior or inferior to 0. So here in the is this game object, in this if statement, we're going to add a second condition that is going to check whenever or not this dot height delta is superior to 0. If it is superior to 0, that means that the player is ascending. Now if you use the contrary, if you would want to take the current height minus the previous height, you would need to just swap this with inferior instead of superior. So this is a preference. I prefer to do it this way, but you can do the other way as well. So once this is done, we can play the animation. This dot game object dot play dot jump dash up. We have the jump up animation, which, if you remember correctly, in the loader, when we loaded the animations, it was here. We specify that frame 8 is the frame associated to this jump up name, which is the name of the animation. We have decided to name it this way. It's arbitrary. You could have named this jump left, but you would have to go back to the player.js file here and modify the name here to be jump left instead. Alright, so we have this. I think we're missing something. A third check we need is a third condition is to check the current animation. So if we are already playing the jump up animation, there's no need to play it again. And because this is called every frame, it's going to happen because well, for this specific animation it's only one frame, so it's not going to change much. It doesn't matter if this check is here, but for other types of animation where there is more than one frame, you would need to put a check to check that the current animation is not already playing. Otherwise, it will interrupt the current animation and go back to replaying it from the start, and you don't want that every frame. Alright, I think that's basically it. And one thing we need to do for this to work is to, after having calculated the height delta, the difference between the previous and the current height, for this frame, we need to store the new previous height, which is the current height of the player. So the current height of the player for this frame is going to be the previous height for the next frame, and we need this to store it. So once this is done, I think it should be working. So if I go here, press enter, and I jump, You see, the jump animation plays, but the other animation doesn't. The fall animation doesn't, and we need to fix that. So let's do just that. Alright, so the logic is basically the same. We have another if statement with this.gameObject.isGrounded. And then we add another condition. Whoops, I need to be consistent with my formatting. By the way, if you haven't already, I recommend watching my ESLint prettier setup, which allows you to set code formatting automatically for you and makes your life much easier. The reason I did not use it for this tutorial is just so that it's easy to follow for a beginner. I don't want to add extra things on top of what I'm currently teaching. All right. So here we just add this. Yep. Whoops. Yep. Okay. This dot height delta inferior to 0. So it's the opposite. So if the height delta here is going to be inferior to 0, we will know for sure that the player has ascended and has fallen, but is currently falling after having ascended. And when the height delta is equal to 0, this is at the topmost point. I'm gonna redo this quickly. Whoops, I want to clear the whole thing. So I'm gonna just take the pen. So we have our player here that hasn't jumped yet. They jump. So that would be, yeah. And then they arrive at a point where they're perfectly still. They don't ascend or descend. But after that, they start falling. And they hit the ground at one point. Oops. Like that. So this is how I would describe it. So when we are in this part, so let's section off this part as a single piece. And let's copy this, and then this part is the second piece of the puzzle. So during height delta, here height delta is going to be inferior to 0 at this stage. Let me just look if I haven't mistaken any. Well, it's going to be superior to 0, not inferior. So at this stage, the difference between the previous and current height should be superior to 0 as long as the player is ascending. Once they hit this point, well, it's going to be the perfect point, the still point. It's going to be 0, equal to 0. And then maybe this diagram, this isn't necessary, might add confusion. So I'm just gonna say that from this point onward, and then from this point, once they have hit the height delta being 0, it's time to fall down. And I'm just gonna copy this, paste it. Whoops. Copy this, paste it. It doesn't work. Paste it here, and it's going to be inferior to 0. Now all of this to explain this. So hope this was clear, and we can proceed on. Whoops. Well, I made a mistake here. I need to fix it. All right. Okay. So here's the drawing. Take a screenshot if you'd like. And let's continue. Alright, so we have our condition. We have basically here the same thing. Highlight but the opposite symbol so that we know when the player is falling. And then really it's the same thing. And then here we make a check so that the jump down animation is not already playing. However, because those two animations are only one frame, it doesn't matter that much. But just keep that in mind for future animations, I guess. If let's say you had a falling down animation that was more than 1 frame, then this would be useful to have that, as I said. Jump down. And now I think that's basically it. So now we can test. So now we can test this out in the actual game. Press enter, press enter. I jump and I'm falling. Jump, falling. Jump, falling. But however, you've noticed an issue is that the character, once falling, does not go back to an idle state. And we need to fix that. So to fix something like that, we just need another check. We need to know if the player is moving or not. If the player is not moving, regardless of anything, we should put back the idle animation. So for this, I need a if statement again. I'm going to put it here. And I'm going to check this dot. And we need another attribute, is moving. And I see that is moving is not here. Let's put it here, but we'll have to create it. Create this attribute in the class somewhere else. And then if this game object dot current animation, so this is just for checking that the current animation is not the animation we want to play. And this is especially good here because we don't want to reset the idle animation at each frame. Because remember, when you're coding within an update loop, this code is run every frame, So now we have this, and then here we can just do this dot game object dot play, and then play the idle animation. All right. So we have our idle animation that's playing. That's really great. And we need the this moving attribute. We need to add this. So let's do just that. So the way I would say is I would add the this attribute, the is moving attribute, to the class itself rather than to the constructor. This is something by default we want. So is moving equal false by default. And then as the player presses buttons and moves around, we can set it. So the way we were going to do this though is, I think, alright, we're going to do this within our player controller. So in the implement set player controls here, in addition to setting this, we need as to add right below the this dot is moving to being true. Then we copy this line and copy it, paste it here 3 times. Well, actually, yeah, 2 times actually. We don't need a third one. And then as the keys are released, we play the animation, but we also set back the is moving to being false as soon as a key is released. Any key, those 2 keys are released. So let's try it out. I think this should do the trick. Press enter. I'm jumping and it comes back. I'm coming. Yeah, so I can run. I run and I fall. So if I try to jump from here, you can see the animation works pretty well. So that's really great. And now we can really start implementing Coyote time. So I want to explain what Coyote time is for those who aren't familiar. It's a gameplay feature that is implemented in most new platformers, not necessarily new platformers, but mainstream platformers. For example, Celeste is an example. So what you do here is simply, when the player arrives at the ledge of a platform, we give them a small time frame in which, even though they're falling, they can jump. They can still hit the jump button and it will still register as a jump. So to illustrate this, let me just make this very clear. Reset canvas. So this is the situation. We have a platform here, and we have our platform character, which is running as fast as they can. Once, maybe I can select this like that. Yeah, they're running Whoops, the legs are gone. Okay, so I'm just gonna select it better this time. All right. So we have our platform character. As they arrive here, normally, if they were to hit the jump button here, they would fall. However, a good game design practice has been discovered, I guess, where it's better to, even though the player is falling here, to give them a chance to the player that if they hit the jump button, they can still jump, even though that technically, if we were like objective, they would fall here. This allows the gameplay to be more forgiving, and so that the player doesn't think that the jumping is unfair. So that's what we're going to implement right now. So to do something like that, we need to modify the logic in our space. So space on key down space in the set player controls logic. So here, what we're going to do is add another if statement right below. And we're going to do 3 checks here. First, is this game object is grounded? Is not. So we want to make sure before we execute any logic here that the game object is not grounded, so it's not on the platform. Because the Coyote time, the way it works is that the player must be out of the platform, and then we calculate a certain amount of time, let's say 0.2 seconds, and then we're within that time frame. If the player pressed the jump button, we just make the player jump, even though the player is currently falling. So that's, I hope I was clear. I drove the point home. All right. So here, we're going to use the time function. Oops. The time function in Kaboom.js, not time range. I don't know why VS Code just wants to replace things. All right. So we have the time component here. Of course, we need to add an end statement right before. All right. So we want to add the time function, and this is from Kaboom, gives the current time. And we want to subtract this from this time since last grounded. And this is an attribute that I haven't yet created, and we're going to create it in a moment. And then we want to check, make sure that this is inferior to the Coyote lapse. And this is another attribute that I have not yet created. We're going to create it in an instant. So just write it for now. And we need another thing. We need to have another check to make sure that this has jumped once is false. So the reason we want this, and this again is another attribute we haven't yet created, and the reason for this is that to implement a good Coyote time, we need to check the time lapse and that they are within the time frame, even though they're falling, so that we allow them to jump. But after having jumped once, we don't want to allow them to jump another time in the air. Otherwise, they could have infinite jumps and basically become like Kirby. So what I'm going to do now is just create the bunch of attributes you have created. And to do that, we're going to add them. So the Coyote lapse can be an attribute here. Coyote lapse. This is just for making it convenient to modify. So 0.1 seconds we want to give. Now for the other two state variables. So if I look, the time since last grounded, and the has jumped once, we're going to set that and create that in the onUpdate loop. So what we're going to do is we go here, right above we have an if statement. This game object, and then we call the isGrounded function. IsGrounded function. What this is going to do is that we're going to check if the player is grounded in this frame, and we're going to create our has jumped once attribute here. So by just calling it as if it were already existing, we're going to assign something to it, even though we haven't created it here, it's a bit like the same principle here where you can create it within the constructor in JavaScript. So this has jumped once. I'm gonna put it as false. So as long as the player is grounded, we consider that they haven't jumped once. So as soon as they hit the ground again, this is false. And now this dot time since last grounded is going to be set for the first time here by calling the time component, which gives the current time. So every frame we get the current time and replace it and assign it to this time since last grounded, which allows us in the player controller, the set player controls function, to basically do a subtraction here between the current time when the space key is pressed versus the time when the player was last grounded. And if this difference in the subtraction is less than the Coyote lapse, that means less than 0.1 second was elapsed, then we can allow the jump. And then here, I'm just going to copy this code right below where you can do this. So here it is, and I think there's better optimization here you could do. Potentially you could transform this into a single if statement, but let's keep it that way. So we jump this game object dot jump, this jump force, we do the jump. Then maybe right before we set back the has jumped once to being false again. If we don't do that, the player is going to be able to jump infinitely. So let's try it out. So I'm going to open the game. I'm pressing enter, pressing enter. So I have my character here. If I drop, well, okay, there's an issue. If you hear the sound is playing twice, and we don't want that. So we need another, I think I'm missing something. We need here to set the has jumped once to being true. Because let's say the player jumps normally in a normal situation. If we did not have this, it's going to move on to here and it's going to play this sound again. Because we put this check as a guard against this, but because we haven't modified the has jumped once, we haven't set it here to being true when the player actually jumps, that's why it was playing a second time. So just to summarize, we didn't have this, which means that when the player pressed the space key, this is executed, so the player jumps. Then we go to the second if statement, but because this has jumped once has not been set to true, it's false, then this is likely going to pass if it's below 0.1, and it's going to jump again, make the jump again, and play the sound again. And this, because this is done instantaneously, like executed very quickly, it's going to be it's going to play the sound twice, and it looks like the player the sound is going to look very weird. So that's the issue. Now if I go back, alright, it's fixed. Now if I go here, drop in the air, yeah, so it's a bit hard to, here we go. Okay, I still hear it twice though. So there might be somewhere else we're missing it. Let me check. Maybe if we added a third condition, that would fix it. So if I add sorry, I'm troubleshooting live. Okay, if this has jumped once is false, let's do this and let's see what it gives. Okay, well, there's a bunch of oh, this is very strange. I did not have this bug before. Oh, I see. You should put this to false. To true. So this was true, and here this is the issue. We need to put has jumped once to true again. We don't need this condition at all. And I think we might refactor this live as well. So if I go back, I jump, I jump, I jump again, and here we go. Everything is fine. The sound is not played twice, so that's we're reassured that it works. Now, I see a lot of logic that could be potentially fixed here. I see a lot of repetition, so let's try to refactor this live. I didn't do this in the original project, but yeah, this is coding. You learn, you have bugs, and you fix things live. So now I'm gonna try having only a single if statement. So I see between the two if statement that we need the thing that is reoccurs is the this.gameObject.isGrounded, and the other thing that reoccurs is that we want to make sure that this has jumped once is false. Now, I don't like to have ifs within ifs. If possible, I would like to avoid this situation. And the way you avoid this is simply to do the reverse. So, if the player is not grounded and they have jumped once, we return early. We return early. So that means that the code that comes afterwards will not be ran. I don't know how to use the past tense, it seems, when it comes to run. Anyway. Alright. So now we can have another if statement below, but is on the same level, which makes the code very easy to read. And this if statement, what it is going to contain is this. So if time dot this time since last grounded is inferior to this dot Coyote lapse. Actually, if it's not the case, so we want the reverse of the situation. So if the difference in time is bigger than the time lapse we allow for jumping for the Coyote time lapse, we return early as well. This way, if any of those conditions are not fulfilled, we actually do the jumping. So we do this has jumped once equal true, because now maybe we should do this last. This dot game object dot jump, and then pass in the jump force, the this dot jump force, then we play the jump animation. Now here we should have an if statement, so only if the current animation of the game object is not the jump animation, then we play the jump animation. And finally we have this has jumped once set to true. Alright, you see that this is much cleaner code, much easier to understand, and we have avoid a lot of embranchments. So yeah, now let's test it out to see if it's equivalent. So press enter, and then oops, maybe. Alright, it's equivalent. It works, no bugs, and is shorter and more concise. Now the reason I wrote the first code that you see that was a bit more messy is because I was discovering how to make the game in the first place. So it's much easier to come back later and refactor. So I hope you learned a thing or two here. And yeah, so prefer to avoid if statement dot within if statements or conditional logic, branching logic within an already conditional block. this is going to make your code much easier to read. And the way you achieve this is by doing the reverse of the condition and returning early whatever possible. So here, instead of checking if the object is grounded and that they have not jumped once, and then writing the logic within the if statement, I do the reverse, so that this if statement is only a single line. And by using the return early, it allows us to have conditional logic where if this condition is not fulfilled, we do not proceed on. If it is fulfilled, we go to the next line, and then we check this condition. And if it is fulfilled, then we continue and do the actual logic that was previously in a within brackets and branched. Alright, so now what is left? Coin collection, and basically keeping track of the coins being collected. So to do something like that, we're going to create right below the set player controls and here a enable coin pickup. And this is going to be a very simple feature to implement. In this method, what we're going to do is that every time first we need a collision event. So this .gameObject.onCollide, so this method is provided by Kaboom when your GameObject uses the area component. So it allows you to check for collisions, and the first param is the tag of the other object you want to collide with, and for this purposes it's coin. For our purpose it's coin. And if you remember in the general mappings here, we assigned to this symbol, we created this GameObject, and this GameObject has a sprite, coin, area, and uses the tag coin. So all coins in our game have this tag, which makes it easy for all to check collisions with every coin the player encounters. So the second param here is a function, a callback, that is going to fire when there is a collision. And within here, we just do a this.coins++. I think we have created this property. If not, let's just create it real quick here. So just to keep track of how many coins the player has collected, here we'll put it to 0. And then, I'm just trying to find my space here. So this.coins, and then what we do is we call the destroy function. Kaboom offers this, and what you can do is you pass in the game object you want to destroy. Now, I said that the second param of the onCollide function is a function that you pass in, but there is the option of passing in the game object. So if you name a param here, Kaboom is going to pass the target game object, so the coin here. So you could have named this param however you'd like, doesn't matter, but it's just a way to reference it here so that you can use the destroy function on it and it will destroy the coin. Finally, we want to play the coin sound, so the coin collection sound. I think we have imported this in our loader, I'm not sure. So if it's in the sound, it's not here. So let's add it. So load sound, and then coin, and then sounds.coin. I think it was coin.wav. If I look at the sounds folder, coin.wav, exactly. So coin.wav. Oops. Oh, alright, so we have it here loaded, and now the only thing we need to do is to enable the coin pickup. We go here and then right here, player dot, so in the main.js file, under our level 1 code, we add the enable coin pickup function, a method that we call. Now if I look at the game, it's load. So there was some freezing, a weird little bug. Okay, alright, now it works. We hear the sounds now, and now we can collect the coins. You can see that the coins are being collected, and that's really great. And now I think that's basically it. Let me just collect everything. And then of course this. Alright, so what we want the gameplay of a game to be is that when the player collects all of the coins, we move on to the next level. But before doing that, I think it might be a good time now to work on the UI. Alright, so let's implement the UI that is going to display the player count, the number of coins the player has collected. To do something like that, we'll first have to go back to our UI manager and add a bunch of methods to draw the UI for this. So let's get started. So first we need a counter. So I have here maybe at the top corner, at the top of the file, sorry, not top corner, I'm gonna create another method called display coin count. And by the way, at the same time, we're going to display the lives count as well. So let's create also a display lives count. And then here again, we need to pass in the player object here. So now what we're going to do, let's start with the display count, and then we'll write the logic for the display lives count. So here, this is where we're going to create the coin count UI. So coin count UI, and basically in this attribute we're going to store this. So we have the add function. We're going to add an array of components. The components we're going to add is going to be the following. So a text component to display the text. This time around, the text, we're going to pull that from the player.coins property. So if you go to the player.js, you see that we have this coins property. We're just going to access it. Now, normally in traditional object-oriented programming, you would prefer not to do that, because simply you would have a getter and setter. But you know, it's a bit tedious to do that, so let's just access the properties we want directly, like that. Alright, so what we do is it's going to be a fraction. So we want at the same time the player's coins, but also we want to get the full coin count. So the full coin count is going to be like the numbers of coins we want in total in our game. Now, if I remember correctly, I think we're going to set this up somewhere else though, not in the class manager. Yeah, so let me just look into it real quick. Alright, so I'm gonna change a bit the approach here because this is not required, this is unnecessary. What we need to do is we're just going to pass an empty string, and later on in the player logic we will modify the content of this as the frames update. So we will display the actual full coin count there. So bear with me here. So we still need to set the font we want to use, so the round font, and the size, so size 50. However, as the second component, you can, in Kaboom.js, you can pass data as an object in your list of components. So if you want, for example, your coin count UI game object to have some data, some properties, you just pass in an object with the properties you want to create. And here, I'm just going to put the full coin count.get. And this is how you could make games without using object-oriented programming. So without using class, is by using this heavily. I've did this in previous tutorials you can watch on my channel, but for this one I really wanted to test out the object-oriented programming approach just to see. I'm starting to see both the advantages and the inconveniences that comes with it, and I think for my maybe future tutorial I'll probably have a hybrid approach, or I'll go back to just functions. We'll see. So we need to write the get coin. So this thing, what it does, so one thing at a time. First of all, you can pass in objects with the properties you want in Kaboom.js, and it will add those properties to the game object that is created. Secondly, we use here the get function, which is something provided by Kaboom that allows you to get all game objects with a certain tag. So you remember the coins, they had the coin tag. So by doing a get coin, it's going to get all the coins. And you also need to use the recursive true to get really all coins. Otherwise, it might give you an empty array. So be careful with this. Add this second property as well, your second param. And then we are only interested in the length of this array, which is going to the get function here is going to return an array of the game objects with the coin tag here. So we just want the numbers of them, the how many of them we have. That's what interests us. Now we also want to use the fixed component because we want the UI for the coin count to be fixed, so it doesn't move with the camera, and we're going to set the position to be 70 by 70. This is just what looked good. It's going to appear at the top left corner. Now what we're going to do right below is again access our coin count. I have trouble pronouncing this, coin count UI. I'm gonna add to it a child game object. I think I've did this in the past in this tutorial, so you should already know what it is. And I'm just gonna create a child game object and pass in the following components. So the sprite we want to use is the coin icon, so we want a coin icon near the coin count, and then I'm just gonna reformat this so it looks nicer like that. Then we want the position minus 60 by I think 0. That would be a good position. So it's an offset, of course, so it's going to be on the left corner because we do minus 60 relative to the position of the coin count UI, which is the parent that is positioned at 70. Alright, I'm gonna scale this 3 times. This is because otherwise it's too small, the icon. And of course we need to make it fixed as well, so that the camera that is not affected by the movement of the camera. So once we have this done, we need to import this icon. So let's go back to our loader and let's simply load, not in sounds. We want to do that here in the sprites, maybe here near the coin. Load sprite coin icon. Then the asset for this is /asset/ so I don't remember the path, so I'm just gonna do a control P and then search for it. So we have coins UI, so it's called coins UI.png. Now if I go back to the UI manager, actually we need to write some logic in the player code before it's going to appear, because the player class is going to be responsible for updating that count. So what I'm going to do is I'm just going to go there and we're going to write a new method right below the update. I'm going to call it update coin count, and here we want to just have the coin count component. So the coin count UI from the UI manager class, we're going to pass it through here, and then here we're going to use an on update again. So you're not limited to only one on update. You can create multiple update loops, and they're all independent. So they will all run 60 times. I mean, every frame, not necessarily 60 times, depending on the frame rate of your game. So here, I'm gonna just do a coin count UI and then access the text property from the game object. This is because we used the text component back in the UI manager. Because we use that component here, we have access to the text property and we can assign a new text. And here we're going to use a template string, and basically we're going to put in the $sign like that. So I'm gonna get the coins. This is a property, an attribute of the player class. So the current number of coins collected. We're going to later on, I think it's updating this already. We wrote the logic for this previously. In the enable coin pickup, we increment this attribute when a coin is collected. And then what we're going to do is just take the coin count UI and access the property we created here, the full coin count. So I'm just gonna use that full coin count. I think it's properly written. So once this is modified, I think that's basically it. So for now, that's it. And we just need to go back to our main JS file and the code for our level. We just need in our UI manager. So we have the UI manager here. So we were just going to first do a UI const first for the coin count UI. Well, actually, you don't need that. We can just first we call the UI manager with the method display coin count. We do this. I would prefer to maybe do it last, just in case it could interfere with the camera. There's no worries to have here, but just for structure, we display the UI last because it's the last thing on the screen we want to put on the topmost layer. But it doesn't matter actually. But anyway, this will display the coin count, and then here we can have the player.update coin count method called, and here pass in the UI manager with the coin count UI attribute, and this is how we pass it through. So I do this, and let's look at our game. Press enter, and you can see as I collect coins, it appears. Now the reason it's here and not here is because we're going to add the live count in a moment. So how many lives the player has left. So just to test that everything works all right, collect 9, 10, 10, 11. There should be 17 in this level. And yes, there is. Nice, it works. So let's go back to the UI manager. Now let's write the logic for the display lives count. So let's do just that. And for this piece of code we need to write here, we are just gonna create, again, it's going to follow roughly the same structure as the previous method we wrote. We have a lives count UI capital, yeah, which is going to contain a game component, game object, and then we use a text component again. And now here, because we pass in the player, we're just gonna display the player not live. It doesn't matter actually, because the player code will take over as soon as possible. We just need to use the text component here because we want to set the properties. So let's do that. The properties are going to be the same thing, font being round, and then the size being 50. And then here again, same thing, fixed so that it is not affected by the camera. The only thing that changes here is the position. We're going to go with a 70, 10. So it's going to be above the coin count. And finally, we're going to add a child to it, which is going to be the logo. And here I've decided on the star logo being the live, the representation of a life, of an extra life. Now, you might say that this isn't a good choice because traditionally stars are what you collect at the end of a level, but there isn't a heart icon, so I thought that I would just use that then. Okay, so here we're going to use the sprite star icon. We need to import it in a second. I'm then going to put the position relative which is relative to the parent, of course. That's minus 60, minus 5. Again, this is trial and error. Try playing with the values and you'll see the result, and it will allow you to have a better understanding of what happens. Of course, I scaled this 3 times because this is what looks good, and I fixed this again so that it is not affected by the camera. Alright, so we have this. Now we go to our loader again, and in the loader we're going to load the sprite for this. Load sprite live icon. I think that was the name. Maybe it wasn't. Sorry. I need to just go quickly here. Not player, the UI manager. Let's close some tabs here. Alright, so it's star icon. I go back here, not live icon, star icon. And as for the name of the assets, and then probably it's called stars UI, so the same naming convention, stars underscore UI.png. Alright, so now that this is loaded, we go back to the UI manager. Everything seems to be set up. I think that's basically it. Yeah. And then in the player code right above, we're just going to write the update logic. And then again, we can use an onUpdate loop. So here it is, update lives. I'm going to call this method. I'm going to pass in the lives count UI though. And then in there, whoops. Sorry. Here it is. On update, again, pass in the callback. And here we just do a live counts.ui.text because we use the text component. And we're just going to pass in the live. So this.lives is enough. Now let's go to the main.js file, and this is where we're going to set that up. So UI manager dot display lives count, and then player dot update lives, and then UI manager dot lives count UI. Oops. Alright, so this should be done. Now let's look at the game. You see, we have the live count here. So to see that the lives count, if I kill myself here, it isn't updated properly because we haven't written the logic for that in our player code. So what happens is when we call the respawn player, we need to subtract the life. So where is it? Respawn player. Yeah, this. So if this live is inferior to 0, is superior to 0, we respawn the character. But before that, we would decrement the lives counter. This dot lives minus minus, and then it should work. So if I drop here, it goes back to 2, 1, and then finally 0. And then the 0th, that means you have 0 extra life, and then if you die now, it's game over. But it's a bug for now. So this is definitely something we need to fix. Alright, so let's work on the game over logic, I guess. What happens if the life of the player is inferior to 0? If is equal to 0, that means that they have no extra life. The respawn player function needs to do something special, like needs to take care of that case. And what we can do is just we use the go function to go to a specific scene. So I'm gonna go to the game over scene. So if I go to main.js, you can see the game over scene was defined here. It was created in Kaboom using this function, the scene function. And so now if I test this out, press enter, press here. Let's say I die 3 times. What? Why did it move me to the... That's strange. Let's do it again. Oh, I forgot one thing. I forgot to, in the player code, to put a return statement, so we return early in that case. So we do all this logic, and then we return early so that it never moves here if we executed the logic here. If we respawn it, if we actually respawned, then we do not need to go to the game over scene. So now this should fix it. Press enter. I respawn. Respawn again, and I have 0 extra lives, and now if I die, I go to the game over screen. Alright, later on we're going to work on the game over screen itself and how to come back to the game, so if the player wants to try again. Alright, I think the only thing left for this, for the UI, is to put a black box, because sometimes in some of the levels the visibility of the text is not going to be great because it's white text, and I thought the simplest way is just to constrain this UI containing the live count and the lives count and the coin count to being under a black box. So to do something like that, I'm just going to go back to the UI manager. I'm already in the file, and we're going to just have another method. I'm going to call, I think I'm going to call it add dark background. Let's put it at the end. Add dark background, or simply shortly put add dark BG. And then inside of that, I'm just going to create a game object. I do not need to assign it anywhere. I'm just going to use the rectangle component, rect, which allows us to draw a rectangle of the width of 270 and the height of 130. And the reason I'm doing this is just what looks good. So you can test, go and play with those values. Now we're also going to use the color component. So all of these components come from Kaboom. And as I said earlier on, go to kaboomjs.com to see the list of components you can use. So I'm going to use 0, 0, 0, so you can specify RGB values. There's also another way to use this color component where you can call the color constructor class and do a from hex and then type in the hexadecimal value you want. For example, white, like that. So this is also an option, but for our purposes, we don't need that. We just want a simple black, and we can just specify the RGB values here. And then of course we need to make this fixed so that it does not depend on the camera, does not move with the camera. Now I just need to call this. So I'm gonna go to the main, right at the end, UI manager dot add dark background. If I go check the game, yeah, you see, actually we shouldn't add this at last. It's going to draw the rectangle over the UI, and this is not what we want. So let's change that. I'm gonna just remove this and put it before everything. So here should be the proper place, and now it's going to draw it properly. So if I press enter, you can see that this nice little black box constrained the UI, and so that even if we have a level where the background is blue sky of a light blue, it will still be very visible, the text of the number of lives, etc. So now the next thing we're going to implement is how to go from one scene to another, to the second level when all of the coins are collected. So let's work on that. So to achieve something like that, we're going to have to write some logic in the player class. Alright, we're just going to write this logic in the update coin count. So right below, as an if statement, if this dot coins is equal to coin count UI dot full coin count, this makes sense to put it here because we access how many coins there is in the level here. So if this is the case, we're simply going to go to this. So first we're going to do a check if we are in a terminal scene. So a terminal scene is basically a property I have defined here, which we tell the player object if we are in the last level. So I should call it something else. Let's refactor that. So rename, change all occurrences, and I'm gonna say is in final level instead. That is a better name. So we go down. So if we are in a final level, then we go to actually, if this is in final level, we will use a ternary operation. We will go to the end scene. Otherwise, we will go to the current level scene. So this is another property I passed to the constructor where we tell the player game object, the player class, in which level the player is. So by specifying the number. So here I think I haven't added it. Yeah, we should have definitely added this. Current level. And then here I'm just gonna set this. Oh, we have it here. This current level scene, it's actually here. So it's right before I did not see it. So let's remove that. And then, yeah, so this go function will go to the end scene if we are in a final level. Otherwise, it will go to the current level plus 1. So to move to level 2, for example, if you're in level 1, you're going to move to level 2, etc. So that's the logic. Now if I go to the main.js, just so you can see, we passed in here the value 1 for being the current level scene. So we are in the first level. So we're going to increment 1 to that when we want to switch to go here to the second level. Now here the false value here because we are not in the final level. So we put false here. All right. Now if I test this out in the game, press enter, press enter. Let's collect every single coin in this level. So for now it's very easy. There are no mobs that could put an obstacle in our quest for more coins. So let's do that real quick. And here is the final coin, and we have moved on to the second level. Now there's nothing in the second level, and this is something we're going to work on. We've already created our first level, and to create all the other levels, we're going to follow a similar pattern that we did for the first level. So I'm going to create inside of the content folder another folder, and I'm going to call it level 2. Once this is done, inside of this, we're going to create a config.js file and a level 2 layout.js. So level 2 layout.js. All right, so we have both of these things created, and really it's basically the exact same configuration. So I'm going to copy this as well. And the reason we want to create different files here is because sometimes you want to test things out on specific levels and you want the configuration to be different. So that's why you have different config files. As for the level layout, things gonna change of course in the layout, but as for the generating mappings, we can just copy over what we had in the first line and just replace the content. So I'm gonna go here, and instead of having grass here, we're going to go with bricks. So brick. Just to make sure that I'm actually doing this correctly, I'm just going to do a Control P and see brick. Yeah, brick one way and brick tile set. So it's brick. All right. Now we of course need to import these tiles, the brick variation. So if I here in the not general mappings, but in the loader, we had previously imported the grass one way tile set. So we're just going to copy that over again and replace grass with brick, which is the other variation. So here I'm just going to put brick. Here as well, I'm going to put brick. And you also need to remember to change the file names because they're different. It's brick with capital. If you look at your asset folder, you should see this very easily. All right, so after having imported the assets here, we just go back to the level layout, and here we're actually going to do the layout. So I have const 2. I need to change this from 1 to being 2, so level 2 mappings. Then here bricks, we import the generate mappings function from the general mappings.js file, which is right there. We used this for the first level. And then right below, we're going to export the const level 2 layout. And for this layout, I'm just going to copy it over from the original code base. This way, it's going to be much faster. So let's do that. And after I will just go over it. So you yourself could do this as well, and you can play around with the values. So I'm just going to find it real quick. All right. So let me just copy that. All right. This level only really has 2 layers. So then again, we have the layout, which is going to contain multiple layers, and we have those 2 layers. Now we need to fix the formatting a bit here. I need to do that so that it looks nice. And here I need to also fix the formatting with the tab. And here we go. Everything is set up. So just so you remember, each number here, each character corresponds to a specific tile that was defined in the generate mappings function. We're just swapping out the places where we are using the grass tile set with the brick tile set. So if I go here, you can look that I've used a template string where I pass in the tile type dash tile set, and this is the name of the asset in our loader. So if I go to the loader, you can see that brick one-way tile set, and you have the grass version as well, grass one-way tile set, for example. So now if I go back to the level in our game, our second level, I have coins, everything is the same, a different layout of course. But now each tile that used to refer to the grass tile set is going to refer now to the brick tile set. So it's going to look very different. And here on the second layer, I just added 2 coins here. So they're going to appear here and here. Actually, I think we could get away with not having this second layer and just try to put the coins here instead. So I'm going to do just that. I'm going to put this here, and then I'm going to add 2 coins here and here. Now I'm just going to remove this second layer because we don't really need it anymore. So I'm going to remove all of that code. Now, once I have this, so we have our layer, our level layout, we can simply try it out. So I'm going to go to the main.js. We're going to follow the exact same structure as the first level, but we're going to swap a few things. So I'm going to copy this and I'm going to paste it here. Now, of course, here I call it level 2 draw background. So here the background is going to be different. And let's import the background real quick. So in the loader.js file, I had the background imported here, so we could add it right here, load sprite. And now this is the castle background we were going to use. And the path for that is asset / I don't remember, so I'm going to look it up. Castle underscore background underscore 0. So let's write this. All right, here, castle underscore background underscore 0. So basically the name is the same naming convention as the first asset here. So once we have this done, I save, of course. And now back to the main.js file. We're going to simply draw the castle background. So we can use the castle name that we defined in the loader. And here I'm just going to replace every level 1 with level 2. We need to replace this with 2s as well, but we need to import the mappings. We need to import this thing. So if I go up the file, you see this? Well, we're going to write the same below, but with level 2 layout and level 2 mappings. And right below or right above, yeah, right above the config. Now, thinking about it, maybe we should have put even the config within the same file. So instead of having a separate config.js, do as you please, but for this, I'm just going to keep it. So I'm just going to write the import statement correctly here. So level 2 config. Once this is imported, I go back here and I'm just going to swap this out with level 2, level 2, level 2, level 2. And then specify here that we are in level 2 to the player object. Then once this is all done, I think here we need level 2 as well to draw the waves. And here instead of water, I'm going to pass in lava. And I don't remember if we have actually imported the lava in our game, in our loader yet. Water is here, so we need lava. So let's add it right below. So same structure. I'm going to copy and paste it. I'm going to just put lava here. Of course, you could create some logic to maybe create a reusable function that creates the load sprite declaration here for the various types of waves. So there's a third one later on that is going to be clouds, but for this tutorial purposes, it's not necessary. This is something you would do if you really want to keep your code clean. So you would do that. Now for the file, I think it's called lava.png with a capital L. So let's write that. And if it doesn't work, I mean, it's not that, and we're going to fix this in a moment. All right, so I have added everything we need. I think nothing is missing. So let's look at the result. Press enter, press enter. So now we've already wrote the logic to move on to the next level. So what I'm going to do is simply play my own game and then arrive to the end. All right, so only 10 coins left. So now there is no mobs, and we're going to add mobs after having added all the levels. That way it's going to be much straightforward. So you see, as soon as you collect all the coins, you're going to move on to the next level, and this is how it looks in practice. So you have a bunch of platforms, you have the castle background, I have the coins collected. So everything seems to be working all right. All right, let me just put everything, and we move on to the third level. Now we need to actually do that for the third level, and basically the same thing again. So level 1, level 2. I'm going to create another folder. I'm going to call it level 3. Now what I'm going to do here, I'm going to create again a config.js file. I'm going to create a level 3 layout, level 3 layout.js file. Now I'm just going to copy the content of the level 2 config to the level 3 config. Now, okay, so level 3 config is here. And now for the level 3 layout, again, I'm just going to copy the same thing here, just do a few name changes. So I'm going to change here to 3 and here to 3 as well. And here instead of brick, it's going to be clouds, I think. So I just look it up quickly. Rock, it's going to be rock, the name of the sprite we're going to import. And then for the actual layout, I'm just going to copy it over from the original code base that I've made, just so that it is convenient for you. You can do the same, as it's a bit tedious to copy this manually. So I'm just going to do that, and just going to do this as well. All right, we have it seems that I've created another layer that is not useful, so I'm just going to remove it. So yeah, so that's the layout of the third and last level. And now let's do the loader thing. We need to import the assets for this. And like with the brick assets, it's the exact same thing, just the name is going to change. Oops. The name is going to change of the asset, and yeah. So instead of brick, instead of brick here, it's going to be rock. Lowercase, sorry. Instead of brick here, it's also going to be rock. And then here as well, it's going to be rock tile set instead of, and rock one-way tile set as well here. All right, we have this all configured and set up. Now, I think, we need to load the clouds. So I think it's the same thing, cloud. And then here it's cloud.png. If it's not the case, we will soon find out. All right, everything is loaded. Now in our main.js file, I'm gonna copy this code as this import statement and really just do the same thing again. Right down below, I'm gonna put the Kaboom here, put level 3 config, level 3, level 3. Now you need to modify here the path to be level 3 folder instead of level 2 folder. Here, also the name of the folder, but also the name of the file from which we import. It's level 3 layout.js. Now I'm just gonna copy code from level 2 and paste it in level 3. So we have this, everything seems correct, and then we just change a few things. Now 3, 3, and here 3 as well, 3, 3, 3, 3, and this is going to be 3. This we tell the player object that we are on the third level and that this is a terminal level. So once they beat that level, the game is finished. So we're gonna pass in true here. If you remember the properties we had, here is in final level. This is true. As for what we're gonna draw here from the level 3 object, instead of lava, cloud. And basically the rest is the same. Let's play our level. Oh, I guess it's not called cloud. So I'm gonna go to the asset folder and clouds. Okay, it's clouds with an S, which makes sense. It's plural, so clouds here. And here I'm not sure if it's clouds or cloud. What did we put in our? What did we pass into our level 3 layout? Okay, here we should pass cloud. Rock. It doesn't matter. It doesn't matter. What matters is in the level.js is where the draw waves, it passes in the type. So it's dependent on what we pass to main.js. So if we pass in cloud, the assets should be named clouds. So I'm just gonna put S here for clouds, and then in the loader, the name of the sprite we're importing is also going to be an S here. Once this is done, I'm gonna play the game. It's failed to load image from rock one-way PNG. Okay. I guess it's not called rock one-way. So if I look at the code, you have grass rock, not just rock. Okay. So while I use the name, I need to add grass rock because this is the name of the image itself. So grass underscore rock, and now things should be working. And yes, it is. Now I'm just gonna play my own game quickly, try to collect everything. And then once I collect everything, we need to make sure that the transition between each level is working. So I'm gonna have this, and then we can focus on the mobs. And then after having coded in the mobs, we're going to focus on the sounds, the sound effects, not just the sounds effects, but the background sounds, like the sound of lava boiling and stuff like that. All right. Okay, there's one thing, the background. Otherwise, yeah, the layout is correct, but the background, we need to change it to the sky. So for the third level, we have 3 different backgrounds. We have sky background 0, 1, and 2, and we need to all import them all. So let's do just that right now. I'm not gonna type this out manually. I'm just gonna look at the code base, what I've written. I think I should find them and then copy paste them. In the meantime, you can do the same thing. Wait, I cannot find them. Forest background, grass tile set, fish, castle background. Okay, alright, I found them. I'm just gonna copy. So here, simple asset import. I'm gonna go exactly right below the castle assets here and just import what we have here. So here we go. Maybe it's, yeah, maybe it's fine like that. Now in the level, we need to draw them in a certain order. We need to, yeah, so here, if you, I'm not sure if you have seen, but if you go to the loader and where we have imported the assets, we've named them sky background 0, 1, and 2 as the name we're going to use. So that now if we go to the main.js file and where we draw the backgrounds, I think it's here, I'm just gonna type in those names. So sky dash background dash 0, which is the farthest layer. Then we're gonna add 1 and 2 as well. So 1 and then 2. So those layers are drawn on top to give the clouds, and yeah, you're gonna look into it. Yeah, so let's just look at the file first. So if I go to the assets, just to understand why we were drawing 3 backgrounds, you have 0, which is the farthest, and then there are some clouds on top, and then some other clouds. And all of them juxtaposed are going to give the final background we want in our game. All right, I'm gonna play my level. Now, just to test things very quickly, instead of having to play it all again, here you can specify the scene you want to go immediately from the main so that you don't waste your time. And here we go. We are in the last level. And that's the reason why I created this black box for the UI, so that it is not obscured. Yeah, so that's that. All right, what happens when you collect all the coins? Well, first we need to complete this level. It's gonna get much more complicated with actual mobs, but yeah, there's only 7 coins. That's why, because it's really hard. So let's do that, and you're brought to the last scene. All right, sounds good. Okay, and now this is done, and we can go set this back to being start from the menu. And now we're going to work on the enemies, so the various entities, and then as the last step, so the way I'm going to structure this is we work on the mobs, the various mobs. Once this is done, we work on the sounds, and then when this is done, or at the same time, we work on the GameOver screen and the U1 screen, because those are going to be very simple to do. Or we could do them just right now. Yeah, I'm just thinking, yeah, let's go with the mobs, because this is the actual gameplay stuff, and yeah, and keep the easiest thing at the end. So let's create our first mob, which is going to be a fish. To achieve something like that, we're going to use the entity folder heavily. I'm going to increase the size of my screen a bit, maybe a bit less. Yeah, so I've been writing my code up until this point in a really big font, but I think it's valuable to have a bit of a state here. So I'm going to try to do some editing stuff to make the experience enjoyable, hopefully. So in the entities folder, I'm going to create our first entity, and let's start with the spiders. So I'm going to create a spiders.js. So You could say there are spiders or lizards, depending on how you look at it. We're talking about those spiders here. So some people who have played the game think those are lizards, and it makes sense a bit. So yeah, let's write the code for this entity. So I'm going to create here a class, and I'm going to call it spiders, and we're going to export this class. Now, once this happens, what I'm going to do is we're going to work on range, add two properties, range x, and then range, I think range x and range y. Actually, this is not necessary. I'm gonna increase the font, I guess, after all, just so it's more comfortable to look at. All right. So let's create our constructor. And this constructor is going to pass in two important pieces of data: the positions of all the spiders we want to put in our level, and the amplitude. So amplitudes, by this I mean how far will the spiders go back and forth. And finally, the velocity. So I think a small drawing would clear up a lot of things, so let's do that. So I've opened the handy ScalaDraw, and let's draw something. So let's say I have the ground here. I have my spider, which is going to move left, back, and forth. So this movement, this range of movement, I call this the amplitude. The velocity is the speed at which they move, and finally the positions is where the spiders are. So I hope that was clear. So this, let's set everything out. So this positions, this amplitudes, we're going to set the amplitudes as an attribute of the class, a property, I guess, and velocity as well, velocities as well. So this should be plural because we're creating multiple spiders with this class and not just one. So here I'm gonna put the velocities. So those are both set as class variables, I guess. And it's going to make it handy for us later on when we want to access them to create the AI, the pattern, the movement pattern for the spiders. So what comes after that is we're going to create this dot spiders. It's going to be in an array that is going to contain the game objects of all spiders we create. So here we're going to do a for loop, and we're going to use a const or const position of the various positions we have entered. For each of that, we're going to append to our array. So spiders dot push, and then add. And here we use the add function to create the game object and then push it to our array. Push the reference that is returned by the add function to the array. So here I'm going to use the sprite. So here the sprite we want our sprite to be configurable because there are two types of spiders, one of the first level and the second one is on the second level, which on the first level the spiders are green and red, while in the second level they are orange and dark blue, I guess. Dark blue grayish. Okay. So here you're just gonna use the same convention we used for the style set where we're going to pass in a template string and only change the type here. And as a fourth param, we're going to specify the type of spiders we want to create. So here it's either type 1 or type 2. Now, I've been using JavaScript here, and I was wondering if you're arriving to that point, would you be interested in a TypeScript tutorial on how to make games in TypeScript? If you're interested, feel free to leave a comment telling me that, just so I can know if it's something that you would like all to watch. All right, let's proceed. Here we're going to have a default anim called crawl. All of this has not been yet specified in the loader, in our loader that loads the asset, and we're going to do that in an instant, but for now, bear with me. All right, so we use the position component and we just pass in the position. So those, because of this, you're probably already guessed that positions is going to be an array of vector 2s. Finally, not finally, there's still a bunch of other components that we're going to add, but this one, the area component with a specific shape. This time around, we're going to use a rectangle instead of having the default shape. Like with the player, we did the same thing. And as I said, when you use the shape, you create a rectangle. The first param is the position of that rectangle relative to the player, the spider here. So I want it to be positioned at x0 and y 4.5 plus, well, the position of the spider plus 0.0 plus 4.5, which is the hitbox where it's going to be. Play around with those values and you'll see, you'll get a pretty good understanding. And then we want to position, we want the width to be 20 and the height to be 6. That's that. And also we're going to add another thing, another property that is offered by Kaboom when using the area component, is the collision ignore property. And this allows you to specify a tag of entities or given a game object you want your current game object to ignore collisions with. And this is really good for performance, but also when you want, for example, that if you have more than one spider, they don't overlap with each other. So one goes on top of each other. Here again, a drawing is going to probably explain it better. So I'm going to reset the canvas. And then here I'm just going to draw. So here, assume you have a spider that is walking here. And then you have another one. So just to be lazy, I'm going to copy that. I'm going to paste it. I'm going to, can I use a mirror? Can I flip it? Is it possible to flip it? Looks weird. Looks very weird. You know what? Let's just redraw another one. So let's say we have another spider here. Now the issue here, I'm gonna put them within a hitbox, is that if you do not put the collision ignore, what happens is that, let's say our spider are moving left and right and they're about to collide. What happens is if you don't have the collision ignore, they're gonna go up and then push each other, and this is not what we want, and it's going to make the game unpredictable because the behavior, like for example, this spider pushes this way, and then instead of the spider being used to going left and right, well, it's going to be pushed over. Let's say it falls down and then start moving here, and then it becomes unpredictable, and some mobs can fall down and be out, and that's not good. So let's here put the tag for the spiders. We don't want spiders to be affected by others colliding with other spiders, so I'm just going to add spiders here. But then there might be a question in your mind. Well, if you're adding the spiders here, how do you know that this is a spider? Well, we need to add the tag to this game object as well, and usually I'm going to do this at the end, spiders here. Now again, I'm going to use the anchor component to have the hitbox and the drawing of the spider centered instead of from the top left corner. I'm going to use the body component, so it is affected by gravity, because we want the spiders to be able to jump, and you need the body component for that. You need it to be able to be affected by gravity. Then I want to scale this 4 times, and this is a current thing, so that all the sprites are big enough to be seen. And then finally, 2 things. We're going to use a state component, and if you remember, we used a state machine for the blinking text in the UI, and now we're going to do that again, but this time around to code the enemy AI, so the spider's AI. So the spider is AI, so it's going to contain 4 states, 4 or 3 states. So the first state is default, is idle. The default state is going to be the idle state. Then we'll have simply 2 other states, so 3 states. So you have to put the state, all the states as a list here as the second param. The first param is just to define which is the which states you want it to be the default. So that's that. So here we will have crawl left, and then crawl right. And then the last component we're going to add here is the off-screen component, so that when the enemy, the NPC, when the mob is out of the camera's view, we're going to stop any collisions, any computation, and this is going to be really helpful for improving performance. All right, now that this is done, we can focus on creating the AI, which is actually a pretty interesting thing to do, and it's not all that complicated. So here I'm going to create a function, a method called setMovementPattern, and this, when called, will set the AI for all spiders. Here I'm going to have a for loop that is going to iterate over all the spiders we have in our spiders array. So the way I'm going to do it here is I'm going to use an off loop, a for off loop, but it's different than what you're probably used to. It's going to also give us the index. So you do this dot spiders, which was created in the constructor, and then entries, which is going to give you both the index and the element itself. And we're going to need this so that we can assign amplitudes and velocities to each of those spiders correctly. Because the way you're going to use the spiders class is you pass in a list of position, a list of amplitudes, and then a list of velocities. And for each member of that list, it's for that specific spider. So if I go here as a diagram to make things clear as day, I guess, I'm going to, so here you have, let's say you have a list, a first list, a second list, third list, third list. Now here, let's say I want a position to be of 100, 100, that's a vector 2, that's passed to the first list, which is the positions list. And then you have a bunch of other elements as well. Here, for example, 50, 100, etc. Now here in the second list, which is the list of amplitudes, we'll have a specific range of, actually, you know what? Let's rename this not amplitude, but range. It's a much more descriptive name. So I'm going to go to the code base right now, and where I put amplitudes, I'm going to just put ranges. So it's the range from which the spider moves and comes back. So yeah, doing this. So what I'm going to do is in this ranges array, let's say I want this to have a range of 500 pixels, this 300, etc. And then finally the last is the speed or the velocity. So I named this velocity, but actually I should name it speed. So let's rename this to speeds. So yeah, I should have came up with better names. So speeds instead of velocities. I'm gonna put here speeds and then speeds. Once we are going to finish building this, It's basically the same logic for all other mobs in the game. For the speed, let's say 200, 100 pixels, etc. So the index is here is 1, the index is 2, the index is 3. So by knowing the index, I can fetch the position. Well, actually, I don't need to fetch the position because I do this in the constructor. I assign it to the game object when I create it. But this is helpful to know the index to assign the range and the correct speed you want for that specific spider. So that's why I get the indexes. Hope that was clear. So here, that's why the index, and I could have written a traditional for loop. So a for loop with an I and then this.spider.length. It's possible. You can actually do that. But you can use this, and it doesn't seem to have any performance implications. It seems to work well. Anyway, if you're well versed in this, maybe write a comment telling us if there is any hidden price you pay with this for loop compared to a normal for loop that use the index, the I. Let I equal 0, I inferior to this spiders.length, I plus plus. So this, yeah. All right, so now within, I'm gonna have to assign to an idle constant the following. So spider, yeah, so here the mistake I did, I added an S here, while you shouldn't. Whoops. Yep, I added an S here, so I'm gonna remove that. So the reason I'm assigning this, you're gonna see in a moment. Actually, let's remove it for now. And then, so spider is the game object. And when you use the state component, you have access to onStateEnter, which you specify the state as the first param, and then the function that is going to run when this state is entered. Now, the reason I'm assigning it to an idle constant here is because we want to keep track. So what onStateEnter returns is a way for us to cancel the event if we want to. And we want to cancel the event when the player leaves the scene. Because if you don't do that, what will happen is that sometimes you're going to proceed to the next level, and then you're going to hear the sound of the spider from the previous level. And because this is not apparent now because we have sounds, but you'll see, like, yeah, so this is to avoid this situation. You will not see because we're fixing it right now before it becomes an issue. So now within, if spider.curAnim, or yeah, well, actually, you see in Kaboom.js, it seems that you have the current anim function, but there's also, I think, the current anim property that you can have and check for. So let's use the current anim function. Actually, I'm not sure if it's the case, if we actually need, so I'm gonna check right now. Kaboomjs.com, maybe it's an error on my part. So if I type in cur, so yeah, this is the Kaboom.js website. You have very easy to read documentation. You have for each components, what you need, etc. So I'm just gonna type in cur. Anim is not here, so I guess it was an error on my part. Okay, so never mind. There's only the cur anim function to get the current animation. So if the current animation that is playing is not idle, yeah, I think maybe it would be handy to actually create those animations. So let's do that. So let's stop writing code here, go to our loader where we load assets, and then create the animations for our spiders. So what I'm going to do is just copy and paste the code I already had made for this. And I'm going to go through it line by line so that you truly understand how it works. And we're going to copy two things because there are two types of spiders, but they basically behave the same. They're the same sprite, just of a different color. So here is the code. Let me just format it correctly. All right. So spider1 and spider2, both, this one comes from this file and this one comes that file, and that file has 3 frames. If we want to look at it, let's look at spider1.png. You can see that it's 3 frames and it's facing leftward. All right, so here slice x 3, slice y 1. You already know why we do this. Now the anims, we're going to specify the crawl animation from 0 to 2, and we're going to loop this animation. And the idle is just going to be the first animation, the first frame. And that's about it. We do this 2 times. Feel free to copy the code. And now let's move on. So I'm going to go back to the spider's code here. So if the current animation is not idle, we're going to play it. And because this is just only one line, we don't need to have brackets. We can just have a spider.play.idle, like that. All right. Now, here, we want to have an interesting behavior, is that we're going to use a promise to, I'm going to create a new promise that is going to be awaited. And in that promise, I'm going to have this callback and pass in the resolve function here. And then call the set timeout within. So it's set timeout. What set timeout will do is it will call resolve after 1000 millisecond. Now, because to use the await keyword, I need to have an async keyword here. And now let's explain this code, what I did. So I want the spider to wait 100 seconds before proceeding on. And because this is asynchronous code by creating a promise, and I use the await keyword, the code execution will wait in this function, will wait before moving on to the rest of the code we're going to write here. So that's why it's going to, the spider is going to look like it waits for 1 second before continuing to move. And the reason, how to achieve this, the reason you cannot simply use a set timeout is because I want to block the execution of the rest of the function. And to do that, I have to create a promise. The promise, how you create a promise in JavaScript is you use the new promise keyword. It takes in a function that is going to be called, and it passes to that function through a resolve function. And then you call whatever you want here inside. And then when here, we just call the resolve function so that after 1 second, it executes this. Because it called the resolve function, the promise knows that it's finished and it can move on. So that's how it works. Maybe a diagram will help. So let's go back to Xcali draw. Again, I'm going to remove this. Okay, I'll remove this. So to explain the situation, this is how it works. So a promise allows you to create asynchronous code. It gives you 2 tools. It gives you the resolve function, and it gives you the reject function. So actually, the promise is a wrapper. So you have the new promise. Think of it as a box. You have a box in which it provides you these 2 tools where you run your asynchronous code within. So it gives you tools to notify it back when you're done with that asynchronous code. That way, when you call the resolve function within the set timeout, after having, because the way set timeout works is that it waits a certain amount of time and then calls the function you have passed in as the first param. And what we have passed in as the first param is simply a function that calls the resolve function. And then, so because of this, it will call the resolve function, which will mean that the code here will tell the promise that it has finished. It notified the promise back. And because this is now finished, the promise is considered as fulfilled. And so because we have the await keyword here, await keyword means wait for the promise to be fulfilled. The promise has fulfilled. That means we can move on to the next. So I hope this explanation was clearer. I think I could have done a better job for the drawings, and I really want to nail this, so let's start again. So what is a promise exactly? A promise is a tool that offers you two tools to notify. It's a notification system, basically. It allows you to notify your code back, I guess, when you have finished executing asynchronous code. So a promise, so you have here a promise. So you have the promise here. It offers two tools. So those two tools are, okay, promise offers you two tools, resolve, reject. Here in this boundary, you execute your asynchronous code. Async code is being executed. So code that could finish at whatever time, it's not specified. When it's finished, you want to call the resolve. So basically, here set timeout is calling resolve after 100 milliseconds, so 1 second. So what happens here is, let's say, in the bigger box, you have the asynchronous function. And here, the await keyword. So here you pass in, oops. So the resolve gives you this tool. You call this tool, which alerts this back. And then this goes from pending. So this goes from pending to fulfilled. This therefore tells the async function in which this promise is run that it's done. This means that we do not need to wait it anymore. All right, hope I did a good job. And let's move on. All right, so we have this. Now, after this 100 millisecond wait time is done, we're going to enter into another state. Or well, actually, we need to first move. Well, actually, yeah, depends. If the previous, so now we want, so the onState enter takes a function, but it allows you to pass in params to that function. So we can have here the previous state. So it's just a way for us to pass in the previous state to this state. I'm going to make a diagram for this in a moment. So if the previous state is not equal, okay, if the previous state is equal to crawl left, then we're going to enter spider.enter state crawl left again. Crawl right. So after having moved left, we go right. Now, that looks good. And of course, we want to return early, so I should have created this under a bracket. So here, like that. So we just do this, and then we return. So this is the code, and then if the previous state is either not defined, because it's the first time we enter into the idle state, then we simply will jump, do a jump, and then we're going to play if spider is off screen. So if it's off screen, we're not going to play the sound, but if it isn't off screen, that means we can play the spider sound, and it's called spider attack. And the volume for that is going to be volume 0.6. All right. And then finally, after having jumped and played the sound for the jump, the spider attack, we're going to move on to spider dot enter state and then crawl right or crawl left. Crawl left. So crawl left. All right. So I think that's it. Now, of course, we need to import this sound. So we go to our loader. From our loader, we're going to load the sound. Load sound. Spider attack. And then here, dot sounds dot spider attack dot wav. I think that's the name of the asset. Let me look at the sounds folder. Spider attack. All right, that's good. If I go back now to the spider's code, I think that's basically it. We have finished the first state. Now I want to make a diagram for this. So the way this works, it's a state machine. A state machine is comprised of states that you move from, you transition to one state to another. So here we have the idle state, the crawl left state. Then maybe you should bring this closer like that. The crawl right state. So we start initially at the idle state, and this is computer science knowledge. It's called finite state machines, and yeah, so this is just a state machine, but yeah, or automata, and they're named like that. So this is the symbol when you start into a state, and here the variable I created called previous state is null, or is undefined, not null. So previous state is undefined, so there's no previous state. So here it is. So it's not so it's just a state machine. I think there are some properties you need to respect for it to be a finite state machine. So yeah, but it's computer science knowledge. All right, from the idle state, if we were in the crawl left state before, which isn't the case, we would go to the crawl right. Otherwise, we would jump. So we would jump and then move on to the next state. So here, the next state is, yeah, so if we were in crawl left, we would move to crawl right. Otherwise, we would jump and then move to crawl left. So that's what happens in the case where previous state is not equal to crawl left. When we arrive at crawl left, we're gonna do some logic. Otherwise, if the previous state was crawl left, we move to crawl right, like that. And then for the rest of the diagram, I'm gonna do it as we go along. So let's go back to the code base. So let's write the other states. So right below here, we're gonna create a new state, and it's going to be the crawl left state. So the crawl left state, again, we created the spider, this was spider dot on state enter crawl left, and then we pass in the logic we're going to execute here. And what we do is simply we set the flip x value to being false. So by default, the spider is facing left if you've looked at the sprites for it. The reason we need to set the flip x value to false is that when we're going to flip it to true, when we want the spider to face right, we need to put it back to false. Otherwise, it's going to remain in a mirrored state. and facing right. So by just making sure that each time we just flip it back to false, we can assure and be sure that when the spider is on the crawl left state, it will be facing left. Then here we're going to do some movements. Now, to move the spider, I'm going to just create right above a asynchronous method called crawl. And the code for it is pretty simple. If you've seen how I used tween, I just I'm going to copy paste it here. So this is the code. And yeah, I think current anim is a property. It does exist and does work, but you know what, just for consistency, I'm gonna use that. I'm pretty sure it does exist. It's just the documentation in Kaboom.js does not document everything, so that's why. Now the param here, we're going to need to pass the current spider, how much you want it to move by, so the range, and the duration of the movement. And as you have seen here, so here the first if statement, we check that of course the current animation is not crawl, otherwise we would play it. So if it's already playing the crawl animation, we don't play it again. Now, regardless of this, we will continue on and use a tween to move the spiders from its current position to its current position plus how much we want it to move by with a given duration. Here it's, I think, 0.5 seconds. And then here it's the function that changes the value progressively, and this is the pattern, the function we want it to change to decide the rate of change, and it's going to be an ease out sin. There are many functions you could use, and I think I've gone over this previously as well. So here I'm gonna call the crawl function. So simply put, I do an await this dot crawl, and I want it to move the spider, of course, the current spider we have. So here we're doing this, we're running this whole logic for all spiders in our spiders list. So we need here for this individual spider, we're gonna crawl, and we want this to this dot range. So it goes from to the left, negative because we want to decrease the position, so go to the left. And then here we're gonna pass in the speed, so this dot speeds, and then this is where we need the index. We want the specific speed, and this for range also we need the index so that we get the specific speed for that spider. And finally, after having done this, we will enter a new state, and this state is back to, I think, back to idle. Yeah, this time around back to idle with the crawl left previous state. This is how you pass the previous state, pass data to the next state you want to enter, is by just putting the state you want. You could have called this no state, whatever data you want to pass in. It's just variable names, and you can just add them here. So for example, if I wanted to pass a number here, I can just add here as the third argument 0, for example. This is just an example, and I don't have a need for this. All right, and of course, to use await, you need to make this async. And now the logic for the crawl left is done. So if we go back to our diagram, what happens here is I'm going to take this arrow and I'm going to just put here. So what happens is, let's say we have this here, maybe smaller. Well, why is it stuck? Anyway. All right, let's have this here, and then like that. Now, once we arrive at the crawl left, we will go to the idle state with the value of previous state. I'm gonna copy this, paste it here, with the value of previous state being I should have used equal here. Anyway, the value here is going to be crawl left. And so when we arrive here with crawl left, we're going to, after having jumped again, move here. So if the previous state, yeah, so no need to add another arrow. It's already describes how we enter the crawl left state. So now let's write the logic for the crawl right state. So crawl right equal spider on state enter crawl right. This is the current state. Here async because we're going to need to crawl. And the logic is basically the same, but the only difference is that, yeah, there's no difference. It's just that we're going to go back to the idle and go back to the left state because we're going to pass in that the previous state was crawl right instead of crawl left. And then because it does not fulfill this condition, it's going to do this logic. Actually, we don't need to even pass a previous state for the crawl right. So here, spider flip x equal true, so that we want the spider to face the right. Await this crawl, and then it's the same thing. Spider, we pass in the spider. This range, this time it's positive because we want to move to the right, so increase the value of x. And this dot speeds is going to be also the same as the previous. And finally, spider dot state enter state idle. No need for a second param because anyway this condition will not be fulfilled. So to test that everything works, I think we have, yeah, we need to go to the main.js and create our spiders. Now I think what we should do is put that into a config file where we can immediately change the spider's position, but let's do that later. So in level 1, right below the camera, so here, and after the player code, I'm going to write const spiders equal new spiders. We import this first array, second array, third array, and then the type of sprite we want because we're in first level, we want the green and red spiders. So this is the, so here the positions, we need to pass in a vector2. So vector2, let me just look at the values I've selected for the first level in my config file. So for the spiders, okay, let's start with 2000. So those values, the way I came up with them was through experimentation. Now you might have asked, why didn't you create the spiders within the... You know what? One thing I've noticed is that the speed, it makes no sense to call this the third param speed. We want the duration of the movement to be 2 seconds. So I'm going to go here. I'm going to go to here. So here it's called duration, so that's a good name. But this is not a good name. So I'm going to refactor everything, change all occurrence, and call it durations. Save that. And now here it makes much more sense that this is a duration. Better naming. So we want the first spider to be at this position. We want it to move at a range of 300 pixels, and we want it to do it in 2 seconds. Now the reason I did this through this and not through the level layout is because the way we draw levels is good for tiles, but the spiders are bigger than a single tile. So that's why it wouldn't fit properly on the level layout, and that's why I decided to just draw them individually like we draw the player. Alright, so this code should work, but we need to now, after having instantiated this, call the set movement pattern method that contains all of our AI code, so that we create the AI, we set the AI for all of our spiders. One thing I forgot to do, and this is the reason why I told you to assign this, is that we're going to add something right below here. So what we want to add here is when the player leaves the scene on scene leave, this is a function by Kaboom. We simply want to cancel all of these states because sometimes they can persist even after the level. And I think that might be a bug with Kaboom JS. So this is a workaround to fix that. Hopefully they fix this or investigate what's going on. Or maybe I didn't use it right. So that's very important. On scene leave, cancel, cancel, cancel. This is also offered by Kaboom.js and allows you to cancel an event, a state. Yep. Now let's test the game out. So I'm gonna go to the game. Fail to fetch spider attack.wav. I guess I forgot. I guess I did not use the proper name for the asset. Let's look into it. So the sounds folder. And then from the sounds folders, oh, it's an MP3. It's not a WAV. Earlier on, I thought it was a WAV. So let's move on to MP3. In case you've already noticed the error, I might look very dumb. Sorry. All right. Enter, enter. This.ranges is undefined. Really? Okay, I guess we're in for a debugging session. So it does not... It considers the ranges as undefined. Why is that? We created the ranges. Oh, okay. Because I did not name this as ranges. So that was the error. Now, if I play the game again. Oh, you see? The spider is now moving. And then when it jumps, it makes a sound. Now, there's probably something you've noticed, that it does not pass through the wall. We want this. We want to allow this for the spiders as well. So let's do that. Go to where we wrote the code for this, and there's probably, yeah, we need to add a method right below. Right below the class. Yep. Right below the set movement. I'm going to call it enable passthrough. This is exactly the same logic as for the player, if you remember. So enable passthrough. Now the code for this, because we're working again with a for loop, I'm just going to copy and paste it just to be quicker. And feel free as well yourself to pause and copy the code. So we have this for loop that iterates through all of our spiders, and then for each of those spiders we call the onBefore physics resolve, which I called in the player code as well. And we check for the collision. If the target is a pass-through tile and the spider is jumping, we ignore the collision. Now, by just doing that, of course, remember when we create those methods, we need to call them in main. Otherwise, it won't work. I need to do here spiders dot enable passthrough and save. Now, if I go back, and now the spider should jump on the platform, move to the right, jump again, and our game is really starting to take shape. So that's great. All right, so now what we're going to do is go to our config file and really configure the spider's movement positions from there instead of having to hard code them into our scene code. So that way it's going to be very easy for us to do that. Yeah, so to change if we want any changes. So here I'm going to go to our config file. Let me find it real quick. Config, let's say for the level 1. And this is the properties we want to add to it. Is the following. So here it is. I'm going to copy paste it. So this is what we want to add. There's a slight modification we're going to need to do to our code here. So first of all, spider position, forgot to add the comma. So spider's position. Yeah, so just realized as I was recording that I cut the sound and therefore I have to redo this part. So at least I have the recording, so I'm gonna do my commentary over it. So from here, I'm adding in my config file the various data we need here so that it's easy to edit from the config. And here what I do is I'd add the spider's position. So I'm just going to move a bit further along. So spiders, yeah. So this is the final thing you need to copy in your code from line 8 to line 16. And what I did here was to have an array where I call this function I define this function that is going to be called and run the vector2 component. Now the reason vector2 here, we cannot just immediately pass in as an array like we could in main, is simply because Kaboom does not exist here. It's not imported, so that you're going to get an error when this is going to run. That's why we need to first wrap it under a function that we're going to call in main. Now the spider ranges is here. We put our ranges, the spider durations here as well, and the spider type here as well as one. So now if I move a bit further, I'm going to just replace everything here and call the map function. And then for each position, so spider position, I'm going to call the spider position function. So the anonymous function. So this is just a name for it, for the function I just created in the spider's position array. All right, I just replace everything here as well. And then if you look at the code, if you look at the gameplay, you can see that you can jump and the spiders are moving and jumping, and you can even interact with them, push them. But this is not what we want. We want that when the player collides with a spider, that they respawn, they die. It's considered a death. So to do something like that, what I did was to simply go to the player code and add a new function called enable mob vulnerability. This function, within this function, I create another function called hit and respawn. What it does is it will play the hit sound at the speed of 1.5, and then it's going to call the respawn player method that is defined within the class. But you cannot simply use the this keyword here because in the function, this does not mean this from the player class. So you need to pass in the context. So it's going to be context.respawn player, and then in the line that comes right below at line 111, I just do the onCollide on my game object, the player game object, and then in the code within, you can see here, I'm going to pause. I call the hit and respawn function that I just defined, and then I pass the this keyword. And the this keyword means in this context the player class. So we have access to the respawn player method at line 109. Hope that was clear. Sorry for the audio issues. Now in main, you're right below the enable coin pickup. You're going to add this enable mob vulnerability function, and then you can play around. So if I play the gameplay, you can see, let's say they hit, oh wait, maybe right below, okay, here you can see that I respawn. So that's yep. All right, so let's move on further. So what I was about to do now was to create the other entity. So there are 6 entities, and let's start with the fish. Fish. I created a class for it, and it's basically following the same patterns, positions, range, and type. The reason I felt that it would warrant its separate class is because there probably is some specific logic. It's not exactly the same. For example, the duration, we're not passing the duration, the durations in this fish class. So here I just do the exact same thing, for loop, and I play the animation. Now there's 2 fish types, but in the game I only use one, so I just removed the dash type and just put one fish, fish like that. Probably going to have to replace the backticks with a normal quotation mark. And then in the loader, we need to still import the assets. It's not done yet. And here I'm just showing off the various components we're using: off screen, state, rotate this time around, but I think I can go without rotate by simply using the flip Y property. And I was about to do that before I realized that I was recording empty sound. And I'm glad I realized this 10 minutes in, otherwise it would have been really annoying. So what I do here down below is just to create a set movement pattern function. Let's continue this for the fish class. Now, thinking about it, I think the best option here would be to have a more general class, because if you remember in the game, in the second level, there is flames that go up and down like the fish of the first level. So why not just have both of them as a single class instead of having to create two? Because anyway, they have basically the same logic. So instead of calling this fish, let's call it projectile. Projectile. Or, yeah, I cannot think of a better name. Projectiles. Or throwables. Or, yeah. Projectiles. Then I'm going to rename the file here as well to being projectiles. And then here I'm going to modify this to projectiles. And here as well, projectiles. And then the type is going to become the name of the sprite. So if it's a type flame, we're going to enter the flame type. If it's a, however, the fish, we're going to enter the fish type here. So a type is basically the name of the sprite, whether or not it's a fish or a flame. And then with this in mind, I think, let me just verify that it's actually similar enough in terms of everything. Yeah. So the only different thing is the animation. Here we can just have a ternary if the type is a fish, then we're just going to play the swim animation. Otherwise, by default, we will play the burn animation, which is the animation for the flames. Could do that. Or we could go here and have a small like anim dictionary or anim map, I'm gonna call it anim map, where if the type you enter is fish, then the value associated to this key is going to be the swim animation. Otherwise, if you enter a flame, the animation is going to be burn, the burning animation. Those animation, we're going to add them as we are going to add the sprite as well in the loader in a moment. But for now, I think this is enough. So we can remove this and just put here anim map. Then here we just pass in the type. All right, I think that's basically it. Now, here we don't need the rotate component. I think we can get away with just flipping the Y value. So instead of having a launch, rotate, and fall, I think we can get away with only two states. So let's do just that. Now, I'm just looking at the code. All right. So in the set movement pattern, we're going to follow the same patterns actually from the spiders. It's a for loop with the index and then projectile as the element of this dot projectiles. And then here, we're just going to type in entries to get both values, the index and the projectile itself. And then we're going to have the first state, which is the launch state. and then projectile dot on state enter. Then here we're going to pass in the name of the state, which is launch state, and then an asynchronous function because we're going to use tweening and we want to use it, the async version of it, so that we don't proceed on with the code until we have finished the movement. So here I'm just going to do an await tween, and then inside of it projectile dot position dot y, then projectile dot position dot y minus this dot ranges, and then we get the specific index. So it's basically the same logic as I mentioned from the spiders logic. Here the duration is going to be 2. In 2 seconds we want the projectile to ascend or descend. So position y is the function here. So basically I'm just going to put projectile dot position dot y is going to be equal to position dot y. And then finally the easings, we're going to simply use ease out sign, and that's basically it. And then once we have finished the tweening, so finish moving from one space to another, we're just going to do a fish dot enter state, and the state we're going to enter towards is the false state. I don't think we need the rotate state, so I'm going to remove it in an instant. Also, before doing any of that, you need to remember to do projectile dot flip y to being false. So if I remember correctly, if I look at the fish sprite, it is facing this way. I guess we might need to rotate at least 90 degrees for the first time and then flip. So we still don't need the state, but we need to use the rotate component and rotate it 90 degrees so that it faces up instead of facing from the sides. And what about the flames? I'm curious if I look at the flame. Okay, the flame already faces upwards. So that's an issue, I guess. So to have our code work for both situations, we're going to have to take that into account. So let's go to projectiles and maybe do like if the type is a fish, we simply do a 90 degrees. Whoops, I did it completely wrong. If the type is fish, then we pass in 90 degrees, otherwise we don't rotate. So that could be, yep. Now here in the second state, const fall, it's the same logic but in reverse. So on state enter, I'm gonna put the default state here, async again. After having async arrow function, then I'm just going to copy this code and just tweak what we need. So here flip y, we're going to want this to be true so that it faces down, and then here is going to be different. Instead of minus, we're going to do a plus, because remember in the canvas in game dev, the farther you want to go down, the more you have to increase the value of y, because of the way the Cartesian plane is set up, where on the x-axis, the more you increase, the more you go left. On the y-axis, the more you increase, you go down and not up, like it is usually shown in math class in public school, I guess. So we have this projectile plus this range, and then the ease out sin, and then fall. So everything is left untouched except for this and this being plus instead of minus. All right, do you have anything else? No. Okay, well, it looks good. Like the one last thing here is to have an on-scene leave. So it's basically a cleanup function where we're going to cancel the launch, cancel, and then fall.cancel as well. All right, so we have our code here. Let's go to our loader to set the assets we need. So I'm gonna add the assets right here. And yeah, let me just find them, as I'm probably just going to copy and paste them. So you have the first of all, the fish. Remove fish 1. We don't need the 2 variations, just 1. And then here it's the same logic. We have 2 frames for the fish and the flames. So slice X is going to be 2, slice Y is going to be 1, and then for the swim animation here from 0 to 1, and then we loop it. As for the fire, the flame, same exact logic. Just gonna paste it here, and here we go. So, and just remove the 1 as well. And we have both of our assets ready. So now what we need to do is let's go into our main file, and right under the spiders, we're going to add const projectiles. Okay, let's start with fish. There's only fish in the first level, so we do const fish, new projectiles, and then for the first pass an array of positions. As for the range, another array, and then finally the type, we're just gonna pass in fish. So for the values themselves, let me just look what I put in my original code base, as I don't remember. What did I put? I need to look at the config file, because of course afterwards we're going to put all of this in the config file. Might as well just do it right now. So let's go to our config for our first level, and right below the spider logic, add for the fish. Now here, instead of amplitudes, since we have changed the name from my original code base to ranges, which is more descriptive, we have it here. So now we simply need to just, this explanation is the same. The reason why we're having a function here is the same as the reason why we're having a function here. I just explained this earlier on. Now here, let's just put level 1 config dot fish positions, and then here level 1 config dot fish ranges, and then finally here it's the type. We don't need to change anything, so we don't need the type here, fish type here, because we're only using one type, color. So here we go, and what we need to do is fish dot set movement pattern, and we should be ready to go. So now let's see the result, how it looks like in the game. So I press enter, we hear the noise, press enter. Bad value for lerp, only numbers, vector 2 and colors supported. Oh, I forgot one thing. So it's not enough to just have the fish position, we need to map over and call those functions that have the vector. So here I'm just gonna call it fish position, and fish position, we just call it. Yeah, so that's it. Now it should work. I press enter, and we have fish is not defined. Well, that's strange. Where is this error? Entities, projectiles, line 37. Oh yeah, I made a mistake here. Yeah, so sometimes errors like that happen, and we can easily debug them. So it's not fish that enter state we need, it's the projectile. Projectile here and projectile here as well. So I save this, I go back to the game, close this, maybe refresh to have the canvas properly sized. Here we go. Now collect coins. I'm gonna try. It seems that it's not working, because usually you should have a fish coming out from here. So there's something definitely wrong. I'm gonna look at the console. Nothing happens. So what's the issue? We enter state. Okay, well, it's normal. We need to go to the launch state back. So from launch, we launch. So we go up, then we go to the false state, and then from the false state we go down, and then we go back to the launch state, so that it's a loop. I forgot this, and that's why it didn't work. Now if I close this, refresh this, and press enter, and I'm gonna try to beat my own level, and you can see the fish are flipping, but not in the way I want them to flip. So that's strange as well. Maybe we need to flip X instead. Because remember, we rotate by 90 degrees. Alright, yeah, that's good. But I'm wondering if it's going to work for the second level. Because I have some doubts that it's going to properly display, but maybe it will. Because for the fish, we rotate the sprite by 90 degrees. So it makes sense to do a flip X here. But otherwise, if we don't flip by any degrees and we do a flip X, it's just gonna mirror. The flames are not gonna look good. So in that case, I must... what am I gonna do? I'm simply going to have an if. I have to have an if statement. So let's implement the fireballs, the flame in the second level and see what happens. So I'm gonna go to the second config.js file, and I'm just gonna import from my code base the flame positions and the spider positions, because there are both flames and spiders. I'm gonna copy and paste everything here. Now one thing I need to fix here, so feel free to pause and copy those values. You can copy them from the actual source code as well, but be careful to tweak it. So here you have the amplitudes, well, ranges now it's called. So let's use this nomenclature. So this naming convention. Nomenclature is a bit too advanced word, I guess. I don't know why it came first in my mind. And for the spiders, we're gonna remove amplitudes with ranges, speeds with what? Durations. And then spider type, here it's important to have the spider type. So those are just positions and speed ranges and speed values we want, duration values we want for our various mobs for the second level. Now if I go to the main, and I'm just gonna take the exact same logic here for the spiders. I'm going to put them here in the code for the second level. I'm just gonna swap this for level 2 to config instead of a level 1. Level 2 as well, here as well. I'm gonna do the exact same thing for the projectiles, so the flames. So instead of here, right after the spiders, but before we attach the camera, copy this, tweak the name here to flames. Here to flames. I think in the projectiles code I've just put the flame as singular, so let's put this as plural. And yeah, because fish is also considered plural for the, yeah, you can say fishes, or you could say fish as well, and both are valid, it seems. But it seems that in English, if you say fishes, that means multiple fishes of different types, while if you say fish, it's of a single type, multiple of the single type. All right, flames here as well, and here level 2 config, and I need to change this to flames position and flames range. And here instead of fish pause, I'm just gonna name it flame pause, just to have some consistency in the code. And if I go back to the config, yeah, that's basically it. And now to facilitate debugging, I'm just gonna immediately skip to the second level. Flame positions is undefined. Maybe I did not. Did I do level 2 config? Okay. Flames. Okay, it should be a plural. It's more consistent that way. Flames position and flames range, rather than flame positions and flame range. But again, here I have singular. So yeah, you know what? Let's go back to just being singular. So singular here as well. All right, so now that we have put everything in order, flame singular here, let's look at the code. Sprite not found flames. I guess if I go back to the projectiles code, the type here. Okay, I see. We need to pass in the flames for the type. So flame burn. If I go to the main here, and I need to pass in as flame singular, which makes no sense, because if I go to the loader, okay, we have fish, but flame is singular. Okay. Well, this is just an inconsistency in the naming convention. We could have called this flames instead. Really, it's up to you to decide what you want to do here. So I'm just gonna keep it the way it is. I don't see a problem here, because it's the flame sprite we want to display, and it's the flame type instead of fish type. So yeah. All right, we have those little things jumping around. You see, it's not flipping, and this is what I suspected. So to fix something like that, really, we need to go back to the projectiles code. So what I'm going to do, we need an if statement where if this dot type, so in the end I need to assign the type here. So this dot type equal type. That way you have access to it in the method. So if this type is equal to the fish, then we're going to flip the projectile horizontally. However, so the reason this works with a fish is because we first flip it by 90 degrees so that it faces up, but the flip is still horizontal. So let me make a drawing for you. I have pulled out the diagram tool, like my favorite diagramming tool, Excalidraw. So we have our fish. Initially in the sprites, it's facing this way. So we have our drawing. However, if I copy this, however, we use the rotate component where we rotate this by 90 degrees. So it's going to look this way. However, when you do a flip X, it flips around the x-axis, the drawing. So saying flip x equal true will do this. So it will take this, and let me paste this, and then is there no mirroring? Align top, align center. You know what? Let's just assume this is a flipped version. So like a mirror. So it's going to flip it this way. However, here the axis is still considered the x-axis, even after using the rotate component. The x-axis is still considered as being this one. So this is y-axis, and here, whoops. So we have the y-axis here, and we have the x-axis here. While with this drawing, it's the reverse. So we have flipped the canvas, but the axes are still the same. So when you do a flip x equal true here, the result is going to be this thing. So a copy. Imagine this is a mirror flip. So this, so I'm gonna remove that as well. And then so it's as if this, whoops, this is y, this is x. So you see, that's why it works to do that for the fish, but it doesn't work with the flames because it's already facing this way. So if you flip it, it's just gonna remain the same because it's gonna flip it around this axis. So just to make it very clear, let's say this is the, okay, let's put it here. We have the flame, and here is the x-axis, y-axis. So doing a flip x equal true, we'll just flip this. So, whoops. I'm gonna take this, copy, paste it here. It's not gonna do anything. It's just the sprite will look the same. It will look the same, but even though it's flipped. So that's what it does. However, if you were to flip this, doing a flip y equal true, then it's simply going to take this and flip it like that. So this is what we want. So I hope this explanation was not too convoluted. So let's have it. Let's continue with our code. So if the type, however, here is flame, the projectile flip y is going to be false here. But we copy those two lines, we paste them here, and then they're both being true. True, and then true. So yeah, it could be a probably more efficient way to do this without having to copy paste, but for now, for our purposes, it works. Now if I look at the game, whoops, alright, let me refresh. Alright, so I jump around and the flames go up and then they face down. And also we need to enable the mob vulnerability for both these new mobs that we added, and for the spiders, and for the second level as well. So let's go to main. So let's go to main. So for level 2, remember we added the player, where is it? Where is it? Where is it? Player. Enable mob vulnerability. I'm gonna put it right here as well for the level 2. We need to put this for all levels. And then we need to go to the actual okay, well, in the projectiles here we cannot keep the tag as being fish. We need the tag to depend on whether or not it's a fish or a flame, so we need to pass in the type here as well as a tag. So if I go to main, to the player code actually, to the player, in the enable mob vulnerability, we just need to add 2 other lines, game object dot on collide, and then here I have flame as the type, and then we call the hit and respawn this, and then I'm just gonna copy this again and then replace it with fish. Alright, so now it should work. Let's look at the level. If I go here, I respawn, it considers I'm dead. Now if I go into the flame, it considers I'm dead as well. So both of them work, and that's pretty good. Now let's go back to the first level to test out the the fish, if they're gonna kill me. So I go here. Where's the fish? Okay, let's set this back to being the menu. And then let's go back to our game again. So if I come across here, I respawn. Alright. And for this as well. Alright, seems to be working. If I have 0 lives and then I'm sent to the game over screen. Alright. So this way we got 2 mobs done at once. So 2 birds with 1 stone. So what's left is the saws and axes in the game in the second level, and then the birds in the third level, which are going to have code that is a bit different than what we have here. Alright, so let's implement the axes. But before doing it the way we've been doing it, by having a class and then adding it to our main, etc., let's immediately start at level 2 config and add what we need for the axes, so the positions where they are going to be, etc., so we don't have to worry about that later on. So here I'm going to copy and paste the thing we need here, and it's basically 2 things. We only need for the axes the axe positions, here it is, and the axe swing times or swing durations. So axe swing durations is a better name, so I'm going to use that. And now we're ready to start. So I'm going to go to the contents folder, the entities folder, and in there I'm going to create a new axes.js file, and it's going to be in a class like we've been doing it since the beginning. So export class axes, and then we have this, and then a constructor which is going to take positions as the first, and swing durations. Here it is. So so we only need those 2 things. And then of course as the first swing durations, we're going to assign the swing durations and then create an array as the attribute of the axes called axes, which is going to contain all the things we need. Well, all the axes we're going to generate here. So I'm going to, again, use a for loop and use the const positions of positions. I made a mistake. Here, this is not gonna work. We need to have a singular position. Otherwise, we're just using the same name and it's gonna confuse JavaScript. So what I have here is inside of here, we're going to write the code for our axis. So the game objects. So this dot add, this dot axis dot push, and then it within the add function, and then an array of components. Here, the components we're going to use, I'm just going to copy them and go over them each. One thing I think I forgot to do is let's go back to the projectiles. Because we were able to get away without using the rotate component, the rotate state here that I created, we don't need the state here in the array of states because we're only going back and forth from the first state, the false state, the launch state to the false state, and from the false state to the launch state. So there's no need for a third state here. All right, with that said, we can move on. We can go back here. So here I have the sprite axe. We're going to import that in a moment. We have this shape, and then we need to use the collision ignore property. So we ignore collisions with spiders and flames. In case the axe will be placed near a spider or a flame, we don't want that to have an issue. Now here I think we might need to change this to a singular, because I think if I go to the projectiles, we use the singular flame as the type. So instead of having flames here, we're going to have flame without an S. All right. Here we use the anchor. So one thing that's great with the anchor component, you can specify either a tag here like center, up, left, etc. But you can specify a specific anchor you would like. And this is going to make sense in a moment because we want the origin of our drawing of the sprite to be from the top corner, from the where the axe starts. So let me just show this real quick. So where is the axe? Where is the axe? All right, axe trap, it's called, the sprite. If I zoom in, by default, if you put the center as the origin of this game object, then the sprite is going to draw it and the origin is going to be here. But if I specify with the vector 2, I want the origin of the drawing, the game object, to be here instead, so that when we're going to rotate the axe, it's going to rotate along this axis. Hope that was clear. So maybe a little drawing will do the trick if it's not already. So we have an axe here. And this axe, when drawn in Kaboom.js, it's going to consider this as a game object. And by default, Kaboom.js draws the origin of that. So the X and Y value of that game object starts here. Now, by using the anchor component and setting it up to center, what it's going to do, it's going to take this and put it here, the origin. So X and Y is going to correspond to this point, and the sprite will be drawn from this origin. However, if you try to rotate this, it's not going to look good because it's going to rotate from this axis. So if I, just to simulate it, if I did this, it's not going to rotate from this part. Now, what we want actually is that I'm going to copy this one and paste it here. We want our origin to be here, to correspond to here, so that the X and Y value is here. So the game object is drawn from this point. And therefore, when you're going to rotate, it's going to rotate along this point. So it's going to look like it's swinging. Hope that was clear. And let's move on. So here, you're going to need two states, the swing left and swing right. And of course, the rotate component, so that we can change the rotation of the axe. And finally, the off-screen component to save on performance, so that when the axe is off screen, we won't need any. It will have a lesser computational load so the game will run at better performance, so higher frame rate. And finally, we use the axis tag here. We create a tag this so that we can make the player vulnerable to this later on. All right, so now we're just gonna have a set pattern movement method like with the other entities we've created, and we're going to again here use a const index and then axis of this axis entries, so that we get both the index and the x. And then finally, we're going to create two states, so the swing left state, and the reason I'm setting them up as in a constant is to cancel them, like I mentioned earlier on. So axis, whoops, I made a mistake. Here should be singular, so because it's each ax in the axis array. So for ax, on state, enter swing left. So we start by default with a swing left, and this is defined here as the first state. I'm gonna swing dash left, and then for the logic we're going to run when this state is entered, we're going to create a utility function, a method right above, and await, and we're going to call it swing. And to the swing method, what we're going to pass, async, not await. Here, async and swing. And what we're going to pass here is the x object, game object, of course, the angle we want to swing towards, and finally the duration, swing duration. Now within here, what we're going to do is first make a check. If the x is off screen, so we don't want, so it's a, because I'm using the bang sign, we have the opposite of this. So we want to check when the x is not off screen. And if it's not off screen, we're going to play the sound for this. So not player, play swinging axes. Our axes. We need to import both the sprite, and we're going to do that in a moment. And then right below, we're going to write the logic to actually make the swing. And here again, I'm using tweens. I'm not going to go over how to use a tween. So yeah, I think by this point, I think we're multiple hours in. So you probably understood how it works. So we get the angle from the current game object, the current angle, from having used the rotate property. So we have access to this angle, the rotate component. So we have access to the angle property in the game object. And then here we pass in the target angle. So here a better name would be target angle. And here it's the target angle. So what we want the angle to be at the end of the tweening, and then the swing duration. And finally, we need to just pass in the value. So x.angle and set, so the function that set everything. And finally, the function, the mathematical function that the tween is going to follow, and this is what I thought was good, is an easeout sign. Here, if you go to the Kaboom.js website, you're going to find a bunch of examples. So I'm going to go to that website just so that you can have a better understanding. So Kaboom.js has a playground where you have a bunch of examples. So just so that you can see, you have here the playground and then a bunch of examples. And I think there is a tween example. Here we go, tween. And then here, by clicking anywhere you can move, and then you can use the arrow keys to change the space. Wait, how do I change? Click anywhere to use the arrow keys. Is there a way to change the easings? It seems that the example was different, because you could switch from one tween to another type of tween. Here are the easing types. So easing types, object keys dot easings. Where is it getting this? Oh, all right. By using the arrow key, you can change the different tweening, so you can truly have a feel of the different types and how they evolve over time. Ease in cubic, easing out cubic. So you see, ease in out cubic starts slow and then goes fast. Is in out cubic starts slow, goes fast, and then goes slow. And ease in quart. So yeah, play around with this and you'll hopefully get a better understanding. So I'm just going to go back to the escalator drawing. Okay, and now go back to the code. All right, here I decided to use an ease out sin. Or sign, not sin. Sorry, I've been pronouncing it wrong. Then back here in the set movement pattern, I'm just going to do an await this swing. I pass in the X. As for the target angle, it's going to be, I think, 90 degrees. So it's going to swing from where it is to 90 degrees. And then the duration is defined by what we have passed in. So this swing durations, and then of course here we need to pass the index to have the specific swing duration. All right, I think we have it here. And then after having done this, we are going to enter the next state, which is swing right. Now what we're going to do is just copy this. It's basically the same logic again, but this time swing right. And then here it's called swing right. And then we swing the state we want to go to after having swinged right is swing left. And here is the difference. We're going to go to minus 90 degrees. And finally, the on-scene leave function, we need to call it so that we don't find ourselves with sounds that we don't want to hear. In case, yeah, as I explained earlier on. And I think we're ready. Now let's go to our loader. And in our loader, we need to load a bunch of sprites. So the axe sprite and what was the other one? The sounds for it. So if I go back to my loader, let's start with the sounds. I think I'm just going to copy and paste it from my original code base. So we have a load sound swing axe, and it's come from this file, mp3. And finally, as for the sprite, I'm just going to import it here then. And the file for that is, sorry, I'm looking at it. I'm trying to figure out, to find it. Where is it? I think it's a flame axe. All right, I found it. Now I'm just going to copy and paste it. So here, the axe trap.png. Now that this is done, I think everything should be working. And now we can set everything up in the main for the second level, because those axes appear in the second level. And we're just going to put them here after the flames. So I'm going to do a const axes equal to new axes. And by doing enter here, it imports everything already here. So you might have, you might need to do that manually depending on how your editor is set up. So here for the positions, we're just gonna have the level 2 config. And then I added this, so the axes, wait, I have level 1 instead. Level 2 config, axes positions has the first param, and level 2 config, axes swing durations. And this is going to give us everything that we need. Of course, for the positions, we need to use the trick with the map and then call the function. So I'm going to do a dot map, and then here axe pause, and then call the axe pause. All right, so we have this. Now we're simply going to set the axes dot set movement pattern. Oops, I have messed it up. So if I go back here, is set movement pattern instead of set pattern movement. I save here, go back to main and change that again. Set movement pattern, call that function. And now we need to go to our player code. So that player, he needs to be vulnerable to these new obstacle. So on collide with axes, because remember the tag we used for axes was plural. Where is it? Axes here when plural. So yeah, you decide if you want to use plural or singular here, but be consistent for the rest of the code. I suggest that you just follow along exactly how I did it, so that you will not be surprised of any errors. All right, so go back to the player code, and then here we have the X, and then the function that is going to be called is hit, and respawn, and then we pass in the context. So everything should be working. And of course, I just want to clarify that at the bottom, we're going to go directly to the second level instead of having to go to the menu, etc. So let's test everything out. So you see, you can hear the sound of the axe, and if I try to jump into it, it considers that I'm dead. And now if I try, whoops, that was hard. All right, like that. Here it is. I try to jump. All right, so you have a bunch of flames. Everything is working. And the reason it's really useful to use the off-screen component is that for the sounds, the axes are not going to do any sounds if they're not on the screen. So that's great as well. Same thing for all the other mobs. Here it is. And yeah, I'm just going to reduce a bit the volume for myself because it's too loud. All right. So now what I'm going to do is add the saws. So it's the same principles again, but this time around the saws are not going to swing. They're going to go left and right while rotating in place. So I'm going to create a saws.js. Then inside of that, I'm going to create. So I'm going to create the constructor. And here it's repetitive, so I'm going to try to move fast. So let me just copy and paste what I have here. So I have the constructor. Feel free to pause to copy the code. I'm not going to modify anything here. So position and ranges, this is what we need. And then we're going to create a rotate function. Well, instead of set pattern movement, yeah, here, let's call it set pattern movement. Is it set pattern movement or set movement pattern? Set movement pattern. Okay, set movement pattern. And then here, so we're going to set the movement pattern here. And here again, I'm just going to copy what I have instead of writing it manually. And again, you can pause and do the copying yourself as well. You can even look at the original code base. This is just so that it doesn't get boring for all of us. So here we have the for loop, this time around just the saw and saws and entries. Then we have our rotate left state, which is going to run the code here. And now here, the thing that is a bit different is we're going to use a promise all. So here this code is normal, so we just, I think, yeah, we're repeating this twice, right? So there's improvement for the code here. So what I'm going to do is I'm going to create another method, an asynchronous method, and I'm going to call it, I wonder what I'm going to call it, rotate. I'm going to call it rotate. And what I'm going to do here, so be careful. In the original code base, if you look at the code, the rotate function, the method here is here. It's the name of this. So yeah, don't get confused. I'm going to copy this code, this whole reusable block we have here. And I'm just going to format this properly. So instead of, yeah, so here it is, maybe this. Wait, this looks weird. So this is okay. This is okay. This needs to be. All right. Now here we're going to pass the saw, give an object. And what we want as well is the range. So I was wondering, how did I do that with the spiders? If I look at the spiders, I have a crawl, and then I used a move by property. So let's use the same thing here. We have a move by param that is going to go here. So it's a plus sign and then everywhere. And depending on the move by, if the move by is negative, it's going to go where we want. And here, all right, so the first tween is to go from the current position to where we want it to go. And then the other tween is just for the rotation. So we want from the angle to go to 360. And this is going to change because if you look at the... No, it doesn't change actually. That's the exact same code repeated twice. Is it? Yeah, it is. So, okay, I can reuse that. Here we just want a 360, so this is hard coded. We don't need to change anything as well here. And all right, I see a huge error. Yeah, so the formatting was completely wrong. We do this to have the correct formatting. We can maybe have a space. So if the saw is not off screen, then we play the saw with a volume of 0.6. I think we're going to reduce the volume because it's pretty loud. And we're going to seek at 10 seconds because the way the sound I selected here works is that there's some noise before, and I thought that it sounded good starting at 10 seconds. All right, so I think this is good. Now we only need to change this code here. So instead, we're just going to call await rotate. Yeah, it doesn't make sense to call it rotate because it moves and rotates. So move and rotate will be a better, more appropriate name here to describe what it actually does. Away.move and rotate. And then we call this with pass in the axe. Oh, the saw, not the axe. Did I put axe here? All right, saw. We're going to pass the saw. And then the move by is going to be this dot ranges index and negative because we want to subtract. We want to go left. And then I can simply remove all of this again. And the reason we don't need to change here anything, so it takes the current, so in the move and rotate, it takes the current angle and swing it, rotates it 360. And the reason we don't need to worry about anything because anyway, at the end of the movement, we set back the angle to being 0. So regardless of it's going left or right or when it's rotated, it's always going to rotate. So that's how, yep, that's why we can just get away with that. Now I'm just going to copy this and I'm going to paste it here. So this dot range is positive. I'm going to just improve the formatting a bit. Now that the formatting is improved and we have, of course, the on-scene leave, rotate right, rotate left, everything is all right. Now the saws are only going to appear in the first level and the second level. Why do I have this? I have an extra... Did I miss a bracket somewhere? If I close that... Oh, I think I have this as extra. Yeah. Had an extra bracket, and then this needs to go here. All right, and now let's go to our main, to our config for the second level and add those saw positions and durations or ranges. This time around, we don't mess with the duration. If you look at the code here, we just use a 2-second duration, 1-second duration for the movement left and right, and 2 seconds for the rotating. You can decide to change that later on, so you could add them as a param to the constructor. Then you then use the index this dot, for example, durations index, and then you get the specific duration you want here. But it wasn't useful for our current purposes, so I did not do it. All right, so now for the level 2 config, I'm going to just put the saw positions and the saw ranges, and there's only 2 in this cell level. I'm going to put them right below. Don't forget to add the comma after the here. So yeah, that's all that we need. Now let's go to main and set everything up. Now, of course, we need to set up the vulnerability for the player so that it gets hit. So here we're using the saws tag. So let's do that before so we don't forget it. So here again, I'm going to copy this line of code. Right below, I'm going to put a saws tag here. So now our player should be vulnerable to the saws we're going to add now. And then here, I think here, we're just going to do a const saws equal new saws. Whoops. And then level 2 config dot saw positions. Yeah, here. Yeah, I'm not consistent with the way I name things here. So it should be saws positions instead of saw positions. Feel free to check to modify this on your own to be consistent one way or the other. Either you use singular for all of them or use plural. That would be a better coding practice. Sorry. So I have a saw pause, saw pause, and then we call it. And then here level 2 config. And then here we have the saw ranges. And that's basically all we need. Now we just need to call saws dot set movement pattern and everything. Wait a minute, it did not import the saws, export class saws. That means that it did not do it automatically. So let's just do it ourselves then. Saws from, we need the saws class from entities slash saws. All right. So I save the file and then let's look at the game. Could not find a sprite. Oh, we forgot the sprites for it. So here again, let's go to our loader and the sounds as well. We need to import both of them. So I'm just gonna add the sound first. Here again, I'm gonna look at my original code base to find that quickly, so we don't lose a lot of time trying to figure it out. So I'm gonna copy and then paste it here. So circular saw.png. Oh, that's the asset, the visual, the sprite for it. So let's go here instead and put the sprite first. And then for the audio for that, I'm gonna also look at it quickly. And here it is. All right, so we have both of them, the load sound. And so now everything should work. Let's look at our game now. All right, it works. Now, the reason we're not hearing the saws is because they're not in the screen. They're not visible yet. So if you want to look at how it swings, you can see that the origin of the axe is here instead of the middle. And the way, yeah, so sometimes the one issue with Kaboom is that the physics are unreliable when you open the debug mode. One thing I think I have not covered is the how we got the hitbox for the axe here. So let's cover that real quick before proceeding on. So here in the axe code, axes.js, and initially when you created the game object, I've put the collision, the hitbox for it, as a shape of 30 pixels by 10, so it's a rectangle. And here is how it is positioned. So it is positioned relative to where the origin by 40 pixels. So if I make a drawing, I'm going to just clear everything. I think this is important to spend some time here. So as I said earlier on, we had our axe, which was drawn, whoops, come on. We have our axe, which was drawn here. And it started its origin from here. But the hitbox, by default, is going to, if we keep the same dimensions without specifying the vector2 component, it's going to be here. Now, because I specified that I wanted the hitbox to be at position vector2 0, 40 relative to the origin, so here, it's going to drop down by 40 pixels, and it's going to find itself here. So that's why we have the hitbox here, and it makes sense because we don't care, like we don't want the player to get hit here. So if the player is here, it does not matter. We want the player to continue playing. They have avoided the actual danger of the axe, which is this part. All right, hope that was clear. Now I'm gonna play my own level and try to arrive at the end where the saws actually are. So, ooh. And then here. So because they are moving in a predictable pattern, I have mastered my own game. I might have some difficulty arriving here, so feel free to modify the level. You see, the sounds we hear here are the axis sound. This demonstrates that it actually works, and now we arrive to the third level. So now we're just going to focus on this actual third level. So we have basically all of our entities, only one, which is the birds. And the birds are going to be the main enemies from the third level. So before moving on, I'm going to go to the main.js file. And in there, I'm going to just go directly to the third level. And then in the entities, in the entities folder, I'm going, maybe first let's go to the config.js of the third level and add what we need here for our birds. So let me just find it in my original code base. So it's simply going to be three things: the bird ranges, the bird type, and the bird position. I'm going to remove the bird type because there's two variations of birds in the assets. One that is pink or violet, and the other that is, I think, orange-ish. So we're just going to use one instead of having two. So that's why we only need first an array of ranges. So how far the the bird is going to move left and right, and then a bird positions where they start moving. And those birds are going to have a certain interesting pattern where they move left and right, but sometimes they do a dive attack and they come up. So this is what we're going to code right now. So in the entities folder, I'm going to create a birds.js file. And here again, I'm just going to copy and paste the code I already have made for this and go over it. So first of all, let's write the class export class birds. And then in there, let's start first with the constructor. So we have the constructor, maybe tab, and then here. So our constructor is going to take a position and range and then a type. We're going to remove the type param as it's not necessary. And here, I'm going to remove the type as well. So because we don't have different types for our current purposes, I'm just going to use normal quotation marks. And then here we are going to have four states: the fly left, fly right, dive attack left, and dive attack right. The off-screen component, of course, and the birds. And then we have the scale, the position, everything here is the same. So here we have the hitbox for the birds and the default animation we're going to play. So we're going to import the sprite sheet for that as well in a moment. So let's look at the set movement pattern function. So here, I think I need to format this properly. Now I'm going to create a set movement pattern method. And in this set movement pattern method, I'm going to have exactly the same thing, a for loop where, so I'm just going to copy what I have. So a for loop, let's do it gradually this time around because there are things that are going to change and I really don't want to lose you. So let's have a const index bird and then of this dot birds dot entries, and then within, let's write our code. Let's create our first state called fly left, and here bird dot on state enter, and then we specify the state we want, fly dash left. So here it's going to, of course, have an async function. I'm using tweens for basically everything. So I'm going to need an async function. Going to remove this to remove some clutter. Now here, what we're going to need to have is, first we're going to do a bird.flip x being false. By default, the bird sprites face left. I'm going to show you just that. Bird1. So you see, they face left by default. It's a bit blurry here. All right, this looks good now. So they face left, so we don't want to change the flip value, and we want to make sure that it goes back to being false if it was changed in another state. Now here, I'm going to create a utility function method. I'm going to call it fly, and it's going to contain the logic we need to make our player fly. Now this is where I think I could just copy paste it from the original code base. So I'm going to do just that. All right. So here, bird move by duration, same principles as what we did with the saws. So let's just add it here. Here, I'm going to do a await fly, and this fly. Bird, we want to move by minus, so minus this dot ranges index, so same thing. And then finally, the duration, we want to move for half a second. And then after that, we're going to move on to a dive attack. So the way the pattern is going to work is it moves left, does a dive attack, and then it goes back to, it moves right, does a dive attack, etc. Repetitively like that. So bird enters state, and then here we're going to enter the dive attack left state. Now let's copy this code and have the fly right logic as well, which is basically the same except for this is true, the flip x, so that the bird sprite is going to face right, and this is positive instead of negative. Otherwise, and this is dive attack right instead of dive attack left. Now what's interesting and what will change is the dive attack, how we're going to code this. So the way we're going to code this is, let's first create a const dive attack left, and then bird on state. Let me just, on state enter. And then here the state is going to be dive attack left. And a synchronous function, of course, because we're going to use a tween again. And then we're going to write our logic. Now here, I'm going to have a condition here that's very important. I'm going to check whenever or not the bird is off screen, and I'm going to dive in that case. Well, here, I think we could just put that in our dive function. So let's create a dive method right up below here. So that's going to be reused in both the left dive attack and the right dive attack. So here it's a bird target. This time around, instead of a range, we want to target a specific point from which the dive attack is going to be made. Is going to direct itself. And then here, so here. And inside of this dive, I'm going to take this code and just use it here. So if bird is off screen, play dive. And then volume is going to be 0.5. Okay, so right below in our dive function, I'm going to use a tween again for the dive. And the way it's going to be structured is a bit different, because now instead of passing in a x value, we want to really go towards a specific vector2 position. So as the first parameter, we have the current bird position, and we want to go to the target position. That's why this is a vector2 with the given duration, and that's basically it. Now in our dive attack code, let's just pass in. So await, here it is, await this dot dive. So here we pass in the bird, then a vector2, which is the target position we want. And the target position we want is the following. So let me just format this properly and have this here. So for the X position, we want the position to be position X minus. So we want our plus, the range. Because here we want our birds to move in a diagonal fashion as they're diving. So we first want them to dive down by going to the position described in the vector2 plus this dot range. And then we want to do that in 0.5 seconds. And then after having done this dive, we want the player to the bird to dive up and to proceed and continue on. So I'm just going to copy this. So here you see the difference that we have a plus here. So we are diving left. And I think, wait a minute, I think I might be doing something wrong. Yeah, oh, oops, this is the code for the right. So we want to move left on the x-axis, but increase the value of y so that the bird goes down like that. And we want to, when it comes up, to also go down, go left, so minus, but we want it to go up and we want to add. So just so that you truly understand what is happening, let's make a drawing. So I'm going to reset the canvas and I'm going to draw it this way. So we have our y-axis, we have also our x-axis. So, and then I'm just going to take the pen. So the pen here. So we have an x value, y value. So initially, let's say our bird is here. It's at, I don't know, 10, maybe 5. It's at 10.5. When we want it to dive, it's going to go here. So it's going to decrease. So increase the value of y. So we do a plus the range. And we want to decrease the value of x. So it's going to be 5 minus the range. Sorry for the writing. Now when it's going to dive up again, then it's the contrary. We want to arrive, I'm going to do a 10. Wait a minute. Yeah, we're going to, wait, no, it's completely wrong what I did here. Let me just erase that. We're subtracting from the x value to move up to the left. Whoops. And we're increasing in the y value. Because remember, the more you go down, the more the value of y increases. So here we have a minus 10. So 10 minus the current range. So it's going to move here and then here. So that's the x vector, y vector. So it goes from 10 to whatever this is, and then y it's going to increase. And then here it's the reverse. We still decrease the x value. So we move further left, but we are going to also have the whatever this is. Let's say it's called, let's call it b. So this is a placeholder for b. And so we're going to do b minus the range. All right. I'm just going to do it properly. Hope that was clear. And this is a parenthesis. All right. Hope that was clear how the dive logic works. Now, after having done a dive attack, we just want to go to the opposite direction. So we want to fly right after having dived attack left. And that's basically it. Now, the same code, we're going to copy and paste it right below. and rename this to dive attack right. Rename this to dive attack right. Here, instead of having minus plus, we're going to have minus minus plus plus, because we want to move the x to the right and still go down with y. And remember, in this Cartesian, the more you go down, the more y increases. And for the this.dive, the second dive, we're going to do the reverse. We're still going to go to the x value, but we're going to decrease the value of y. Wait, it's the contrary. When we increase the value of y, we go down. Yeah, that's good. When we decrease the value of y, we go up, like here. All right. A bit hard to wrap your head around it, but I hope this schematic was clear. So yeah, just showing it again. All right, so I think we have it all done. And then, of course, here we need to modify it to fly left after having dived attack right. And finally, we need the cancel logic to cancel on scene leave. And the only thing left is to import, not within the state, sorry, outside of the state. Here. And that's basically it. Now we need to import the various assets we're going to need in our loader. So for the sound, I'm going to go over this real quick. Where is it? Where is it? Where is it? So there's a dive sound that we're going to just import. So this is the sound for the diving. And for the sprite, for the bird, it's going to be a sprite sheet. So it's going to contain a bit of animations. So let's use the second the bird2 type here. I'm going to paste it here. So you see that it's bird_2.png, but we're going to simply name it bird, as we just want one type. We have a slice x, a slice y, anims, the fly anim from 0 to 2, and then speed 9, this is what looks good, and looping, so that it loops. And I think everything is alright, is ready. Whoops. Now we can go back to the main function, file, sorry, not function. And under here before the camera, I think the only thing left is the enable vulnerability for our player, but let's do that right after. So here, I'm gonna do a const.birds, new birds, and this is going to import automatically. As for the positions, we're just gonna do a level 3 config dot bird positions. Then we map here so that we can have access to the positions. So bird pause here called. And because it's an arrow function, yeah, one thing I haven't specified, because this is an arrow function, it returns this. If it wasn't an arrow function, you would have to write the return keyword. So this is something I thought I should have made clear, but it just didn't came to mind. Sorry. Now I have a level 3 config here dot bird ranges, and of course don't forget the comma. And finally, right below, birds dot set movement. I wrote it completely wrong, and it's set movement pattern. Set movement. Set movement pattern. Let me just check with set movement pattern. All right. Yeah, so this should be named properly now. And we have a set movement pattern. We call this, and things should be working. Of course, don't forget now to add to the player class the vulnerability. So here it's going to be birds. Birds. All right. Now I think that's ready. We're ready. And we can test the game. So let's it's completely not working. It's even bugging around. Okay, there's definitely an issue. So I need to check if I did things correctly. So we have the birds, fly left, fly right. It's called fly left twice. I forgot to change this. So that's why. Fly left, fly right. You probably have noticed those errors, and I'm sorry, but I myself, when writing the code, I didn't. And that's why it's a good idea to have a fresh pair of eyes looking at your code. So fly left, right, dive attack left, dive attack right, dive attack left, dive attack right, fly right. I'm just looking at if it's correct. All right, let's test now. All right, you see, now it works. But there isn't any vulnerability. I'm not dying when entering contact with them. So I probably got something wrong. Here it's the birds tag. So if I go to the player logic, this should be working. This.GameObject collides with birds. It should hit and respawn. So that's strange. Why isn't it happening? So if I wait, let's enter in collision. What? It's not working. All right. Well, that's another debugging session, I guess. Let's try to figure out together why it's wrong. I'm gonna look into it. So, oh, I know why. I did not call in the main.js here. I did not call in the level 3 player.enable mob vulnerability. That's why. So now if I play it again, all right, and I jump into one of them, yeah, I respawn. All right, our game is really taking shape. I think the only two things left. Oh, let me just try to beat it. So the only two things left is, all right, so sorry, I'm having a technical issue, so you might not hear the sound of the birds, but you should on your own game, if you've been following along, hear the sounds. I'm sorry. So yeah, so it's a bit loud, so let's continue on. So now what is left really? Having a game over screen, an end game screen, and having maybe some background noises like the sound of the water flowing in the first level, the sound of the lava boiling in the second level, and a strong wind in the third level. So this is what is left basically. So let's work on that. Let's first work on the game over and end game screens, and then once this is done, we're just going to do the sound design thing, add some couple more sounds, and the course should be finished. So all right, so let's get started. So for the game over and end game screens, really I'm gonna create two methods in the background manager, so and the UI manager. So let's create a UI manager. No, we already have a UI manager. I mean, let's create a new method in the UI manager. For example, here. And this is the code. And remove this for now. We're gonna add it later on. So what I have here, I'm gonna go through the code here. So I add a black rectangle that takes the whole screen. I display the game over text with a size 50, font round, and centered. And I display the blinking message that tells you to press enter if you want to start the game. We already worked on that previously. And if the user presses the enter, we play the confirm UI sound and we go back to the first scene so that the player can start playing the game again. Now for the display end game screen, so what happens when the player has won? Simply put, remove this. We're going to add a sound manager for playing the sounds, the recurrent sounds like the lava boiling, etc. But for now, forget about it. So here, again, I add a black background that covers the whole screen. Then a simple message that tells you you won and thanks for playing. We display the blinking message, and we allow the player to go back to the main menu this time around if they want to play again. Now, yeah, so that they can, because they finished the game. All right, so copy this code over. You can spend some time this as well and this as well. And now we need to simply go to the main.js file. In there, I'm going to simply call that function. So UI manager dot display game over screen and UI manager dot display end game screen. Now let's test that out. So if I play my game and I die, I'm just gonna reduce the volume for myself a bit. And if I die again until I get a game over screen, I get this screen, game over. And then if I press enter, I'm back to level 1. Alright, that's great. Now for the end game, same thing. Really, it's going to work the same way. Just when the player has collected all the coins, they're going to go to the end screen. We already worked on how to transition over to this scene, so really there is no need to go over this. Alright, now the last piece of the puzzle. Really the sounds, the ambience sounds, like the water flowing, lava boiling, and wind. So let's first start with a loader. And I'm going to just import all the sounds we need here so that we don't have to do it back and forth. So the first is the water ambience. I called it this way, .mp3. So import that. The second thing we need to import is the lava boiling, lava ambience sound. Import that. Finally, we have the wind. So strong wind, we're going to import that as well. All right, we're set when it comes to the sounds. Now we need to create a background sound manager. So I'm going to create a class, call it bg sound manager in the utils folder. Once this is created, I'm going to just have a class. It's going to be a singleton, a bit like the UI manager. So only one instance is needed. We're going to have a sound map attribute property here that is going to contain the various background sounds so that we can easily pause them when we need to. I'm going to add a add sound method with you pass in a key and the options, and this under the hood is just going to do this sound map and add a new key to the sound map, and within we're just going to play the sound. So play, call the play function. So the play function in Kaboom.js not only plays the sounds, but at the same time gives you a reference to that sound. So that's why I'm playing it here. So you pass in the key, so the sound you want to play, and then you have the options you can give it, like the volumes, etc. So we're just passing it over to the play and then play function, and then storing the actual sound inside of sound map. The other method we need to do once we have that is, we can play a specific sound, but I don't think we need that. Really what we need is, we actually need to play this sound. So once a sound is inside of our map, we're just going to add this method. So I'm just going to copy it over to go faster. So this sound map is going to seek back to the 0 second, and it's going to set the paused attribute to being false. So this is a Kaboom specific thing. So once you have created your sound by passing in the options and the key for it, you can have access to an object where you can have access to properties like seek, which allows you to seek where you want to start playing the sound, and the pause attribute, where you can set it to false or true. If you set it to true, the sound will be paused. If you set it to false, it's going to play. So by seeking to 0 and then making paused false, it's going to play the sound from the start. Now, what we really need here is a pause all sounds method. That's the most important method we need here, because we want the sound that all ambience sounds stop when we transition to another level. And if you don't do that, the sound is going to keep playing. Yep. So actually, I thought of a better better way to do that. Instead of having to create this class, a simpler solution that I just thought about right now, so let's delete it, is to simply go to where you want to play the sound. So for example, here in our first level at the top, so here at the top, maybe after, yeah, before even the gravity, we're going to play the sound. So I'm going to look at how I did this. So without using a manager, we don't need that. I just thought of a more efficient way that just sparked into my mind at the moment right now. So what we're going to do is simply call the play function. So store it in the variable. So water ambience. And then we're going to play. And what we're going to play is the water. Let me just scroll up. So water ambience. And then for the options here, volume is going to be low because those are pretty loud noises. So let's set it to 0.02. And then we're going to loop the ambience, so we want it to continue. And here, instead of using a manager, and really what we can do, we can use the on-scene leave function that is provided by Kaboom that I used for getting rid of the state machines, and stop. So do a water ambience dot. I would want to even destroy it, but I don't think you can. Maybe let's look if you could destroy this. So if I go to kaboomjs.com and I look at the play function, it gives us a audio play. And can you actually destroy it? I don't think you can, which is unfortunate, but yeah. Maybe you could. Seek time, play time, paused, detune, volume, loop, then, etc. Can you actually destroy? What about here? Can you destroy it? No, you cannot. So we can at best just pause it. Well, maybe if I look at the destroy. So destroy removes a game object, but what we have here is not a game object. So yeah, let's just work with what we have here. Let's just pause, set pause to true. And then, yeah, I think this should do the trick. And now let's test it out. So I really don't want to... Okay, let's first go back to setting it up to start at the first level. And then here, I load. Can you hear it? Let me make sure that you can hear it. There is this watery sound. It's really low. This is just meant as an ambience. So what I wanted to do to check if everything is correct is I'm just gonna play the whole level. I'm gonna play the whole level and then transition to the next level and see if the sound is still playing. Alright, we don't hear it, but now what I'm gonna do is I'm just gonna die 3 times to go to the GameOver screen. And then I hear it again. Alright, so it works. Let's do this for all of the other sounds. Yeah, the only disadvantage of this approach is I'm wondering, does this get destroyed? I think it does, so that's good. Alright, let's just keep it that way. So for the other sounds, for the second level, we want to play the lava ambient sound. And the sound for it is here, so I'm gonna go here, right above, const, lava, ambience, equal, here, oops, play, the name of the sound, and then an on scene leave. We're just gonna pause it. So just gonna do a lava ambience dot paused equal true. And then finally, for the last level, the wind sound, the third one, we're going to, yeah, I'm just gonna have it here. Yeah, so this simplifies my code a lot. And yeah, I'm glad I thought about this. So wind ambience play. I wrap this. Whoops, I already had the correct brackets here. So, and then finally on scene leave, we just set, whoops, we set the wind ambience to being paused equal true. And that's basically it. Now I'm just going to test this out. So for the second level, can we hear anything? All right, we can hear the sound of the boiling stuff. Now I'm gonna try to beat that second level to go to the last level. Ooh, this was a close call, as I say. Now I'm just gonna, okay, this should be easy for me. For you, might not be. So feel free to simplify the level. Alright, so if the game looks to have a bit of a slower frame rate, that's just my computer. Alright, yeah, we hear the wind sound. I'm hoping this is true for you as well. Yeah, alright, according to OBS, that is. Alright, so I think I'm just gonna try to beat it, and that's basically it. The tutorial is done. I hope you had... Okay, let me just beat it first. Alright. Right. Here, and then finally... need to beat... And I beat it. All sounds are gone. If I click on play again, I'm sent to the menu. Well, I think instead of being sent to the menu, a better approach would be to just be sent to the first level. So that way, yeah, that's more convenient. So here in the display endgame screen, if I go to the UI manager, here in endgame screen, instead of going to the menu, we just go to level 1. Alright, I hope you liked this tutorial. This is it for me. It was a pretty long tutorial. First one I did from, yeah, it's the first one I do this long. I hope you learned a thing or two. If you like this tutorial, this course, feel free to subscribe to my channel. I make JavaScript development, software development content, and maybe I might put out another course you might enjoy. So yeah, thanks for watching everyone, and see you hopefully in another video. Bye.